Hey guys, a very good morning everyone. Welcome all the ISRO aspirants to have a full mock test of 80 questions as per the pattern of ISRO. 80 technical questions. Let's cover all of them, and it's eventually going to be a complete revision for you in that particular sense, because these 80 questions will be from all particular topics of this electronics and communication. Okay, so you'll be in a revision of all of them. So quickly update all your friends that the session is live. They all can join. They all can, join up. Okay, all the ISRO aspirants, and let's get moving ahead. Chalo. Okay, so guys, let's get forward. This is a regular introduction. Okay, let's come here. So dear, okay, whatever we discussed today, along with the questions and the solutions, I'll be sharing you the complete PDF in my Telegram group, so you can be connected in my Telegram group, and for other questions, doubt discussions, updates about the exam also, you can be connected. At the same time, guys, I know, what happened yesterday, the update, the news that came up yesterday has been really disappointing, disappointed students, disappointed all of us. Okay. So all those who have filled up both the forms, that is ISRO and BEL, because eventually they have fallen on the same date. Okay, eventually they have fallen on the same date. That is the 17th of December. Okay, you can, in case if you mailed yesterday, well and good. Otherwise, you can just drop a mail to isropr@isro.gov.in. And simultaneously for BEL, there is no mail ID officially that we could get for complaint, for request actually. But for BEL, you can go to the help desk. Once you log in to download the admit card, there is a help desk. You can raise your query there. I hope somebody will, some or the other body will definitely be listening to you. Okay, and we can get some good updates in the next 2 to 3 days. So let's get moving ahead. Okay, and also guys, as you know, engineering services 2023 results were announced recently. The results are still counting, but yes, as of now, updates is All India rank 1. Okay, Vineet Jain, All India rank 9, Varun Kumar, and not only this, 5 aspirants under rank 10, 29 under rank 50, and 37 aspirants under rank 100. Okay, so brilliant performance by, students who have used the BYJU'S exam prep, on the app. Right, so let's get moving ahead. Now, first question, guys, let me quickly give you the updates first of all. Okay, because this is the ISRO mock test. Okay, because this is the ISRO mock test. Okay, so what are the important updates of the hour? What are the important updates of the hour? Let me give you that first only. Dekho. Okay. We are going to cover exactly 80 technical questions. Clear, everybody? We are going to cover up the exact 80 technical questions. Okay, comprising of all the subjects one by one. Me, Sanjay sir, Saket sir, Ishan sir, we are going to cover up all 80 technical questions. We know this time general aptitude is also there in the, ISRO. So last weekend I took the aptitude mock test, and now this is the complete technical mock test. 80 questions will be there. Okay, from all subjects miscellaneous, and here it is the first question starting for you. Okay, here it is the first question that gets started for you. Yes. A second order system with the 0 at -2 had the poles at -3 plus J4, -3 minus J4 in the S plane. The undamped natural frequency and the damping ratio of the system is respectively how much? Okay. No. ISRO admit cards are not released. It will be released somewhere in first week of December. That's what they updated. Okay. Okay. Chalo guys, so let's get moving and let's get started. Okay, Surajit has the answer already. So, the poles are given to you. The poles are -3 plus and minus J4. Okay, and this can be correlated with the minus alpha plus and minus J omega D. Okay, so definitely we have the alpha, that is zeta into omega n, that corresponds to 3, and omega D is given to you as 4, which is omega n under root of 1 minus zeta square. This is equal to the 4. Okay, the alpha is 3. Okay, acha, alpha is zeta into omega n, and if I look into that, I think probably, sometimes that is what you have to take care in the MCQ questions also. You can take the advantages. So you can take the advantages that alpha, zeta into omega n. Okay, what you need to calculate? Undamped natural frequency and the damping ratio. Question is omega n and zeta. Okay, and there is only one option which satisfies the product equal to 3, so I'll just mark it as option number D. Okay, I'll just mark it as option number D. Clear, everybody? Although, you know, we can calculate both, but not required. So let's go to the next question then. Okay, number 2. Which one of the following statement is correct for the open loop transfer function? Okay, for the open loop transfer function, GS equal to K S plus 3 upon S S minus 1 for K greater than 1. Okay, so you know, option is talking about both open loop system being stable and closed loop being system stable or unstable. System is talking about both. Okay, system is talking about both open loop system and the closed loop system. The open loop system and the closed loop system. So very clearly, dear, very clearly, if you talk about the poles, of open loop transfer function, that is the open loop poles, and they are 0 and plus 1, and there is a RHP pole, and if there is a RHP pole, system will be unstable. If there is a RHP pole, system will be unstable. The open loop is unstable. What about the closed loop? Okay. What about the closed loop system? Okay, for closed loop stability, you can directly check the characteristic equation. What is the characteristic equation? 1 plus K S plus 3, 1 plus GSHS, na? 1 plus K S plus 3 upon S S minus 1 equal to 0. Okay, and you don't even need RH because, you know, this is S square minus S plus KS, so I can write it as K minus 1 into S plus 3K equal to the 0. Okay, and because it is second order, we don't need the Rautherwitz. Now, for second order, only coefficients sign will matter here. Okay, so look into it. Given that K greater than 1. Okay, so S square coefficient positive. If K is greater than 1 means it is positive only. No? It's greater than 0 also. So this is also positive. And K greater than 1 to K minus 1. Okay, K greater than 1 clearly means K minus 1 is positive. So all coefficients are of same sign. And for second order, when all coefficients are of same sign, system is stable. For second order, we don't need Rautherwitz criteria. So closed loop is stable, but open loop is unstable. Option number B. Okay. That goes with the option number B. Okay, next question, dear, ready for you. Which one of the following transfer functions represent the Bode plot as shown in the figure? Okay, where K is constant. Where K is constant. Okay. Which one of the following transfer function represents the Bode plot as shown in the figure where K is constant? Tell me. Okay, a very simple, simple question it is, because you are able to see that initial slope is positive. Okay, what is the initial slope here? The initial slope is 40 dB per decade. Okay, that is 40 dB per decade. And initial slope positive means there are zeros at origin. Let's say M zeros at origin. Okay, initial slope is positive. Okay, so M is equal to 2. And what is this 2? M is equal to 2, and 2 means what? Zeros at origin. So you have the M equal to the 2 zeros at origin. Okay. You have the 2 zeros at origin. Number 1. Okay. Next. Okay. 2 zeros at origin. So definitely all options are there with S square. But look at this point. Okay. Look at this point. What is happening here? The slope was 40. Now becomes minus 60. Now it becomes minus 60. So some of you are coming up with option number C. Great, great, great. Okay, yes, Suraji, Sonali, MDR, correct answer. Okay. No, Senu, it is a scientist examination for ISRO. Okay. That is for technical branches. Now, dekho, have a look into it. How much is the slope change here? The slope prior to it is 40. Now it becomes minus 60. So the slope change is minus 100. Minus 100 dB per decade. Okay, and due to a single pole, the slope changes by 20. So this corresponds to 5 poles. Okay, this corresponds to 5 poles at the frequency omega equal to 10. 5 poles at the frequency omega equal to 10. So 1 plus st, time constant is given by 1 upon corner frequency. The time constant will be 1 upon 10. So that is why we have 1 plus s by 10 ki power 5. Okay, option number C. Option number C. Clear, everybody? Right, G. Okay, option number C. Okay, let's get moving ahead to the next question then. Okay, Nyquist plot. From the given Nyquist plot, calculate the number of open loop poles. What we need to calculate? number of open loop poles on the right hand side of the S-plane. Number of open loop poles on the right hand side of the S-plane are known as the P plus. And by looking into the Nyquist plot, let us calculate. Okay, this is infinity. If it is slightly word, let me tell you that. Okay, this has been shown to go tending to infinity. So definitely, if you locate the critical point, the shifted origin -1, 0. Okay, so are there any encirclement? Okay, yes. Okay, this inner loop is not going to encircle, but look into this outer loop, this infinite outer loop. That is encircling the point -1, 0. That is encircling the point -1, 0. And in what direction? This is the encirclement opposite to clock, anti-clockwise direction. Right. So, n is equal to 1 anti-clockwise. Okay, and anti-clockwise means positive only. So, it is +1. So, it is +1. And then I can use the formula n is equal to p plus minus z plus n is equal to 1. P plus is unknown. And okay, we need to calculate the number of open loop poles on the right side of the S-plane, that is P plus, for the closed loop system to be stable. Now, isko dhyan dena. Okay, they are telling that the closed loop system should be stable. That means Z plus should be equal to 0. Because what is Z plus? When you count the encirclement of -1, 0, simple, na? Z plus is known as what? Z plus is the roots of 1 plus GSHS. It is the zeros of 1 plus GSHS. That means roots of characteristic equation. And for the system to be stable, okay, roots of characteristic equation in the RHP, okay, should be 0. Plus, I write Z plus for RHP only. Okay, so that should be 0. Clear? So, Z plus is also given to you indirectly, and hence P plus should be equal to 1. My correct answer is option number A. My very correct answer is option number A. Done, hai ji? Yes, correct, MDR, Surajit, Bhanu Prakash, correct. So next question. The characteristic equation of a closed loop control system is given to you. S square plus 4s plus 16 equal to 0. What is the resonant frequency? What is the resonant frequency? Okay, the question is about resonant frequency. And from this given data, okay, what is this? This is omega n square, that is 16, and hence omega n, the natural frequency of the system is 4, and then the coefficient of s, that is 2 zeta omega n is 4, so 2 zeta omega n was 4. Solving this, I get zeta is equal to the 1 by 2. Okay. Solving this, the zeta is equal to 1 by 2. Okay, now zeta is 1 by 2, that is of course 0.5, okay, and that is less than 1 by root 2. Because for, resonant frequency and resonant peak, resonant frequency bola yahan pe, okay, you have to take care whether zeta is less than 1 by root 2 or not. Okay, because the formula is, okay, for resonant frequency, omega r, it is given by omega n into under root of 1 minus 2 zeta square. Omega n under root 1 minus 2 zeta square, right? If zeta is less than or equal to 1 by root 2, right? Otherwise, the resonant frequency is simply 0 for any value zeta greater than 1 by root 2. So yes, here it is less than 1 by root 2. So we can now go and calculate. Omega r is omega n, that is 4 under root of 1 minus 2 into zeta square. Zeta square would be 1 by 4. Okay, so that becomes 2 by 4. That's half. So 1 minus half is half. So again, it's going to be 1 by root 2. Solving it, this should be 2 root 2. Okay, 2 root 2, option number D. Okay, 2 root 2 radian per second. Okay. Acha, suppose if they ask the MR. Suppose if they have also asked the MR. Come on, dear. Agar MR pucha hota by chance, resonant peak for the previous question. Okay, what it is going to be? Resonant peak for the previous question. The resonant peak for the previous question. Okay, so what is the value of zeta? Zeta is also known as cos phi, and zeta is given by cos phi, and that is half. So phi should be actually 60 degree, right? MR, now usually you remember MR by 2 formula, 1 upon 2 zeta under root 1 minus zeta square. Again, zeta is greater than equal to 1 by root 2, or otherwise the resonant peak is 1. Sorry, ye less than tha. Okay, and zeta greater than 1 by root 2, it is 1. But simplified way of writing MR, Okay, simplified way of writing the MR is given by 1 upon sine 2 phi. Zeta is cos phi, so accordingly we write down. Okay, but for this, phi should be greater than equal to 45 degrees. Zeta less than 1 by root 2. Otherwise, for phi less than equal to 45, phi less than 45 degree, it will be taken as 1. It will be taken as the 1. Okay. So here, what is the value of phi? 60 degree, which is greater than 45 degree, and hence simple way of calculating MR is 1 upon sine 2 phi, that is 120 degree. Okay, sine 120 degree is like sine 180 minus 60, sine 60 degree, and that is root 3 by 2. So MR is going to be 2 by root 3. In addition, we have just calculated, okay, the MR will be 2 by root 3. Resonant frequency bola tha, so that was anyways completed, and the answer is 2 root 2. The answer is known as the 2 root 2. Okay. For the omega. If they ask MR, it is 2 by root 3. Next question. Consider two control systems, okay, with the following transfer function. Okay, GS is 1 upon 3S plus 1, and the next GS is 1 upon S plus 1. That is the system 1 and system 2. Okay, they want to compare the bandwidth of the system, whether they have the same bandwidth or whose bandwidth is greater. First order. It is basically first order. Okay, when you have any first order transfer function, 1 upon 1 plus st, t is the time constant and bandwidth is given by, okay, bandwidth is directly the 3 dB bandwidth basically. When I talk about this bandwidth, it simply means 3 dB bandwidth, and that 3 dB bandwidth is actually given by reciprocal of the time constant. Reciprocal of the time constant, right? So that means in the first case, what is the time constant? 3. In the second case, it is 1. Okay, so time constant 1, I can say that, let's say this is T1 and T2. T1 is greater than T2. So bandwidth for the first one is going to be less than the bandwidth because it is inversely proportional. Na? Okay, for the first one, it is less than second one. The second one greater, option number B. Bandwidth of system 2 is greater than that of the system 1. Bandwidth of the system 2 is greater than that of the system 1. Hanji. Option number B, correct. Yes, MDR, Surajit. Chalo, correct. Next question. Number 7. The state space representation of a system is given to you. Okay, the state space representation of a system is given to you. X dot is equal to AX, Y equal to CX. Okay, when X naught, initial condition is 0, 1, what is the response? Acha. First of all, you should know that the general way of writing the state space model is X dot is equal to AX plus BU. But here it is only given as AX. That simply means what? Okay, it is given to you as only AX. So that simply means that they are talking about, okay, U means UT, which is 0. So the question is talking about the condition of 0 input. Okay, 0 input is given. So what is the response we calculate is ZIR, 0 input response. They are asking the response. Which response? Okay, it is the 0 input response to be calculated for the system. It is a 0 input response to be calculated for the system, correct? It is a 0 input response. Chalo. So how do we calculate the ZIR? Okay, how do we calculate the ZIR? YT. Dekho, Y equation is given to you. Y is equal to CX. What is Y? The matrix C is given to you. 1, 2 and X. X bole to state vector, na? Containing both the state variables. So what is the output YT actually? If you multiply, okay, 1 into X1. So that's like X1T plus 2 into X2. 2X2T. So we need to first calculate X1T and X2T. Okay, how do we calculate X1T and X2T? Okay, uske liye aa jayenge state transition matrix pe. Okay, there is a system matrix A given to you. There is a system matrix A given to you. Okay, because, okay, the solution of the state vector under 0 input condition is given by X dot, directly the solution likhte hai. The solution is given by e raised to the power at into x naught under 0 input. Okay, the state vector is given by e power at into x naught, where e power at is known as the state transition matrix. Okay, this is what is known as the state transition matrix. Okay, Now, how do we calculate the state transition matrix in general? Okay, पहले एक बार recall करें. In general, okay, phi t, which is e power at, is actually calculated by the inverse Laplace transform for Si minus a whole inverse. That is a general formula, but यहाँ पे एक trick apply करेंगे. Okay, it is in general given by the formula Si minus a whole inverse, and then calculate the inverse Laplace transform for this. Okay, inverse Laplace transform for this. Inverse Laplace of Si minus a whole inverse. ठीक है? अच्छा जी. Okay, but यहाँ पे look into the given matrix. In this, if you look into the given matrix, that is 2 0 0 3. Okay, this is 2 0 0 3. 2 0 0 3. Done hai ji? Okay, so what is the e raised to the power at? Okay, whenever the matrix is a diagonal matrix, the state transition matrix, shortcut, because many questions you will find this diagonal matrix. Okay, what is important about this is the given matrix is diagonal matrix. Okay, the state transition matrix is then given by, okay, that will be also be a diagonal matrix, okay, containing, if this is 2, so the element will become e power 2t. Take the exponent of all diagonal numbers, and then this will going to become e power 3t. E power 2t 0 0 e power 3t. Okay, that is what is the state transition matrix. Okay, that is what is the state transition matrix. Now I can calculate the xt. Okay, ye thoda sa better question hai. Previous one was simple. So as I told you, the state vector is phi t into x naught. Okay, phi t has been calculated as e power 2t 0 0 e power 3t multiplied by x naught. X naught is the initial state. Okay, that is given to you as 0 1. What is this x naught? This is known as the initial state of the system. Okay, और कितना था? Once again, that is 0 1. 0 1. Okay, now multiply. Okay, first row e power 2t into 0, then 0 into 1. The first element is 0. Second row with column 0, and then e power 3t. Acha. So as we all know xt, what is the xt? It is the column vector containing both the state variable. Okay, it just contains both the state variables, so that is accordingly 0 and e ki power 3t. Okay, so correspondingly, okay, what is the x1t? If you map, x1t is 0, x2t is e ki power 3t, and the response yt, guys, again look into the output equation. The response was given by x1 plus 2x2. The response was given by the x1 plus 2x2. Okay, and that becomes how much? Okay, x1 is 0 plus 2x2, that is 2 e power 3t. So final answer 2 e ki power 3t. The final answer 2 e ki power 3t. The final answer is 2 e ki power 3t. Okay, that is the option number C. 2 e power 3t, final answer is C, C, C. Done hai ji? Okay, good hai. Okay, next question. Okay, moving ahead to some questions from signals. Okay, the fundamental frequency of the signal is given to you, cos pi by 4n plus sin pi by 8n. Okay, what is the fundamental frequency of the given signal? Right, first of all, discrete time, so sometimes you have the risk in discrete times. Okay, periodicity is not always ensured for individual signals only. But yeah, look into this. What is the 2 pi by omega? Okay, this has the omega 1, which is pi by 4. Okay, so what is the 2 pi by omega? That is 2 pi upon pi by 4. Pi pi cancel करके ये आ गया 8. Okay, that is given as 8. Okay, that is a rational number. Okay, and also an integer. The first time period is 8. Okay. Also, what about the second one? Omega 2 is pi by 8. Okay, so what is 2 pi by omega for periodicity in discrete domain for sinusoids? Okay, the 2 pi by omega should always be a rational number. Not necessarily integer, but it should be a rational number. And rational number is one which can be expressed in the ratio of two integers. So ye bhi rational hai. 16 is like 16 by 1. And if it is directly an integer, then that is the time period also. Okay. 16. Okay, so what is the final time period? Okay, what is the final time period? What is n1 by n2? 8 by 16. या LCM भी ले सकते हैं. Okay, directly we can talk about the final time period when two signals are added. Okay, the final time period is n1 by n2 because it is discrete time. देखो, if it is continuous time, differences क्या होते हैं? If it was continuous time, then addition of two periodic signals may not be periodic always. For their T1 by T2 we check. But in discrete time, okay, because both the time periods are integer, na, so n1 by n2 will always be rational. So we don't check, we directly go for the answer. LCM of 8 and 16 is going to be 16. Okay, the time period is 16. Okay, अच्छा fundamental frequency बोला है. Okay, then तो I think नहीं, fundamental time period ही होगा, otherwise options will not match. This is the time period only, and frequency if they want, that is going to be finally pi by 8. No. So it's fundamental period only, otherwise options will not match. I think there is a typo error here. Okay, we are looking for fundamental period only. Otherwise the options will not match. Okay, the 16 is the answer, considering the fundamental period as the question. Correct, Suraji, then MDR. Correct, AG. Next question. Number 9. Convolute un plus 1 and un minus 3. Simple question. Convolute xn is equal to un plus 1 and hn is equal to u of n minus 3. So dear, what is the first of all result that you can put down is un convolution un. What is un convolution un? What is un convolution un? Step convolution step in discrete domain is rn plus 1. देखो continuous में result different होता है. Okay, continuous में, okay, step convolution step is exact ramp. Ut convolution ut is rt in the continuous domain. In the discrete domain, it is un convolution un is equal to rn plus 1, the shifted ramp signal. Okay, now we apply the properties. So u of n plus 1, time shifting property, convolution with the u of n minus 3. Okay, will become how much? N. Both the parameters will be affecting the output here. N. So n plus 1. Then यहाँ पे n minus 3. So minus 3 will also come up here. And then in addition ये plus 1 तो है ही. Okay, I am changing n plus 1 and minus 3. Okay, so hence my final answer should be r of n. Okay, 1, 1, 2, minus 3, n minus 1. It should be r of n minus 1. N minus 1. Option number B. Yeah, that's what you have to be careful here. It's option number B. That is r of n minus 1. Okay, r of n minus 1. No, guys, not r of n minus 2. See, this question easily making you commit the mistake. MDR and Sonali, just recheck it is r of n minus 1. Because un convolution un is rn plus 1. Okay, if you just take it as rn, then we get a wrong answer. ये भी ध्यान रखना होगा. The correct answer is rn minus 1. Okay? Okay, everybody, take care about the important points. Now, number 10. Number 10. A signal is given to you, xt is equal to 1 for mod t less than 1, xt is 0 otherwise for mod t greater than 1. Okay, if I try to sketch this signal, dear, xt is 1 for mod t less than 1. Okay, magnitude of t less than 1, matlab t can be anywhere between minus 1 to 1. T is between minus 1, 7. Okay, t is between minus 1, 7. Okay, so what is the signal actually given to you? What is the signal actually given to you? It is a rectangular pulse, and we commonly line the rectangle pulse as rect of t by t, where the t, the capital T represents the total width of the rectangle. Okay, the rectangle is centered at origin, but the total width is equal to 2 units. Okay, that is the duration. So I'll write it as rect of t by 2. I'll write it as rect of t by 2. Clear? This should be the rect of t by 2. Now, what is the Fourier transform of the convolved signal x2t convolution xt by 2? Now, don't think that you have to convolute it. That will make your process lengthy, because if you do x2t, listen to me, if you do x2t is scaling, compression, xt by 2 is expansion. Okay, if you compress and if you expand, compress करने पे इसका width 1 हो जाएगा because compression is by 2, expand करके width will be 4. So there will be 2 rectangles only, but of unequal duration. These two will be 2 rectangles of unequal duration, and whenever you convolute 2 rectangles of unequal duration, you get a trapezium. and then you calculate a Fourier transform of the trapezial shape, very big approach, very lengthy approach. But rather than if I use the Fourier transform property, it is going to be simple. Why? Because xt is one of the very important signals whose formula you must know. Rect of t by t. Okay, पहले मैं formula लिख देता हूँ आपको. What is the formula that you must know? Very very important formula related to it. Lots of question can be there. Rect of t by t. Okay, t as I told you is the width. Okay, is given by t sampling omega t by 2. Okay, this can be written in the form of sampling function. It can be written in the form of the sampling function. ठीक है जी? Okay, so t sampling omega t by 2. Okay, so here what is the xt given to me, dear? That is rect of t by 2. Okay, so what is going to be the x omega? Okay, capital T ka value 2 rakha, and that is going to be 2 sampling, 2 se 2 cancel, 2 sampling omega. At the end we know what is sampling theta is sin theta by theta. Okay, so we can also call it as 2 sin omega by omega. Okay, because eventually options are in the form of sine, not in the form of sampling. Okay, now let's come to the question. Yt is x2t convolution xt by 2. So their property of Fourier transforms will be used. X of 2t convolution x of t by 2. Now dear, what is going to be its Fourier transform y omega? First of all, time scaling property क्या बोलता है? X of at will have the Fourier transform 1 upon modulus of a x of omega by a. If a is negative, so you take the modulus of a, and here a negative है तो as it is रखेंगे x of omega by a. So x2t, the Fourier transform will be 1 by 2 x of omega by 2, number 1. For second one, x of t by 2, so 1 upon half will become 2, and then x of omega by half, so that will be x of 2 omega. Now, what is the convolution property of Fourier transform? Whenever signals are convoluted in time, okay, they are multiplied in frequency. The Fourier transform will be multiplied. So mixture of good properties. One important formula for rect. Okay, then scaling property, convolution property, all this coming up here. Okay, 2 se 2 cancel kiya, so answer is simply x omega by 2 into x2 omega. Put down the value of x omega. Okay, so first one is going to be 2 sine omega by 2. First one is omega by 2. Okay, then divide by omega by 2, and next is sine of, okay, x2 omega, तो 2 भी आएगा, sorry यहाँ पे. तो next is going to be 2 sine 2 omega divide by 2 omega. Writing down the final answer, dear. ये final कितना हो जाएगा? Okay, so this 2 omega and these two cancel. Okay, there will be 2 2s are 4. Okay, sine omega by 2, sine 2 omega, and denominator whole divide by omega square. Okay, denominator whole divide by the omega square. That should be the last answer. That should be the last answer. Now let's check up the option. 4 sine omega by 2 sine 2 omega upon omega square. Option number A, straightforward. Okay, but good question. Decent question on Fourier transform, I can say. Chalo ji, next question. Consider the following cascade of two subsystems with the impulse responses h1t is equal to minus h2t is 1 by 2t. What is the step response of the overall system? What is the step response of the overall system? See guys, what is the h1t? Impulse response of the first system itself, you see, is 1 by pi t. Is 1 upon pi t. Is 1 upon pi t. Whose impulse response is 1 upon pi t? Whose impulse response is 1 upon pi t? Tell me. It is basically Hilbert transformer. Okay, the impulse response is 1 upon pi t and the system is the Hilbert transformer. Pi by 2 phase shifter. It's a pi by 2 phase shifter. It's a Hilbert transformer. Okay, now h2t. Okay, minus h2t is 1 by pi t. h2t is like minus h1t. Let me put it like this. Okay, negative of the Hilbert transformer. Now, when two Hilbert transformers, forget the negative sign for a moment. When two Hilbert transformers are cascaded, what happens? Okay. When two Hilbert transformers are cascaded, what happens? Okay. 180 degree phase shift comes. Whenever two Hilbert transformers are cascaded, you get the response that is known as minus xt. You get the output 180-degree phase shift, na? 180-degree phase shift. Okay, suppose I just cascade two Hilbert transformers, H1T and H1T. Okay, if these two were cascaded, then the response is minus ht because that is a 180-degree phase shift, na? One Hilbert transformer gives 90-degree phase shift. Okay, but what is the story here? Okay, so what is the story here? One of the system has H1T, another has minus H1T. H2T ko hata dete, let us only write minus H1T. Okay, so because of this additional minus, what is going to be the output? What is going to be the output? It will be again shifted by minus, so that's simply equal to the xt. That's simply going to be the xt. Okay. Now, what is the step response? Now, they have not asked the impulse response. Be very careful about the words. They are asking the step response. Okay, they are asking about the step response. Okay, step response means the output of the system when the input applied is unit step. Okay, but input and output match. Okay, so what is the output? Yt is equal to xt, so that is also going to be ut. That is also going to be ut. What is the step response? Response when the input is step, output will also be step. Option number B. Okay, the step response is step function. If they ask the impulse response of the overall system, then it is impulse function. Okay, so be careful. The answer is not impulse here. Okay, the answer is step here. Okay, ji? The answer is a step function here. Any doubts you can ask me. Okay. So this one is slightly related with the Hilbert transform, but that's okay. Also at the end you can know that why it gives minus xt. What is the Fourier transform of 1 upon pi t? In frequency domain, this is known as minus j signum omega. Okay, so this is also minus j signum omega. मैं ऊपर वाले की बात कर रहा हूँ. Okay, now in the time domain, impulse response are convoluted for cascading. Okay, ठीक है. Which one आकांक्षा? कहाँ से? कौन से second step से? So when you multiply in the frequency domain, there is multiplication. So what do you get? Minus of j square. Signum square is 1. Okay. Minus of j square is... Okay. Sorry. Minus be plus. Okay. It is only j square and j square is minus 1. That is why you get the final minus in the output. Okay. These are standard results. Anyways, no need to derive that what happens when Hilbert transformers are cascaded. Dekho. So in second, what I have done is, the first idea is this is the standard result with Hilbert transformer because it's like, ये तो हो गया Fourier transform calculation. Logically also you can say na Hilbert transformer is 90-degree phase shift. So if you are putting two in cascade, so that is a 180-degree phase shifter. Okay, 180-degree means introducing a minus sign because if the phase is 180-degree, we write e power j pi and e power j pi is minus 1. If the phase is 180, e power j theta is pi, that is minus 1. This is clear. But now in the given question, okay, one of them is H1T, that is 1 upon pi t, that is the impulse response of Hilbert transformer. Another one is minus H1T. Okay, so because of this additional minus, what will happen? The output will be further minus of minus xt, that is plus xt. So in the second case, yt is equal to xt. That's what I'm trying to tell you. Okay, so done hai. Let's move ahead to the next question now. Here it is. If xn is 1 by 3 power mod n minus half power n un, then the ROC, region of convergence of it, the Z transform will be. Okay. See dear, okay, if it is a power n un, okay, if it is a power n un, let me write down the ROCs, important ROCs. It is mod Z greater than mod A, right? If it is the a power n u minus n minus 1, okay, then the ROC is given by interior of a circle, defined by the interior of the lowest pole, mod Z less than mod A. Okay, and then if it is a power mod n, okay, then the ROC is given by what? Then the ROC is given by mod A less than Z less than modulus 1 by A. Okay, mod A less than Z less than modulus 1 by A, but here there is a condition. Okay, that modulus of A should be less than 1. If modulus of A greater than 1, then there is no ROC. Okay, for A power mod n, and no ROC means Z transform for this signal will not exist. Okay, so now what is the answer? As per the given question, okay, what is going to be the ROC for half power n un? Mod Z is greater than mod A, that is half. Okay, for 1 by 3 raised to the power mod n, okay, it is going to be 1 by 3 is less than the mod Z is less than the 3. So now if I combine both, then what is the answer? Okay. So whenever two signals are added or subtracted, you will take the intersection. Nah? Okay. So what is the final answer? Okay. So let's take it here. Okay. What should be your answer? Your answer should be of the form such that mod z greater than half and 1/3 less than mod z less than 3. Both of them are satisfied. Both of them are satisfied. Intersection. Okay, so greater than half and one of them is 1/3 से 3. 1/3 तो पहले आएगा, sorry. This is 1/3, this is 1/2 and this is 3. Okay, what you want? Okay, you want greater than half also and you want between 1/3 से 3 also. So what is the common portion? Okay, 1/2 से 3. 1/2 less than the mod z less than the 3. Okay, it's going to be 1/2 less than mod z less than 3. Okay, that is option number C. Correct. Yes, MDR and Akansha, correct answer. It is option number C. It is option number C. Done. 13. A 5-point sequence is given to you. X minus 3, X minus 2, X minus 1, X naught and X1. Let X e power j omega denote the discrete time Fourier transform dtft of Xn. What is the value of integral X e power j omega d omega? What is the value of this integral? Okay, that is the dtft of Xn. X e power j omega is the dtft of Xn. Okay, what is the dtft formula? And one simple property is being used here. X e power j omega, and let's simply call it as X omega. Okay, that is given by summation of Xn e raised to the power minus j omega n for all values of n in general. Okay, then what is the IDTFT formula? IDTFT formula. Xn 1/2 pi integral over one time period. DTFT is always periodic with the period 2 pi. Okay, so 1/2 pi integral over 2 pi x of omega e power j omega and d omega. Okay, so now area under the Fourier transform. Okay, integral minus pi to pi, that is integral over 2 pi, integral over the total range of 2 pi x omega d omega. Okay, what is x omega d omega? Okay, that is taken by putting n equal to 0. That is obtained by putting n equal to 0. If you put n equal to 0, there it is the e power 0 which is equal to 1. Okay, so my final answer is 2 pi into x0. The value of the signal x0 at 0 is 5. Okay, and the answer should be 10 pi. It's B. The correct answer should be B. Okay. Yes, MDR and change the name. Correct answer is B. The correct answer is B. That is 10 pi. Okay, G. Next question is here for you. The direct front structure of a FIR, finite impulse response filter, is shown in the figure. The filter can be used to approximate what? Low pass filter, high pass filter, band pass filter, band stop filter. Okay, the first let us identify what is this FIR, finite impulse response. Filter can be used to approximate what? Low pass, high pass, band stop. So देखो, let us first calculate the impulse response or the Z transform, something here at least. Okay, so let us say if this is Xn, Xn has the Z transform Xz. Okay, now unit delay. Okay, unit delay means, okay, what is the Z transform delay system? Yeah, you can solve in the time domain also. Unit delay means what comes up here? This is Xn, na? Okay, this is the only gain multiplier. So here you have 5xn. This is unit delay, that is xn minus 1. Another unit delay, so total it becomes xn minus 2 and now multiplied by 5. So what is the final output equation yn? That is going to be from plus side it is coming 5xn and on the negative side 5 times of this one, 5 times of the 2 units delay actually. Okay, now you can convert it into the Z transform. Okay, now you can convert it into the Z transform or DTFT, whatever you want. Okay, so if suppose if I calculate to the DTFT y omega, so that becomes 5 xn DTFT x omega minus 5 property x omega e power minus j2 omega. Okay. Right. So what is the transfer function? It is given by the ratio of output Fourier transform to the input Fourier transform. That is x omega divided 5 commonly 1 minus e power minus j2 omega. Okay, 5 1 minus e power minus j2 omega. Okay, now let me check the result for low frequency. Okay, what is the low frequency? Omega 0. At the omega 0, what is going to be the gain? Let us say this transfer function is h omega. Let us say the transfer function is h omega. So what is the value of h0? That is 5 1 minus omega 0. So e power 0 is 1. So low frequency gain of the system is 0. It cannot be low pass filter. Okay, high frequency. High frequency in discrete domain is omega equal to pi. It's omega equal to pi. Okay, so what is the value of h pi? 5 1 minus. Dekho, e power j2 pi is also 1. E power j2 pi is also 1. So it is also 0. So it is neither low pass nor high pass. So we go for the intermediate frequency calculation then. Any intermediate frequency, but commonly we take pi by 2. Commonly we take pi by 2. You can take other intermediates as well. So what is the gain of the system at pi by 2? That is going to be 5 1 minus omega rakha pi by 2. So that becomes e power minus j pi. And what is the value of e power minus j pi? Is minus 1. Okay, that is minus 1. So 5 1 minus 1, that is 5 into 2. That is known as the 10. That is known as the 10. Okay, so now if you just try to, sketch this waveform, now how it is going to look like. Okay, let's try to sketch the mod of h omega. Okay, at low frequency, you got 0. High frequency also you got 0. And intermediate frequency, the gain was obtained as 10. Okay, I have taken the intermediate frequency as pi by 2. Okay, and the gain at pi by 2 is suppose 10. So filter is roughly showing the characteristics that, at low frequency gain is 0. It rises to the 10. Okay, and beyond that, if you calculate, that's again going to be decreasing, and at pi it will again come to be 0. Okay, so what type of characteristics are shown here? Okay, I can say that in a particular range, so here we can calculate the 3 dB bandwidth and all again, but in a particular range, okay, the gain is more, and these set of frequencies are passed, okay, by the system. Okay, a band pass. It is just a band pass characters. These are the band pass characters. Band pass. Option number C is the correct answer. It is the option number C which is the very correct answer. Okay? Band pass. Next question. 15. What is the 4-point discrete Fourier transform DFT? Okay, of the discrete time sequence 1 0 2 3. Dekho, what you can do here, na, especially in MCQ questions. Okay, what can be done especially in the MCQ question? Dhyan dena. Okay, what can be done especially in the MCQ question? So when you just want to calculate the DFT in general, okay, the xk is given by the formula summation of xn, okay, from n equal to 0 to n minus 1, we take finite length signal, summation xn e raised to the power minus j 2 pi by n into kn, or we also write down e power minus j 2 pi by n. Okay, we denote it as the twiddle factor, that is wn, and then the DFT xk is also written as summation of xn wn power kn. Okay, from n equal to 0 to n minus 1. Okay, we can calculate on the basis of this, but always remember, okay, always remember that if you take k equal to 0, starting at the intermediate point property, x of 0, w power 0 is anyways going to be 1, so you only get summation of xn. Okay, summation of xn से मेरा मतलब है it is going to be addition of all the values like x0 plus x1 etc. x1 plus x2, just addition of all the values up to the last value given. Okay, if you take the central ordinate n by 2, talking about n point DFT, take the n by 2 point. So when you take the n by 2 point, you get the result x of n by 2. Okay, putting down the value of n by 2 here, you will get what? N by 2, n cancel, 2 cancel, e power minus j pi n, and e power minus j pi is minus 1. Okay, so what you are left with is summation xn minus 1 ki power n. And when you solve minus 1 power n will keep alternating with sign. Okay, plus minus e power minus 1, minus 1 power even is plus 1, minus 1 power odd is negative. Okay, accordingly dear, this is given by x of 0 minus x of 1 plus x of 2 minus x of 3 and etc. 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 Okay, that is what is actually given. Okay, this is what is actually given. So, let's see if we can directly work out by this, if by chance, otherwise we'll do more calculation. So, sabse pehle, if I calculate x0, so 1 plus 0 plus 2 plus 3, that turns out to be 6. Okay, so that is either option number C or D. Okay, then I go to the central ordinate, that is x2, because the central ordinate is n by 2 and we are talking about 4-point DFT. Okay, we are talking about 4-point DFT, and as I told you, that is alternate plus minus. Okay, so 1 minus 0 plus 2 minus 3. So this becomes how much? Minus 3 plus 2. This is minus 2. Now out of these two, minus 2, one second. 6 and 6, and then I've done any mistake. 1 0 2 3. So 1 minus 0 plus 2. Acha, 0 hi to hai, sorry. Yeah, that's 0 only. 1 plus 2 and then minus 3, 0. Okay, now I'm only left with option number D. That's what you can utilize here. Okay, so now we are left only with option number D, and that is my correct answer. If not, okay, then we can calculate any other value. Okay, like x1. x1 and x3 will be conjugate of each other due to conjugate symmetry property. Okay, so being from EC, DFT questions are expected. Okay, and with some addition of properties, you can try to make it simple. DFT you must study thoroughly. That is a very, very important topic. Okay, ji. Chalo ji, next question then ready for you. Okay, let A is a m cross n matrix with m greater than n, and I is the identity matrix. Okay, let A1 equal to A transpose A inverse into A transpose, then which of the following statements is false? Okay, some mathematics question also we will see now. Which of the statement is false? What is A1? A transpose A whole inverse A transpose. But whenever you apply inverse onto multiplication, that is operated actually reverse. So first A inverse, then A transpose, then A transpose inverse and A transpose. Acha. A matrix and its inverse are together multiplied. A transpose inverse into A transpose. That should be identity. Okay, that should be identity. A inverse into identity, and that is A inverse. Okay. So A1 should be A inverse. Okay, now which of the options are correct? Okay, which of the options are correct? One by one. Okay, one by one. Let's keep checking. Option number A. A1, A. A1 को रख देंगे A inverse. Okay, so A inverse A. A into A inverse is identity. Okay, so you are left with A into A inverse cancel. Okay, chalo. So A option is correct. We have to select the false option. B. A1 whole square. What is A1? Okay, A into A1. Okay, so that is A into A inverse. A into A inverse is I square is I. Okay, and AA1 is also I, correct. So this is also equal to AA1. Okay, that means B option is also correct. C to correct hai. A into A1 is like A into A inverse, and that is identity. Okay, D option. Okay, so D ही बच रहा है जो wrong होना चाहिए. अच्छा, D तो wrong हो गया ना, because A1A is equal to A. Okay. Option number D में directly I can now say A1A is equal to A, that is not equal to A1. ये दोनों linked हैं. ठीक है, तो correct answer is D, which is the false. We have to choose the false statement. Use a false statement. Correct. The false is D. Yes, NGC Anakansha, correct answer. Yes, NGC, I'll check up and I'll put the pending PDFs, in some time. Consider an unbiased cubic dice with the opposite faces colored identically and each face colored red, blue and green. Okay, such that each color appears only 2 times on the dice. Okay, so there are 3 pairs of opposite dice, na? There are 3 pairs of opposite faces. Okay, and there are 3 colors, red, blue and green. Red, blue and green. If the die is thrown thrice, what is the probability of obtaining red color on the top case? Probability of obtaining the red color on the top face, okay, at least twice. At least twice. You can solve by binomial or you can solve directly also. Okay, agar मैं single toss करूँगा, very simple, you can solve it directly also. If I do the single toss, okay, what is the probability of getting the red? Okay, so how many red? Red is there on the 2 faces, favorable 2 divided by total 6. So probability of getting red colored face is 1/3. Okay, probability of getting the red colored face is 1/3, number 1. Okay. Probability of getting the red colored face is 1/3. Chalo, next. Okay, now if the dice is thrown thrice, okay, so then what is going to be the answer? Okay, the red should be at least twice, 2 or 3. So suppose red is twice, okay, so red is 1/3, okay, into 1/3, 2 times, and other time it is not red. What is the probability of not red? It is 2/3. Dhyan dena. What is the probability of not red? It is 2/3. So red, red and not red. But ये जो not red है, it can be anywhere, na? Maybe third one is not red, maybe first is not red, maybe second is not red. So this will have 3 cases. Actually 3C1. Actually 3C1. Plus, I told you, red should be at least twice. So first I took 2 eyes. Then I'll take thrice also, at least twice. So 2 or more than 2. So red can be there thrice also. All the 3 times you get red. 1/3, 1/3, 1/3. Okay, so once you solve it up, definitely denominator is 3, 3, 3, 27. Okay, but this is 2 3s are 6 and plus 1. The answer is 7/27. Okay, 7/27. And guys, this is nothing. Okay, this is nothing. I have solved directly, but this is what itself is the binomial formula. This is what is the binomial formula itself. Okay, NCR. You want red, suppose R times or K times, so NCK. Okay, probability of red is 1/3, 1/3 power K, 1/3 power 2 into 1 minus P, probability of not getting red into N minus K. This is binomial formula, but it was a simple small data question, so I just solved it by the logic. Otherwise, it can be done by the binomial formula as well. Okay, ji. Anyways, the correct answer is option number A. Please check. It's 7/27. Okay, it is 7/27. Okay, ji. Next question. Okay, number 18. Consider the function 2x cube minus 3x square in the domain -1, 2. What is the global minimum of fx? What is the global minimum of fx? Come on. What is the global minimum of fx? Okay, so we need the global minimum, okay, not the local minimum. But yeah, what is the procedure? If you have followed earlier classes, I have told you straightforward gate as well. Okay, so for stationary points, calculate f dash x, that is 2 3s are 6x square minus 3 2s are 6x equal to 0. So 6x common into x minus 1 is 0. So solving which you get stationary points as 0 and 1. Okay, now what you do is the direct shortcut is calculate the value of the function at the end points and at the stationary points. Stationary points given in the stationary points which are in the given domain. So here both are in the given domain. Okay, both are in the given domain. So I start with the end point f minus 1, then stationary point f0 nikalenge, then at 1 f1 and then at 2 f2. Okay, so minus 1 ka cube is minus 1, so minus 2 and then minus 3. This is minus 5. Okay, f0 is simply 0. f1, that is 2 minus 3 is minus 1. And f2, okay, that is 2 into 2 cube, that becomes 16. Minus 3 into 2 square. Okay, so 2 square ka value 4 and 3 4s are 12. Correct. and 2 into, correct. So this is equal to 4. So they are asking what is the global minimum? Okay, what is the global minimum? So this will tell you everything, because the global minima or maxima, 110%, global minima and maxima is either at the stationary maxima, is either at the local minima, local maxima, or at the boundary points. It cannot be anywhere else. So straight calculation, no need to draw the curve, no need to go for second derivative, yeah, any wavy curve. Okay, directly just calculation. Okay, so what is the global minimum? Okay, the minimum value is -5. Okay, that is at the end point. If they ask the maximum value, that is equal to 4. Both of them are here at the end points, but it can be either at the end points or at the local maxima, local minima point. ठीक है. अच्छा, which out of this is local minima, local maxima? Not required. Don't waste your time there. निकाल सकते but not required. Okay, so global minimum is -5. They're asking global minimum, that is the -5 dear. That is the -5. ठीक है. Be ready for the next question. Evaluate integral x की power 4 fx dx, where fx is 1 upon root 2 pi e power minus x square by 2. Oh, exponential. एक बार put तो कर दे function तो, then we will get the hint how to take it up. Integral minus infinity से infinity x की power 4 fx, where fx is 1 upon root 2 pi e raised to the power minus of x square by 2 for all values of x. ठीक है. That is giving you the hint that the limit is minus infinity to infinity, and if it was by chance minus t, e power minus t, so can be related by gamma function. If it is by chance e की power minus t, then it can be related by the gamma function. Okay, तो यहाँ पे क्या कर देंगे? We can take up the x square by 2 equal to t. If it is e power minus t, then can be related with gamma function. Now, let's try this at least. I'll just put down x square is equal to the t. Okay. I'll be just putting down what x square is equal to t. ये color उतना visible हो नहीं रहा है. Okay, so now let me take this. Let us put down the x square by 2 equal to the t. Okay, so 2x dx by 2. So simply x into dx will be dt. ठीक है. अच्छा, if x square is 2t, okay, let us put this result into the integration. So integral is the integral of the form x की power 4 into 1 upon root 2 pi e की power minus x square by 2 dx. Okay, let me split this first of all. Okay, I have x square by 2 as the substitution. So x power 4, split it in x square. Okay, then there will be one more x, and one more x I will shift with the dx. Okay, इसको थोड़ा सा split करके लिखे, and one x is here with dx, and now try to put the substitution. So what is going to be the value for x square? Okay, so x square will be 2t, and ठीक है, x square will be 2t. Okay, so इसको put कर देते हैं. So then the value of the integral is going to be minus infinity से infinity. X square is 2t. So what is x? Root over this, root over 2t, then 1 upon root 2 pi, then e power minus t, x square by 2 का value t, x dx का value dt. Now it is in the form of e power minus t. Okay, so what are the constant terms you can take outside? Root 2 cancelled. Okay, only 2 outside. Twice integral minus infinity to infinity. Twice integral minus infinity से infinity. T root t will be t की power 3 by 2. T की power 3 by 2. Okay, root 2 cancel. Root pi अभी भी बाहर आ जाएगा. तो 2 upon root pi e raised to the power minus t dt. Now can you solve and tell me the answer? Now can you solve and tell me the answer? Come on. Okay. NGC says 3. Let's check it out. So guys, very soon Sanjay sir is also going to join you. Okay, yeah. Chalo. So let's move forward. Acha, one more thing we can do directly here. Finally, limit is minus infinity, so infinity. And if I'm going to relate with the gamma function, then it should be the limit 0 से infinity. So look into this. यहीं से देख लीजिए. This whole particular function is an even function. This whole function is an even function. Why I can say directly? Because it contains x square and x की power 4 terms only, na? So even if you replace by minus x, it's not going to affect the answer. Okay, so definitely for even function, integral minus a to a is twice integral 0 to a. Rather than checking here, directly you can say here the even symmetry. Okay, twice integral 0 से infinity. Okay, x power 4 into 1 upon root 2 pi e raised to the power minus x square by 2 dx. ठीक है. तो यहाँ पे हम लोग पूरा इसको ट्रेंड को फॉलो कर लेते हैं. Okay, so this is also twice and then integral 0 say infinity. Okay, making it twice again. So this is limit 0 say infinity. So then this should be becoming 4 upon root pi and then limit 0 say infinity. Now it is definitely gamma function. Okay, integral 0 say infinity x power n minus 1 or t power n minus 1. N minus 1 is 3 by 2. So n is actually 5 by 2. Okay. What is the gamma function here? Okay, you are getting the answer as 4 by root pi into gamma 5 by 2 into gamma 5 by 2. Perfect. Because in general, the gamma n is given by integral 0 से infinity e raised to the power minus x, x की power n minus 1 dx. ठीक है. Also remember important values, important results for gamma. Gamma n plus 1 is always given by n gamma n. Okay, gamma n plus 1 will be factorial n if you have, okay, if you have integral value, if n is equal to integer. Okay, and also one more important result, that gamma half is root pi. Three important results you should know with gamma, that is the recursive relation and the factorial relation, that is for integral value of n, and gamma half is equal to root pi. Rahul says 2. Let's check out. Okay, so what is that we have got? We have got the answer as 4 by root t gamma 5 by 2. 4 upon root pi gamma 5 by 2. So what is going to be the gamma 5 by 2? Okay, so देखो, we need to calculate gamma 5 by 2. Split this gamma 5 by 2 as gamma 3 by 2 plus 1. Gamma n plus 1. Okay, gamma n plus 1 is n gamma n. Okay. Now similarly, split this 3 by 2 as 1 by 2 plus 1, and again you have gamma n plus 1. Gamma n plus 1, and that is again n gamma n. Okay, n gamma n, gamma half, which I already told you. Okay, as root pi. So this is 3 by 4 and root pi. So what is the final answer, dear? My answer that I left was 4 upon root pi into the gamma value, that is gamma 5 by 2. Okay, that is known as 4 upon root pi into 3 by 4 root pi. Root pi cancel, 4 cancel. Correct answer is 3 only. Okay, yes Rahul, 3, NGC 3, correct answer. Okay, it's going to be 3. Yes, Sonali says A, correct answer 3. Option number A. But this is a good question. This one is a good question. ठीक है जी? This one is a good question. चलो जी, next question then ready for you. Okay, moving ahead to the next. Right. The value of P for which the vector field 2x plus y I cap plus 3x minus 2z j cap plus x plus pz is solenoidal. Okay, the vector field is solenoidal. So divergence of the vector. This one is simple. Divergence of the vector field del dot v should be 0. Okay, and we know divergence del by del x of the x component, del by del y of the y component, directly लिख ही देते ना. Divergence del by del x of the x component, which is 2x plus y, del by del y of the y component, that is 3x minus 2z, del by del z of the z component, that is x plus pz. Okay, this should be equal to 0. From here we can get the value of P. Simple one. Okay, so del by del x of 2x plus y 2, del by del y लेंगे, that is 0. Okay, del by del z लेंगे, तो that is P, and that is equal to 0. Eventually the value of P is going to be minus 2. Eventually P is minus 2. Correct answer is C. Okay, yes Rahul and NGC, correct answer, it is C. Option number C, minus 2. Correct, Sonali. Okay. That is the minus 2. Okay. So guys, Sanjay Rathi sir will now join, and let me update you that this 6th December, that is Wednesday at 7:30 p.m. all your favorite Abhinav Negi sir going to come and have a special talk, special workshop on GATE 2025. Yes, the time, okay, where several students are thinking, yeah, even started preparing for GATE, but only started preparation doesn't matter. Now, what is the roadmap to be a topper? How to ensure that you are in the topper zone? So attend this free live interactive workshop on this Wednesday. That is on the BYJU'S exam prep app at the 7:30 p.m. Right, you can download the app. There is a link in the description of the video. You just go to the YouTube description and you'll find the link. You can directly download the app from there, or you can also get it from the Google Play Store. Also guys, tomorrow, that is the Sunday. Okay, Sunday 3rd December. Okay, you also get a chance to appear in the National Scholarship Test from BYJU'S Exam Prep. Again, this is on the app, so you can download the app for multiple activities, and based on the performance in scholarship test, you can get as much as up to 90% scholarships on the GATE and ESE full-fledged preparation programs. Okay, and take benefits in your GATE preparation, engineering services preparation, and also guys, All India Open Mega Mock Challenges are live. All India Open Mega Mock Challenges are live on the BYJU'S Exam Prep app. Okay, and now initially we had some full subject test, and now from the next 16 December you are going to have the full GATE official syllabus test. And because these are All India Open Mega Mock, that means they are free, so thousands of students are participating. You also participate and see your results. Okay, in the when the thousands of students are participating, so that also gives you a crystal clear idea. At the same time, if you perform in this test, you can also get huge discounts on the BYJU'S test series part. Okay, so you can get more and more using those test series. Okay, so for multiple of these activities, you can download the BYJU'S Exam Prep app. Okay, and also guys, the full-fledged courses are available for GATE 2025 and 26 on the app, available in both English and Hindi. And for GATE 24 aspirants, a quick revision crash course is also available on the app with the complete syllabus coverage. Okay, these courses will offer you live classes, facility of recorded lectures, study material, mock tests, practice quizzes, everything to get you exam ready. Okay, will be provided by these batches. Okay, so for more details, you can just contact 9241333666 and get all your queries rectified. I'll share you the today's content in the PDF as I mentioned, and now time to invite Sanjay Rathi sir. Okay, so he'll be continuing with question number 21 as I told you. Now question number 21 onwards. Sanjay sir is joining you just in a while. Stay updated. Okay, just stay updated, and in a while he's joining you. Let me just give a call to the sir. Yes. So Sanjay sir will be joining soon, guys. Just stay updated. He'll be joining quickly. So total as per the ISRO pattern, there will be the 80 questions. There will be the 80 questions. Okay, so complete revision, including all subjects, will be there today. All subjects will be there today. Yes. So in case of any doubts, you can ask me. Okay, by the time you can ask me any doubts in case you have. Sanjay sir will be joining shortly. Right, so guys, keep preparing. Let's see what is the final dates, if there is any changes with Bell or ISRO. Okay. Yes, Sonali, in ISRO questions are repeated also, and even previous year questions are also, previous year GATE questions are also found in the ISRO. Okay, so that is why, ISRO, firstly, after you complete the revision, most suggested practice for ISRO is all ISRO PYQs and all the GATE PYQs, including 1 and 2 marks, because ISRO we see some good level questions also. Okay, so all GATE PYQs at least 10-15 years. Let's say keep a target at least 2010 onwards minimum. Okay, and ISRO PYQs. Okay, this is minimum practice set that should be completed for ISRO. Okay, that should be completed for ISRO. Yes, any queries you can keep asking me in any of the questions we discussed, because Sanjay sir is just joining in the next 2 minutes. Okay, let us wait for that moment. Yes, sure, they are helpful. So like today also we have discussed some questions which are straightforward, some questions which are good and they take time. All the straightforward questions are especially helpful for Bell because their number of questions are more and time is less. And even in the previous years we have seen Bell more straightforward questions. But yeah, eventually these questions are helpful for Bell also. Yes, whatever are the important, I think Sakit sir is planning a video onto that already, communication important topics for ISRO and GC. Okay, and anyway, Sakit sir is also joining today, so he'll be guiding you about those important areas as well. Because whatever are the more important and frequent areas, only that we are trying to focus more and more in the mock test also. Okay, so that this mock test also gives an idea ki what topics are being covered are definitely at least important. Right. I'll just check on, guys. I'll just check it out. Just a minute. Yes, dear. So Sanjay sir is ready and now he'll be joining. Just a moment. Hello.
Hello everyone, very good afternoon and welcome to the BYJU'S exam prep. This is Sanjay Rathi and now it is guys ISRO 2023 Electronics Engineering mock test. Already Rakesh sir have taken some important sessions. Now I am going to start with what some important subject like what EDC and then what analog, then digital and what one of the important subject that is microwave. I think everything is fine guys. 1 minute, give me 1 minute only. Yes. Okay, sound quality, picture quality, everything is fine. Okay then guys. Now, some important numericals from 4 subject. This is my introduction. Myself Sanjay Rathi. I am having 23 years of teaching experience and I have trained more than 1 lakh students for these competitive exams and these are my ranks in engineering services exam. And I am an ex-IAS because I worked as Deputy Director in Ministry of Power. To use my experience, I am going to solve some questions with detailed explanation guys. Now, This is my channel Electronics by Sanjay Rathi. So all the students you can join because I will upload the PDF of this session, that is mock test, on my Telegram channel, that is Electronics by Sanjay Rathi. तो राकेश सर थैंक्स. राकेश सर ने काफी अच्छे से आप लोगों को क्वेश्चन सॉल्व करवा लिए. नाउ दिस इज माय टर्न. ओके, this questions helpful for bail exam. Yes, that is also helpful for bail exam, but remember in ISRO calculator is not allowed, and little bit we are getting some lengthy question as compared to what bail exam. Okay, see here, concept and theory will remain same. Then before starting the session, I want to give you one very important information that scholarship test this Sunday, means note the date, right, 3rd of December 9 a.m. to 9 p.m. tomorrow, and get up to 90% off on this if you want to start your journey with us. Right, आ सकते हो आप भी, और this is a golden opportunity for you. A second important thing, one very important workshop by Abhinav Negi sir at 7:30 p.m. on 6th of December, that is on Wednesday. Complete roadmap to be topper in GATE 2025. Okay, so you can join that workshop. You can ask your doubts there. Okay, then please register it for now. But for registration, simply install what BYJU'S exam prep app. Then guys, this is the first question. The use of rectifier filter in a capacitor circuit for satisfactory performance only when the load is. Tell me what is the answer. Tell me what will be the answer for this question. What is the answer for this question? Okay. Now guys, give me what is the answer for this one. And ask your friend to join the session, guys. Okay, what is the answer then? Now watch this. The use of a rectifier filter in a capacitor circuit given satisfactory performance only when the load. What is the meaning of the load, guys? So it is given when we are using the capacitor here. When we are using the capacitor, like this is diode, this is RL, this is a half wave rectifier. Okay, without capacitor we are getting this type of output. Without capacitor we are getting this type of output. This is the half wave. Okay, then we are connecting a capacitor parallel to that, and the value of this capacitor should be very high. Then we are getting this type of output: charging, discharging, charging and discharging. So we don't want that. Once the capacitor will charge, it should remain charged. Then capacitor will discharge through RL. So actually what we want, that this time constant should be very high as compared to time period of the signal. Means C should be high, RL should be high, so that the capacitor, once it is charged, it should not discharge through what? RL. So when the RL is very high, then what about the load current? It is very low. For low load current, this is called load current, IL. So for satisfactory operation for capacitor filter, we want performance when the load current is low. Load current is low, RL is high, and time constant is high. So that the ripple factor is proportional to what? Time constant. If RLC is high, ripple factor will be low, guys. So this is the answer for this question is B. Okay, Sonali and all other students, this is clear to you. So this is the first question from capacitor filter. and that is from the rectifier. Now the next one, next question is, okay, that is again a very important question, just like a ISRO, that is question from diode. It is predicted that for germanium, the reverse saturation current should increase by 0.11 per degree centigrade. What is the 0.11 per degree centigrade? It is a fractional change in the reverse saturation current. It is found experimentally in a particular diode that found experimentally, this is a keyword, in particular diode that at a reverse voltage of 10 volt, the reverse current is 5 microampere and the temperature dependence is only 0.07 per degree centigrade. What is the leakage resistance shunting the diode? So normally in ISRO, this type of questions we are expecting. What is the answer for this one? Is it audible, visible, everything is fine? Give your comments. और भाई जरा आ जाओ, motivate हो जाओ. We are going to solve some important numericals from different subject, EDC, analog, digital and what, microwave. So tell me guys, what is the answer for this one? This is again very important question. So what is the meaning of this? For germanium, the reverse saturation current should increase by 0.11 per degree centigrade. This is the fractional change in the reverse saturation current. That is the theoretical reverse saturation current. Under theory, we have the 11% change in I naught. So what is the percentage change? d I naught by dt upon I naught into 100. That is called percentage change per unit when temperature increases by 1 degree centigrade. This is actually 11% theoretically. So what is the fractional change? It will become d I naught by dt. That is 0.11 per degree centigrade. Okay, theoretically. What is the numerical value? It is found the numerical value is only 0.07. So numerical value means reverse saturation current is different. Practically the reverse saturation current is different. Then it is found that this fraction is only 0.07, means 7% per degree centigrade. This is the value. Why we have this difference? That is a theoretical question. It is based on what? Reverse saturation current across the BJT. Now, and what is the ask here? The reverse current. What is the leakage resistance shunting the diode? 5.5 mega ohm, 5.5 kilo ohm, 20 mega ohm, none of this. Now, we can solve this question. We can solve this question by simply, first of all, understand the concept here. Here, we are having one diode. This is a PN junction. This is a PN junction. And this is reverse bias. When you are making it reverse, just I am connecting a ammeter here. This is reverse bias by 10 volt. So we are having the PN junction. There will be a current that is called reverse saturation current through this junction, I naught. That is the reverse saturation current through this junction, and that reverse saturation current is given by AQdP PN naught upon ln LP plus AQdN NP naught upon ln. This is the formula for the reverse saturation current, where this is the minority charge carrier Ni square by Nd according to mass action law, and NP naught is a Ni square by Na. This is in N type, N side, this is on P side. This is on P side. So this is called reverse saturation current. Theoretically, this is the case. But when we are connecting parallel, actually, we are saying that when the temperature will increase, new hole electron pair will generate and it will increase by 11% per degree centigrade. Okay, theoretically. But numerically, what will happen when we are connecting a battery? On the surface, we have some charged particles. When we have charged particle on the surface, and it will follow the Ohm's law. So that is the battery. So in the direction of the battery, there will be the current. And that is called surface leakage current. This is just I am giving the name IL. That is the surface leakage current. So when we are connecting the ammeter, it will read both the values I naught and IL because they are connected in parallel. So this is the I naught dash. So actually we are getting the I naught dash, that is called practical reverse saturation current, and that is given as 5 microampere. This is given as 5 microampere. Now what is the I naught dash? I naught dash is, now watch this. Here the I naught dash is equal to I naught plus IL. Reverse saturation current theoretical plus IL. But when we are differentiating with respect to temperature, it will affect due to temperature. It will affect due to temperature, but this is the effect of the temperature on the leakage current is 0. That's why 0. So we are getting a new term, d I naught dash by dt up is equal to d I naught by dt. So what is asked in the question? What is the shunting resistance? So shunting resistance means this is the diode. We are having a resistor parallel to that, and that is called because of the surface leakage current. Now we are having the battery. So one current will flow, this is called I naught, and one current will flow, this is called IL, and that is the 10 volt battery. RS is required. So RS is nothing but applied voltage divided by what? IL. Applied voltage divided by IL. This is called shunting resistance. So one by one you will get the question, what is the shunting resistance? 10 volt divided by IL. Now we have to find IL. This is the I naught dash, I naught plus IL. It is given as 5 microampere. Now if you have the value of I naught, you can find the IL. How we can find the I naught? Now guys, remember what is the fractional change it is given? The fractional change it is given, d I naught by dt is equal to 0.11. d I naught dash by dt upon y naught, this is 0.07. Now we have d I naught by dt and d I naught dash by dt are equal. We can divide these two equations. When we are dividing these two equations, you will get I naught dash by I naught, because these are equal, we have proved. It will become 11 by 7. So what is the I naught? I naught will become 7 by 11 times of I naught dash, and I naught dash is 5 microampere. That's why it will become 35 by 11 microampere. 35 by 11 microampere. That is the value of theoretical reverse saturation current, that is through the junction. Now what is the total is 5, and what is the I naught? 35 by 11. So what is the IL here? From this you can find the IL is equal to I naught dash minus I naught, 5 minus 35 by 11, that will become 20 by 11 microampere. Now if you have the IL surface leakage current, that is very very small, so what is the RS? 10 volt divided by 20 by 11 microampere means it will become 110 divided by 20 into 10 raised to power 6 ohm. That is nothing but mega ohm, 5.5 mega ohm. So answer for this question is 5.5 mega ohm. Answer for this question is 5.5 mega ohm. So this type of questions we may expect in what? ISRO examination, guys. Okay. So but suppose you are getting this type of questions. If you have no idea about that, please leave it. Simply leave it, because it will waste your time. If you have idea how to solve, because it is a questions from standard textbook like what Millman, Halkias, Sadra and Smith, Niemann. So EDC will affect your time management. If you have idea, then try to solve, otherwise simply leave it. That is the question from electronic devices and circuit. Okay, the typical questions. If you have idea, then answer is what? 5.5 mega ohm. Because you have to solve 80 questions, technical 80 questions. Now, this is the question from the clipper. Yes, you can solve this type of questions. अरे यार थोड़ा comments दीजिए. Is it audible ना? Everything is fine. Send smiley or something else so that yes please. Okay then. Next one. Consider the following circuit. For the circuit shown below, which one of the following is the correct statement? One statement is correct out of this. D2 does not conduct for any value of Vi. V0 is 10 volt for all values of Vi greater than 10. V0 is 0 for all values of Vi less than 0 volt. V0 is 10 volt for all values of Vi greater than 0 volt. So this is the question from what? Clipper. So what is the answer for this type of questions? Clipper. So clipper means if we have the 4 options, then quickly you can check. First of all, always watch the answer. In 4 options we have one option where Vi is less than 0. Here the Vi is greater than 10 volt, here Vi is 0 volt. So here 10 kilo ohm, 10 kilo ohm and 10 volt battery is connected. So you can first of all check for Vi less than 0. So when the Vi is negative, here we are connecting the Vi. So when the Vi is less than 0, what is the highest battery? 10 volt. Diode is ideal. Then when the diode is ideal, because of the 10 volt, this diode is off. When this diode is off and because it is less than 0, negative, this diode is also off. So for Vi less than 0, what is the position of diode D1 and D2? Otherwise in Clipper we have to make the proper table, but it is an objective question and we have to solve quickly. Then on rough pages, then V0. So D1 is off, D2 is off. Both the diodes are off. What is the current? 0. Then you will get this is off, this is off. If both are off, you will get nothing. What is the output voltage? 0 volt. Output voltage is 0 volt when Vi is less than 0. Now verify the answer. It is a MCQ, only one answer is correct. It is given V0 is 0 for all values of Vi less than 0. C is correct. C is correct. Then no need to check the other answer in exam hall. In exam hall, no need to check, guys, but it can ask for transfer curve also. So what is the transfer curve? Transfer curve or V0 versus Vi, then we have to find all the range for this. So second Vi is 0 for all the values of Vi, that is the C is the answer. But how to draw the transfer curve? Then we are taking just Vi greater than 0. 0 is less than or equal to Vi is less than. Then when just the Vi is greater than 0, D1 will conduct. But because it is 10 volt, it is reverse bias by 10 volt, it is off. Now you have to draw the second diagram. When we are giving the second diagram, this time this diode is on, ideal diode act as short circuit. Practical diode, it will act as open circuit. And now you will get the output, that is nothing but Vi by 2. Why Vi by 2? Because it is 10 kilo ohm, it is 10 kilo ohm, it is the voltage division rule. Vi by 2 is the output. Initially it is 0, now it is the Vi by 2. So output is Vi by 2 here. Now what will happen? When we are increasing the Vi, output will also increase. Now watch this diode. This diode is reverse bias by 10 volt and on the positive side we have the V0 and V0 is Vi by 2. Okay, so when we are increasing the Vi, V0 will increase, and when Vi by 2 is greater than 10 volt, when Vi by 2 is greater than or equal to 10 volt, D2 will on. So what is the Vi? When greater than or equal to 20 volt, D2 will on. So this is valid up to what? 20 volt. Now when the Vi is greater than 20 volt, this is already on, this is on. Both diode on. And once the D2 is on, guys, this will act as short circuit and output is fixed at 10 volt. So what is the maximum value of the output? 10 volt. What is the maximum value of the output? 10 volt. It is fixed. So that is the case. Now watch this. First answer, D2 does not conduct for any value of Vi. Wrong. D2 will conduct for Vi greater than 10 volt. Greater than 20 volt. V0 is 10 volt for all values of Vi greater than 10 volt. Wrong. V0 is 10 volt for Vi greater than 20 volt. This is also wrong. This is correct. V0 is 10 volt for all values of Vi greater than 0 volt. Wrong. It is greater than what? 20 volt. Okay. So that is the answer. Is there any further any other question you can ask, guys? Yes, please. Now, once you have the V0 and Vi, then you can draw the transfer curve also. So in a clipper, they will normally ask the transfer curve on this. So this is the case. Okay, next question. To draw the transfer curve and post on my Telegram channel, I will check and then I will inform you that whether you are able to draw the transfer curve, yes or no. That is the V0 versus Vi, and that table already I have given. Then next question is on what transistor? Again from the analog, that is for the common collector amplifier shown in the figure, the BJT has high beta, negligible VC is set, and VB is 0.7 volt, the maximum undistorted peak to peak output voltage. To watch the previous year papers of the ISRO examination, we are getting this type of questions. Okay, typical questions. What about the swing in engineering? That is about the Fermi level, about what graph, EDC and analog. So that is the question. So that is the swing, the maximum undistorted peak to peak output voltage is. So when we are taking the output from the emitter and when we are giving input to the base, it is a common collector configuration. Collector is common here. So how we can get the swing, guys? So what is asked? Beta is very large. That's why you can neglect the base current. And VC is set negligible, means when it is in saturation, it is 0 voltage. Means when it is in saturation, it will act as short circuit. VB is 0.7 volt, the maximum undistorted peak to peak output voltage. Means we have to find the swing. V0 maximum minus V0 minimum. Undistorted output voltage. Okay. Then how we can solve this question? First of all, do the DC analysis, and this capacitor will act as what? Open circuit. During DC analysis, how we are going to get the swing, guys? Try to solve this question and give me answer on comments box. Okay, everyone. So see you all other students. How are you? Is it audible, everyone? Is it audible now? Okay then. Then first of all, make this capacitor open circuit. This capacitor open circuit under DC condition, and then you can apply what? Thevenin's across this. This is a 12 volt battery. So you are having, this is 10, this is 5, this is 12 volt. So what is the Thevenin's voltage here? 10 divided by 5 plus 10 into 12. Okay, then you will get 8 volt. You can check. This is the 2 by 3 and this is the 12, 8 volt. This is the Thevenin's voltage at this point. Once you will get the Thevenin's voltage 8 volt, then you can draw this circuit again under DC analysis. Then it will become this is 8 volt. No need to find the RTH because the base current is 0. Beta is very, very large. 8 volt. This is 0.7 volt. So under DC condition, what is the output? 8 minus 0.7, that is what? 7.3 volt. Under DC condition, first of all, find the output, that is the 7.3 volt. Okay. Now, always remember transistor has two extreme conditions. One is what? Saturation, one is cutoff. Under saturation, it will act as short circuit, or under cutoff, it will act as open circuit. Then we have the 12 volt. So under two situation, when it is in saturation, so saturation, you can draw the transistor as a short circuit. We are having the resistor here, and that is the output. This is the 12 volt. So what is the maximum DC output? 12 volt. Under short circuit, when the BJT is under short circuit saturation. When it is in cutoff, BJT will act as open circuit. This is the resistor. There is no current across this RL and we are getting the output 0. This is the BJT act as open circuit under cutoff. So what are the extreme end? 0 and 12 volt. Now finally, so always remember how to find the swing. Very quickly you can solve if you have the idea. That first of all, always plot a maximum and minimum value. What is the maximum and minimum value? 0 and 12 volt. 0 and 12 volt. Now, where is the Q point? Where is the DC output? We have the DC output at 7.3 volt. When we are having the DC output at 7.3 volt, then How we are finding the swing, undistorted swing? Always remember, draw a sinusoidal waveform which has the symmetrical shape like this. Because we want undistorted output, then that is the gap. So what is the gap? This is the gap between this and that will decide the swing. So what is the gap from 12 volt to 7.3 volt? 4.7 volt. This gap should be also 4.7 volt. So what is the swing here? 9.4 volt. 9.4 volt is the swing of the output, undistorted output. 9.4 volt, that will be the swing, guys. So this is the swing here. Now the maximum undistorted peak to peak output voltage is what? This one. Next question. For the common collector amplifier shown in the figure, the BJT has. So this type of questions from the analog, guys. Already I have taken one session on what ISRO, important topics from what analog. Please go through that and try to solve those questions. Okay. The next one. And all the students, if you are enjoying the session, then like the session and simply install what BYJU'S exam prep app. Now, amplifier. They will ask question from what amplifier? That is what common emitter with RE, bypassed RE or unbypassed RE. So here it is bypassed. Here it is bypassed RE. 3.3 is bypassed by the 50 microfarad capacitor. 4 kilo ohm. HFE is 150. It is given 60 kilo ohm, 30 kilo ohm, and directly we have connected the input here. So an amplifier circuit is shown in the figure. The voltage gain V0 by Vs is. What is the voltage gain? 4 divided by 3.3, 100, 160, 200. Okay, give me answer in comments box. Yes, please, Dhiman. क्या हुआ भाई आप लोगों को? Give me the answer. What is the answer for this question? Very easy question. An amplifier circuit is shown in the figure. Vt is given 25 millivolt. What is the voltage gain? This is the Re bypassed with the capacitor. And HFE is given 150. That is a very, very large value. So you can also neglect. Nandesh, you are giving the A option. Okay. But remember here the Re is bypassed. 3.3 kilo ohm. Now Vt is given as 25. So I have the shortcut, but remember, once the Re is bypassed, guys, first of all, we have to do the DC analysis to find Re. What is the Re? Vt by I. Vt by I. Vt is 25 millivolt. And now you have to find the I, then you can find the small Re. That is called dynamic resistance. So under DC analysis, this capacitor will act as what? Open circuit. This capacitor will act as open circuit. This capacitor will act as open circuit. And now you can apply what? Thevenin's equivalent here. This is the case. Cut here. So you can find beta is very, very large, and simply find what? VTH. This is the 30, this is the 60, and that is the 12 volt. It will become VTH is equal to 30 divided by 30 plus 60 into 12 volt. That will become what? 4 volt. Now once you have the value of VTH, you can redraw the diagram. What is the diagram here? This is the 3.3 kilo ohm. Here no need to find the RTH because the base current is very, very small. And what is the 4 volt? What is the VB? 0.7 volt. So here you will get around 4 minus 0.7. So what is the voltage at this point? 3.3 volt. And what is the current IE? 4 minus 0.7. So what is the IE is equal to 3.3 divided by 3.3, 1 milliampere. Now if you have the 1 milliampere, then you can find the RE. What is the RE? 25 divided by 125 ohm. 25 ohm. Now remember, it is bypassed, guys. It is bypassed. Once it is bypassed, you can use the RE model. This is the RE model. This is the alpha IE. And this is a small RE. Because it is bypassed, no need to consider the 3.3 kilo ohm. Emitter is directly connected to ground. This is ground. and here 60 and 30 are in parallel. This is the base terminal. So 60 and 30 are in parallel because during AC analysis this will act as 0. Now here we are connecting the Vs and this is IE, and at the output only the 4 kilo ohm resistor is connected, that is called RC. 4 kilo ohm resistor is connected, that is called RC. Now you can find alpha is very near to 1, nearly equal to 1, because alpha is beta upon 1 plus beta. So this is nearly equal to 1, you can take alpha is equal to 1. So what is the I? I is moving in this direction. So that is the V0, and what is the Vs? I into Re. So you can write V0 by Vs is equal to alpha IE into RC upon IE into Re. IE cancel, and always remember this answer minus, because it is a minus. This current is alpha IE with negative sign. So minus, so it will become minus alpha RC upon Re. That is the answer directly you can use. So this is a shortcut. This no need to draw the diagram and T network. You can use directly formula, but you have to find the Re. To find the Re, IE you have to find. Now put the value. What is the RC? 4 kilo ohm, and this is the 25. So alpha is nearly equal to 1. So it will become 4000 divided by 25. What is this 4000 divided by 25? Minus 160. Nearly equal to 160. Which answer is correct? C. C is the correct answer. C is the correct answer. Now nowadays it is clear. Because why we are getting the very high gain? Because it is bypassed. Because it is bypassed, guys. Now next question. Now the common emitter current gain bandwidth product of transistor is defined as common emitter short circuit current gain. Common emitter current gain bandwidth product. Current gain bandwidth product is always constant. Ft is defined as alpha of the transistor fall by the 3 dB, beta of the transistor falls by the 3 dB, beta of the transistor falls to unity, power gain of the transistor falls to unity. What is the Ft? High frequency analysis of BJT. High frequency analysis of the BJT. Very easy question, theoretical question. Give me the answer. Theoretical question. यार इतना तो बनना ही है आपसे. Yes please everyone. Okay. Here there is no negative marking on mock test. Please give answer. But remember in exam there is a negative marking in technical paper. So Nandesh is giving the D. All other students. Yes. Now watch this. In a high frequency we are having this type of response. Right, it is a Bode plot. First of all it will increase and then it will fall like this. So a frequency where the gain become 1, that is the Ft is the frequency where the gain, current gain will become 1, means beta will become what? Exactly equal to what? 1. Beta become unity. Then F beta cutoff frequency is called this frequency. This is the bandwidth for what? Common emitter transistor. This is the Ft, and that is the gain is what? HFE. So just it is a asymptotic plot, so you can find the 20 log of AI, but I am not writing the mod of AI, this is the AI. Now here the gain is 1, so what is the 20 log of 1? 0 dB. So that is the Ft, the Ft is the gain where, Ft is the frequency where the gain bandwidth product is what? 1, unity gain bandwidth product. So at this point gain is HFE. HFE into F beta is equal to 1 dot Ft is equal to alpha dot F alpha. Where is the alpha? This is the alpha. And this is called alpha cutoff frequency. This is called alpha cutoff frequency. And at this point the gain is alpha less than 1. This is the gain 1. So everywhere the gain bandwidth product is constant. When the gain is HFE, bandwidth is F beta. This is for common emitter. When the gain is 1, gain bandwidth is up to Ft. When the gain is less than 1, F alpha. So F alpha is greater than Ft, Ft is greater than what? F beta. So that we have solved number of questions. So Ft is called unity gain bandwidth product. It is constant. A frequency at which effective beta will become 1. And that's why the answer is what? Beta of the transistor falls to unity. Beta means effective current gain will become 1. Remember, This is from high frequency analysis. This is a very, very important graph. Now questions from what? Power amplifier, guys. Okay, try to give me the answer. In a class B push-pull operation, the DC power drawn is 28 watt. What is the power delivered by the amplifier at the ideal maximum efficiency of power conversion? So guys, what is the power amplifier? We have the different types of amplifier, class A, class B, class C. So class A, class B, class AB, class C. So tell me, what is the ideal efficiency for class B operation? In a class B push-pull operation, ideal maximum efficiency of power conversion, if the input power is 28 watt, then what will be the output power? Remember, class A, for direct coupled we are having the maximum efficiency 25% and 50% for transformer coupled. And in case of class B, we are having a very, very high efficiency, that is 78.5%. That is called power conversion efficiency. Power conversion efficiency. So input power is 28 watt. Power efficiency is what? Output upon input. So what is the output power? Output power is efficiency into P. So efficiency is 78.5, means you can write 0.785 into what? What is the input power? 28 watt. And you will get the answer. 22, option C. Yes, Nandesh, that is answer is correct. C. 22 watt. 22 watt. So they will ask the class. So just I'm giving you this is the answer. And remember, what are the cutoff points? If this is the DC load line, then for class A, this is the IC, this is the VC. For class A, in the middle of the active region, that is the class A operation. Class B, it is at cutoff. Class AB just near to cutoff between A and B, and class C is below cutoff. Classes, these are called the Q point for class A, class B, class AB and class C. Right? And when we are moving downward from class A to class C, efficiency increases. Class A, AB and most class C has the highest efficiency. Class C has the highest efficiency. Yes, all type of amplifier का कोई lecture है, हाँ, you can search with what power amplifier you will get, right? You can get. Okay then. I think now you are enjoying the session, guys, everyone. So I am touching what all the topics. If you find any difficulty in any topics, then please inform me. Monday I am going to take one important session at 11 a.m. because microwave is in our syllabus, but normally we are getting 1 or 2 or 3 questions from microwave. So in 1 hour, I am going to cover all the important devices from microwave. 11 a.m. Subscribe the channel. Join my Telegram channel, that is Electronics by Sanjay Rathi. Don't miss that session on Monday. 11 a.m. on microwave. Because it is not possible to revise all the topics from the microwave. So just quickly I will give the basic idea about all the devices. And second important thing, already I have taken one session on what? Analog. Go through that. हाँ बिल्कुल है. कैसा है इंटरव्यू सेशन? थैंक यू फॉर योर फीडबैक. Everyone please enjoy that session and get the basic idea. We have number of questions. We have taken 5 or 10 mock interview, and this time we want to take more and more mock interview. Okay. Then voltage series feedback, also called series shunt feedback, results in. Now feedback mechanism. We have the 4 types of feedback: voltage series, voltage shunt, current series, current shunt. Then what is the voltage series feedback? I think everyone have the idea about this question. Voltage series feedback, also called series shunt feedback, that is another name of that. Then increase in both the input and output impedance, decrease in both the input and output impedance, increases the input impedance, decreases the output impedance, decreases the input impedance and increases the output impedance. Tell me, that is a very, very basic question. Very basic question, guys. Everyone try to give me the answer in comments box. We are having, this is the case. This is the sampling of the signal, and here it is mixing of the signal. Voltage series means we are sampling the voltage, we are mixing the voltage. Basic amplifier is, and this is the beta. Now tell me. At the output, when we are sampling the voltage, shunt connection. That's what is called at the output. This is here we are using the input connection, output connection. So at the output, shunt connection. When the resistor connected in parallel, output impedance will decrease. At the input, series connection, because we are mixing the voltage. So when the connection is series, input resistance will increase. So increase in the input impedance, decrease in the output impedance. 4 types of feedback. So this is the answer. Increase in input impedance, decrease in the output impedance, guys. Okay. Then electronics, they will ask question. This is the complete table. If you want the PDF, then yes, I will upload. There are 4 topology: voltage series, current series, voltage shunt, current shunt. What are the output signal? What is the input signal? What is the basic amplifier? Which gain is stabilized? What is the unit of beta? What is the another name? And finally, what is the effect on input and output resistance? Please go through this table. You can take also a screenshot, or otherwise what on my Telegram channel I will upload. Then please go through this table. You will be able to solve all type of questions on this. This is a very, very important table, guys. Okay. That is called what? Short tricks. Now next. Now an amplifier using an op-amp, with a slew rate of 1 volt per microsecond has a gain of 40 dB. But normally we are taking the slew rate for closed loop system. So now this is the property of operational amplifier. With a slew rate of 1 volt per microsecond has a gain of 40 dB. If this amplifier has to faithfully amplify the sinusoidal signal from the DC to 20 kilohertz. So what is the highest frequency? What is the maximum frequency of operation? 20 kilohertz. What is the lower frequency? 0. Without introducing any slew rate induced distortion. Then the input signal level must not exceed. Now we have 15 days. So guys, this is a formula based question. Quickly we have to apply the formula. What is the maximum frequency of operation? Then quickly you can solve this type of questions. So what is the slew rate? Slew rate unit is given 1 volt per microsecond. That is the slew rate is given. But remember, you have to convert it into volt per second. Then it will become 10 to the power 6 volt per second. 6 volt per second, guys. That is the slew rate. Now, what is the maximum frequency of operation? We have the formula. That is for maximum frequency of operation, FM. That is nothing but omega m by 2 pi. This is in hertz. It is given by slew rate divided by 2 pi. This is the 2 pi Vm into closed loop gain. Here Vm is the amplitude of what? Input signal. So directly you can use this formula, right? And then you can find the amplitude of the input signal. What is the closed loop gain? The closed loop gain is given as 40 dB. So what is the 40 dB means? 20 log of closed loop gain. So 20, take the anti-log of that, you will get the 100. 100 means 2 into 20, 40. So 100 is the gain. Now FM, it is, what is the maximum frequency of operation? 20 kilohertz. And then what is the slew rate? 10 to the power 6. What is the 2 pi? 2 pi. Vm we have to find into 100. Then this will become 10 to the power 4. This is the 2 into 10 to the power 4. So what is the Vm is equal to? Vm is equal to, it will become 10 to the power 4 upon 2 into 10 to the power 4, that is divided into what? 2 pi. This is 1 upon 4 pi. Find the value 1 upon 4 pi volt. You can convert it into millivolt, guys. 1 upon 4 pi volt. So what is the answer, Ankit Kumar? So 795, 395, 79.5 millivolt or 39.5 millivolt. It's up to you. You can find 1 divided by 4 pi. That is the answer. Or you can check my calculation also. (79.5 millivolt). 79.5 millivolt. So slew rate, PSRR. power supply rejection ratio, offset voltages and currents, input bias current, input offset current. Revise all this topic. If you want the typical value, it is given in Millman-Halkias. Millman-Halkias. I think the 15th and 16th chapter or 14th or 15th chapter. Go through that, operational amplifier. You will get all the properties. Okay then. Now next question. Now some questions, already we have discussed one question from EDC, remaining questions from analog. Now EDC. Silicon is doped with phosphorus. Silicon is doped with, what is the phosphorus? Trivalent or pentavalent? To a concentration of 4 into 10 to the power 17 atoms per centimeter cube. Assume the intrinsic carrier concentration of silicon is this one, standard value. Value of the KT by Q is 25. This is also a standard value, 25 millivolt at 300 degree Kelvin. It is given. Compared to the undoped silicon, the Fermi level of the doped silicon. Undoped silicon Fermi level. That is not in ISRO exam now. One question from Fermi level. Semiconductor physics is very important topic in ISRO. Right? This is a pentavalent. It is a pentavalent means what? Nd. This is the donor impurity, 4 into 10 to the power 17, and then material will become N-type. When we are giving Nd, it will become N-type, means Fermi level is moving upward. When the Fermi level is moving towards the conduction band, so guys, goes down, it is wrong. Goes down, it is wrong. Now you can take calculated risk, B or D. 50% probability that you are going to get the right answer. Then, but it's up to you. This is called what? Calculated risk. Calculated risk. If suppose you are not having any idea about the formula, then if you have the idea about the formula, then you can solve. If you have no time and if you want to solve, if you want to take calculated risk, then this is the EV, this is the EC, this is the intrinsic Fermi level, undoped Fermi level, and when it is N-type, actual Fermi level is near to conduction band. So what is asked? Compared to the undoped silicon, the Fermi level of the doped silicon goes up by what? This is the value. Goes up by what value? This is given by KT, right? It is in what electron volt? That is what KT log of. What is the doping? Nd by Ni. That is the formula. So they will give you the value of that. KT means what? You can put the 0.025 because it is given in millivolt. Log of Nd. What is the Nd here? 4 into 10 to the power 17. Now why I have choose this question, and this is 1.5 into 10 raised to power 10. Now 0.025 log of this is 4 upon 1.5 into what? 10 to the power 7. They will give you the log of this value. Yes, definitely in ISRO examination, if the calculator is not allowed, then they will provide you the value. You can use that value, multiply it, and you will get the answer, guys. But here, so that is, you will get around 4.427. It goes up by 0.427. Up by 0.427. D is the answer. Yes, Ankit Kumar. Your answer is correct. So this type of questions from Fermi level, get all the idea about the Fermi level, guys. Okay, and especially what that is the continuity equation and so on, semiconductor physics. Okay, questions on Hall effect, again that is very important one for ISRO. An N-type semiconductor specimen, already given it is N-type semiconductor, has a Hall coefficient of 300 centimeter cube per coulomb, and its resistivity is 0.1 ohm centimeter. Its electron mobility is, again formula based question. Hall effect, Hall coefficient, what is the relation? So Hall effect, as you know, Hall voltage is given by Bi upon rho W. Bi upon rho W, that is the Hall voltage, and rho is the volume charge density, that is called RH. Volume charge density, that is called what? RH, Hall coefficient. Unit of rho is coulomb per centimeter cube. What is the unit of RH? Opposite, centimeter cube per coulomb. That is given RH. Now As you know, the mobility you can find is given by sigma RH. Sigma RH. Sigma is nothing but 1 by rho into RH. What is this rho is resistivity. That don't confuse with this. This is the volume charge density and that is the resistivity. So no need to write. What is the sigma? 1 by resistivity. Directly you can write 0.1. So 0.1 into RH 300, it will become 3000 centimeter square per volt second. Centimeter square per volt second. Okay, quickly you have to use all this formula. All this formula, guys. How to download? Chandrasekhar, you can't download this session. Simply what you can do, you can join my Telegram channel, that is Electronics by Sanjay Rathi. I will upload the PDF of this session. Okay. Just after the session or after 1 or 2 hours, I will upload the PDF of this session. You can watch. And second thing, you will get the notification about all my sessions there, because I am going to take one important session on ISRO exam. 2 sessions, one on EDC, one on microwave. So this is the important question. Next one. After me, stay tuned with us. After me, Saket sir will join. Okay, so continue with Saket sir. Some important questions from communication and EMFT. So that is, I have to solve 10 more questions. Then next one. Now this is a question from analog, that is what Zener voltage regulator. So now this is the 9th question from analog, guys. 9th question from analog. Okay, tell me. You are expert in this here. Zener diode voltage regulator. The Zener diode in the regulator circuit shown in the figure has a Zener voltage of 5.8 volt. Zener breakdown voltage is 5.8 volt and the Zener knee current of 0.5 milliampere. Knee current means IZK. 5 milliampere. The maximum load current drawn from its circuit, this circuit, ensuring the proper functioning over the input voltage range between 20 to 30 volt. What is the maximum load current we can draw from this? If suppose RL is connected, so what is the maximum load current we can draw from this circuit for proper functioning of the circuit? Proper functioning of the circuit. Okay, Ankit, I will upload. Just after session, I will try to upload. Okay, everyone join that session, Electronics by Sanjay Rathi. Tell me what is the answer. What is the answer? Just I am sharing the link with you. What is the answer? Quickly try to give me the answer. Yes, please, everyone. Okay, this is my link. You can join Electronics by Sanjay Rathi. So first of all, installed what? First of all, installed BYJU'S a Telegram channel and also install the BYJU'S exam prep app. So what is the IZK? That is the very basic question, guys. Why I have chosen? Because number of students are doing silly mistake in this type of questions. Voltage regulator is a general circuit and you have to follow this only 2 formula here. First of all, if suppose RL is connected here, then guys, this is the IL, this is IZ and this is I. Always remember what is the IZ? I minus IL. Always follow this formula. IZ is equal to I minus IL. This is a very, very important. When the IZ will be minimum, IZ minimum, when I is minimum and IL is maximum. Always follow this formula for proper functioning. Proper functioning means Zener diode should be in what? Breakdown region. So you have to satisfy this question. When IA minimum minus IL maximum, that is the IZ, it should be greater than or equal to what? IZK. Now, what is the I minimum? So when we are getting the I minimum, because this voltage is fixed, once it is breakdown, it is 5.8. Here we are having the 20 and 30. So when we are going to get the minimum, when we are choosing the minimum value of VI, 20 minus 5.8 upon 1, that will give the minimum value of VI. 20 minus 5.8 divided by 1 kilo ohm, that is the series resistance, minus IL maximum is required in the question. It should be greater than or equal to IZK. What is the IZK? 0.5 milliampere. 0.5 milliampere is the IZK. Now it will become 14.2 minus IL maximum, it should be greater than or equal to 0.5. So what is the IL maximum? It should be less than or equal to 14.2 minus 0.5. That is equal to what? 13.7. So answer for this question is 13.7, not that value. Okay, remember. So guys, rely on this formula only. Rely on this formula. For what is the keyword here? For proper functioning of the circuit. This is a very, very important formula. Okay. Then next one. Next question. Now this is a question on what FET. The characteristics. They are giving the question on graph, guys. In ISRO exam, we are getting the questions from the graph. So what is the answer? The measured transconductance GM, of an NMOS transistor operating in the linear region is plotted against the gate voltage VG at a constant drain voltage VD. This is the gate voltage VG at a constant drain voltage VD. Which of the following figure represent the expected dependence of GM, transconductance GM on VG? GM in MOSFET. What is given? The measured transconductance GM of NMOS transistor operating in the linear region is plotted against the gate voltage at constant drain voltage. Which of the following figure represent the expected dependence of GM? A. GM versus VG, GM versus VG, GM versus VG, GM versus VG. If you have idea, then you can give the answer. Otherwise, simply leave it because there is negative marking. Then remember, what is the in linear region means what? In when the VG is constant, it behaves like what? Normally we are getting this type of curve between ID versus VGS. This is the curve. But practically what will happen when we are increasing the VG? Electric field will increase and the mobility for high electric field mobility is proportional to what? Root E, and very, very high electric field mobility is proportional to what? 1 by E. Mobility. For very high electric field, mobility start decreasing. So actually when we are increasing the VG, what will happen? Actually we are assuming that this type of curve ID versus VG, but for very high electric field, up to this point everything is fine. After that it will start decreasing like this. This is the blue one, practical curve. So what is the slope of this line? This is called GM. Slope of this line is what? GM. K and dash W by L, half of K and dash W by M, VGS minus VT the whole square. This is the formula, and the slope of this line, this curve, is called GM. It will increase linearly. Everything is constant. Okay, is it audible? Visible? Give me 1 minute. Okay. Now, next question. Some problem, 1 minute. If there is a voltage fluctuation or anything else. Give me 1 minute. Okay, 1 minute. Now I think everything is fine now. This is a solar cell. The figure shows the IV characteristics of a solar cell illuminated uniformly with solar light of power 100 milliwatt per centimeter square. Solar cell has an area of 3 centimeters. About the solar cell, then give me the answer. I'm audible. Hello, hello. No, fine. क्या problem है? The figure shows the IV characteristics of the solar cell. So remember, here we are getting this is the ISC VOC. So according to the field factor, we have VMIM upon VOC ISC. So what is the VMIM? This is called maximum point 5 into what? 180 milliamp. Milliwatt. So you will get the answer. So what is the answer for this question? 21%. So that there are the 4 options here. Option A 21%, option B, normally we are getting the 81%. Options, guys. Anything going wrong? 1 minute here. What is the problem here? One minute. So normally the practical value, I want to say that practical value is what nearly equal to a 20% or less than the 20%. That is okay. Then next one, consider the 2 energy levels E1 E electron volt above the Fermi level and E2 electron volt below the Fermi level. P1 and P2 are respectively the probabilities of E1 being occupied by an electron and E2 being empty. Then tell me, what is the probability? E1 E electron volt above the Fermi level and E2 electron volt below the Fermi level. Suppose this is the Fermi level. E1 electron volt above the Fermi level. And E2 is electron volt below the Fermi level. Right. Now P1 and P2 are respectively the probability of E1 being occupied by an electron. E1 is above the Fermi level, means it is in conduction band. It is in what? Conduction band. And it is in what? Valence band. Then if there is a 1 electron in the conduction band, then definitely there is a 1 hole in what? Valence band, because the gap is what? Same, just like what? Intrinsic semiconductor. So if the gap is same, means what? We are talking about the intrinsic semiconductor. So what is the probability? If the probability of finding an electron is what? P1, here the probability of finding hole is P1, P2, then both are equal. So both are equal, that is the P1 is equal to P2. Empty state means what? Hole, probability of hole and probability of electron. That is exactly what? Same, P1 and P2, because the gap is same. Now, that is now we are going to solve questions from digital, and quickly we will solve questions from microwave, and then Saket sir will join, guys. Okay, tell me the Boolean expression in its canonical form for the decoder circuit shown below is. Again, a digital question, very easy one. Tell me, we have to solve in ISRO exam, we have to get the marks from our digital. Boolean expression in its canonical form for the decoder circuit shown below is. देखो है ना, इसरो में ना ड्यूरिंग एग्जाम यू हैव टू डिसाइड कि कौन सा सब्जेक्ट आपको टफ पड़ रहा है, उसको छोड़ दीजिए, पहले जो इजी क्वेश्चन इजी है ना उसको बनाइए, वो चाहे वो डिजिटल हो, चाहे नेटवर्क हो, चाहे सिग्नल एंड सिस्टम है, एनालॉग है, आपका मैथ्स एप्टी, जो भी आपको बनाना है ना वो बनाइए पहले, और उसके बाद आप एकदम कोर या ईडीसी वगैरह में जाओ जहां आपका टाइम लगेगा. तो देखिएगा बूलियन एक्सप्रेशन इन इट्स कैनोनिकल फॉर्म द डिकोडर सर्किट शोन इन द फिगर. Now watch it carefully. It is a very interesting subject. There is ABC and C is connected to what? Enable pin. When the C is 0, it is enable. When the C is 1, it is disable. Once that is disabled, what about all the outputs? All the outputs are 1, 1, 1, 1, 1, 1, 1, 1 because it is inverted output. If when it is disabled, all the outputs are 1, 1, 1, 1. What is the output here? 1. What is the output here? 1. If both the inputs to the NAND gate is 1, both the input to the NAND gate is 1, then what is the output? 0. What is the output? 0. NAND gate. NAND gate means 0, 0, 0, 1, 1, 0, 1, 1. A dot B the bar. So it is 1, it is 1, it is 1. When both the inputs are 1, output is 0. So when this is C is what? 1. C is 1, this is disable and output is 0. Now you can say like, that is the diagram. Now watch this. A, B, C 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and what? 1, 1, 1. Now what will be the output? When the C is 1, we are getting the output 0. Directly you can say 0, 1, 2, 3, 4, 5, 6 and 7. So 5, 7, 1, 3, 5, 7 we have the 0. 1, 3, 5, 7. 1, 3, 5, 7. If suppose in this answer 1, 3 is present, not possible. Right, and you can say, sir, that is the mean term. No, again we have to check or further. Then we can say, watch this, any one of these three. Suppose now it is a C is what? 0. We can change 0, 0, 0, 1, 1, 0, 1, 1. So if out of this definitely any one of these 0, then definitely 2 will be what? 1, 1, 1, 0 or what? 0, 1, 0 and so on. If any one of the input is 1, output is 1 and that is 1. It is remain fixed. So you can remove the 0, 1, 3. That will not work. Now you have to check only what? 3, 4, 6 and 7. Out of 3, 4, 6 and 7, already 3 and 7 is what? 0. So 3 and 7, remove the 3 and 7. Now what is remaining here? 4 and 6 only. So out of 4 and 6, if any one is 0, you will get 0 here. 0, 1 is what? 1 here. So for 4 and 6, you are going to get the 1. For remaining, you will get 0. Means it is a mean term what? Mean term of 4 and 6 only. Mean term of 4 and 6 only. So nowadays, 0, 2 is cancelled out. 0 and 2 is cancelled out because of this. Because it is passed through the 1 OR gate and it is always 1. Any one of the input is 1, then it is always 1. We want 0 here. But it is never ever possible to get the 0 here. Is it clear? Because of OR gate. So 0, 2 cancel, 4 and 6 only. Now, next question. A, B and C are at decimal integer corresponding to the 6-bit number. A, B, C are the decimal integer 1, 0, 1, 0, 1, 0. Consider the sign magnitude 1's complement and 2's complement. The 8-bit 2's complement representation of A plus B plus C is. A plus B plus C is. Then tell me, what is the 1010 in 2's complement? 10 10 10. If it is a 2's complement number, then it is a negative number because MSB is 1. And find the 2's complement of this 0 1 1 0 1. 1 2 4 8 16. This will become 22 minus 22. Watch this. Am I correct? 0 1 1 0 1. 0 1 1 0 1. That is 1 2 4 8 16. 16 plus 4 20 22 minus 22. If it is 2's complement. If it is 1's complement, then in 1's complement again it is a negative. Find the 1's complement of this 1 0 1 0 1. 1 2 4 8 16, and that will become 21. This is the minus 21. This is minus 21 in what? 1's complement, right? So you have to simply put the sign and find the 1's complement of 1 0 1 0 1, and that is the 1 0 1 0 1, that is the 21. And now if it is sign magnitude 1 0 1 0 1 0, sign magnitude means it is a negative sign, and find the magnitude 1 2 4 8 16, only the magnitude. 8 plus 4 12, it is minus 12. Now add these three. So minus 22 minus 21 minus 12, actually it is 5 and 45, minus 45. Now how we can represent the 45? 45 means what? First of all, find the 45 normally. So it is 1 2 4 8 16 32. So what is the 45? 45 will become 32 plus 8, 40. This is the 45, right? 1 0 1 1 0 1, 45, but it is negative. So you have to find the 2's complement of this. It will become 1 1 0 1. You have to put a 1 extra 0 to just represent the sign. So this is the 2's complement. This is the in 7-bit representation, 1 2 3 4 5 6 and 7-bit. So this is the 45. Now find the 2's complement. 1 1 0. This will become 0. First of all 1, that is 0. 1 will become 0, 1 will become 0, 0 will become 1, 1 will become 0, and that is the 2's complement representation. 1 0 1 0 0 1 1. But it is represented in 8-bit, then you have to put 1 extra 1. We have to repeat the MSB. So double 1 0 1. So if you have any answer, then okay, otherwise none of this. Double 1 0 1 double 0 double 1. Right, check my calculation also. Okay, that will be the answer. It is what? Minus 55. Okay, I have done calculation mistake. Oh, sorry, calculation mistake. This is minus 55. So in exam we are doing the calculation mistake, guys. Minus 55. Okay, then if it is minus 55, then this is 32 16, right? And that is what we can represent up to what? 60-bit. That is the 32 16. That will become what? 48 48 plus 8 56. 48 plus 55. No, this is all 1. And you have to put the 0. This is the negative sign. Now find the 2's complement of this 1 0 0 1 0 0 1. If you want, this is the 7-bit representation, 8-bit representation. So double 1 double 0 1 double 0, double 1 double 0 1 double 0, and you can find which answer is correct, guys. Is it clear? In this way you can find the answer. So first of all, write the 55, and then find the 2's complement of that. That will give you the value in 2's complement representation with the MSB here. That is, first of all, write the 55. This is the 48 plus what I am doing here. Yes, this is correct, and that is the find the 2's complement and repeat the MSB. Repeat the MSB. That is the solution for this particular question, guys. Okay, D, none of this, and that is the answer. Now a programmable logic array is shown in the figure. The Boolean function f implemented is PLA. That is the question on PLA, guys. So what is the Boolean function here? Now here, watch this. which are connected here. In PLA, this is the P. So here we are getting the P and P bar, Q and Q bar, R and R bar, which is connected here. P bar plus Q into Q, R, AND gate R, and then we are getting P plus Q bar plus R into R. That is the output. So we have P bar Q bar R plus P bar Q R plus P Q bar R. Which option is correct? C. Which option is correct? C only. Array, screen not is visible. Very simple. PLA means what is the full form? Programmable logic array. They will ask. AND gate is programmable as well as OR gate is also programmable in this. So PLA, PAL and what? ROM. There are three devices, PLDs. These are called programmable logic devices. To get the difference between ROM, PLA and PAL. Now tell me, this is again a very simple question. The minimum number of JK flip-flops required to construct a synchronous counter with the count sequence. Okay, tell me. Okay, then guys, the minimum number of JK flip-flop, which option? C? No, that is the highest counting is what? 3. So highest counting is what? 3. Then what is the counting here? 0 0 1 1 2 2 3 3. So there are 2 zeros. So when we are writing 0 1 2 3, actual counting is what? 0 0 0 1 1 0 and what? 1 1. Then 2 JK flip-flop is required. But here there are 2 zeros, 2 ones, 2 twos, 2 threes. Then we have to represent it like this. 2 zeros. So you will represent 0 0 0 and another 0 is represented by 1 0 0. 2 ones. So 1 0 is 0 1 0 1. You have to put 1 0 here, 1 1 here. That is the 2 ones. Similarly 2. So 1 2 is 1 0, another 2 is 1 0. You have to separate it by 0 and 1. MSB you have to change. 3 1 1, another 3 1 1. Required, guys. 3 flip-flops are required. Okay. What is the technical issue, guys? 1 minute, give me 1 minute. So please tell Okay. Now I think now it is everything is fine now. Okay. So 3 flip-flops are required, not 2 flip-flop. Counting, watch the counting here. That is important. Then next one. Consider the following statement in Johnson counter. Which of the statement is not correct about the Johnson counter? Tell me. Which of one of the statement is not correct about the Johnson counter? Then a mod 6 Johnson counter requires 3 flip-flop. Yes, if it is a 3 counting 2n, then how many flip-flops? 3 flip-flop is required, you will get the 6. First statement is correct, but that's why this is not the answer. Johnson counter requires decoding gates. If there is any decoding gate is required in Johnson counter, Johnson counter we are using the decoding gates, and 2 input AND gates are required to decode the each count. 1 logic gate is used. This is also correct. Mod 6 ring counter require 3 flip-flop. That is wrong. Mod 6 ring counter require what? 6 flip-flop. Sorry, there is some technical issue, I think. So it is required 6 flip-flop in ring counter. If you want the 6 T state, it will require 6 counter. At a time, one output is 1, all other are 0. So this is called ring counter. And Johnson counter is called switch tail ring counter. Switch tail ring counter, guys. Now 2 questions from microwave, and after that Saket sir will join. Saket sir will join us. Okay, so stay tuned with us, and please like the session, subscribe our channel. Monday I am going to take one session on microwave. That is the microwave. Complete revision of the microwave in 1 hour. 4-port microwave passive device has scattering matrix of. This is the matrix. We are having the S. Today it is a okay, guys. Now I think now it is visible. Last question.
Hello guys, good afternoon everyone. So welcome to BYJU'S exam prep, and here we are going to start with the questions of the advanced communication, communication system and electromagnetic theory. So few students were asking about the important topic of the communication, so I will discuss that also. Good afternoon Ankit, and good afternoon EC lover. So guys, this is about myself. So my name is Saket Verma, and I'm having more than 13 years of experience. I have done MTech from IIT Guwahati, And these are the some PSU exams and obviously the gate exam that I have cracked. I have also now I started teaching the signals and system and ICT also in the for the ESE and the gate so you can watch those sessions as well. And this is my Telegram group. You can join this Telegram group for connecting with me, and if you need any help from my side for your preparation, either it is gate or any other PSU exam, you can ask me. And okay, so this is the EC for EC, and for any other branches we have all India open mock test, and this is free for all of you. So that is the booster for your preparation journey. And here we are having the complete schedule of the test series. So it is from the 16th of December to 22nd of December it will be live. So you can register for this in the link given in the description. And there is one more thing that in the link itself, in the description itself, there is one more link for the revision of the ISRO examination. So there is a playlist, separate playlist for the revision of the ISRO examination. So that also you can join. Now this is the one of the basic question that I am asking you, and I will give you 1 minute for every question, and then I will explain it that how it can be answered. The electromagnetic wave incident on a perfect conductor. What will be the result answer of this? An electromagnetic wave incident on a perfect conductor. Okay, so what is the answer of this question? Last 10 seconds left. An electromagnetic wave incident on a perfect conductor, whether it will be entirely reflected, fully transmitted, partially transmitted, or none of this. What will be the answer of this question? So as the 1 minute has gone, yeah, so one answer I have got from the EC lover, that first of all that you should know that what is the value of eta. In general, the value of eta is j omega mu divided by sigma plus j omega epsilon, right? And if it is talking about the perfect conductor, so for perfect conductor we will write the sigma equal to infinity, and hence that is going to give us the 0. So the wave incident from any medium, it does not depend on the which medium it is transmitting. If it is any medium, there is any medium other than the perfect conductor, obviously, because the wave will travel according to that. And here we have a perfect conductor. Okay, so the wave is incident from this medium, and this is perfect conductor. So it is asking for whether it is transmitted or not. So this is the reflected wave. Okay, this is reflected, this is transmitted, and this is incident. Now if I say that eta 2 minus eta 1 divided by eta 2 plus eta 1, then the reflection coefficient, because eta 2 is 0, this perfect conductor, so perfect conductor has the impedance 0, so it is minus 1. So irrespective of the medium of the first, irrespective of the impedance of the first medium, the reflection coefficient will always be minus 1, and the reflection coefficient is nothing but the ratio of reflected electric field divided by incident electric field, and hence the reflected electric field will be minus of incident electric field. So the whole wave will be reflected. So that is why the correct answer would be option A. Okay, Nandesh, so correct answer would be option A, because all the signals will be reflected, and this minus sign shows that the reflected wave will be opposite to the incident wave. Incident wave is the right hand side, then the reflected wave is in the left hand side. So that is why this minus sign is coming, which tells us the direction of electric field, that is in the negative x direction or negative z direction, whatever it is. Now answer this. Okay, so as you can see that it is given in that in this there is a lossless line. So lossless line with the 50 ohm is terminated to a 100 ohm resistive load. Okay, so the load impedance is 100 and the characteristic impedance is 50. So how can we calculate the reflection coefficient? The reflection coefficient is ZL minus Z0 divided by ZL plus Z0. So it is 100 minus 50 divided by 100 plus 50. So it is 1 by 3. Okay, it is 1 by 3. Now, what is the standing wave ratio? The standing wave ratio VSWR is 1 plus magnitude of gamma divided by 1 minus magnitude of gamma. So it is 1 plus 1 by 3 divided by 1 minus 1 by 3. So it is 4 by 3 and it is 2 by 3. So it is 2 ratio 1. So 2 is to 1 will be the right answer. Okay, there is one more way to solve this problem, that since the load is resistive in nature, okay, since the load is resistive in nature, the standing wave ratio is nothing but the and the load is greater than the characteristic impedance. Load is resistive in nature and the load impedance is greater than the characteristic impedance, then this is ZL upon Z0, which is 100 upon 50, which is equal to 2 by 1. So that is the answer. Okay, 2 is to 1. If the load is resistive, then we can write, because the standing wave ratio is always greater than equal to 1, then you should always take care of that the standing wave ratio should always be greater than 1. So according to that your calculation should be done. If you are suppose getting the answer which is less than 1, then obviously you are doing some calculation mistake, you know? So it means that this 1 by 2 and this 1 by 4 are eliminated just by looking into the options. Because it is asking for VSWR, we can eliminate these two options. So now I have to choose between B and C, and when the load is resistive in nature and load is greater than the characteristic impedance, then to make the standing wave ratio greater than 1, we have to keep the numerator greater than 1. Numerator numerator should be higher than the denominator. So numerator should be higher than the denominator. So that is why we will get 100 divided by 50. Okay. Yes, Akbar, I will convey your message to our team and we will try to conduct one more mock test for purely for the electrical. Okay. Now answer this question. This is the phase constant beta. Okay. Okay, so as you can see that in this question, the beta L is equal to pi is given and we want to calculate the length. So this is pi by beta. Okay, so we are looking for the beta value actually. So a lossless transmission line segment has a characteristic impedance Z0. Electromagnetic wave is traveling with the velocity 0.8 times and the frequency is also given. So we can easily calculate it, the length, no issue at all, easy one. The separate calculation we are doing here. So as you can see that the Vp is 0.8 into C and beta we want to calculate, which is nothing but the omega root over LC. Okay, omega root over LC. And we have these two values, and for the lossless it is 1 upon root LC and characteristic impedance is root over L by C. Okay, characteristic impedance is root over L by C. Now what you can do the multiplication. The characteristic impedance is given as 100. This is 100 ohm. So this is given as 100. Now when you multiply this, you will get 0.8 into 3 into 10 to the power 8 into 100 equal to L. So L, the value of L will be, from here you can calculate. This is 24 into 10 to the power 9. Okay, so this is the value of L, but it should come as a negative. Wait, I am multiplying now. Okay, so I am multiplying, then we will get this as C. So when we are multiplying, this root L will get cancelled and we will get 1 upon C. So this is the value of 1 upon C. When we divide it, so 0.8 C divided by Z0 is 1 upon root LC, and here it is root over L by C. So this time 1 upon L. So 1 upon L will be 0.8 into 3 into 10 to the power 8 divided by characteristic impedance, which is 100. Okay. So just thinking that can be solved by some other way. Beta I want to calculate. Okay, so we have got this 1 upon C equal 24 into 10 to the power 9 and 1 upon L equal to 0.8 into 3, that means 2.4 into 10 to the power 8. Yes, correct. This is quite lengthy, na? So from here, when you multiply both of them, you will get 1 upon LC, which is 24 into 10 to the power 9 and 2.4 into 10 to the power 8 divided by 100, and then you can calculate 1 upon root LC by taking the square root of this 24 into 9 into 2.4 into 10 to the power 8 divided by 100. Then 1 upon root LC, the value of 1 upon root LC you can put here and then you can calculate. One more formula is that we can directly calculate this beta is equal to omega by Vp. Okay, so the omega is 2 pi into frequency. That is why we have the frequency as well. That is 100 megahertz. Vp is 0.8 times of C. C is 3 into 10 to the power 8. So this 10 to the power 8 will get cancelled and we will get 2 pi divided by 2.4. Okay, 2 pi divided by 2.4. So this is radian per meter. Okay, this is radian per meter. No, it is related to the electromagnetic wave, not from the power system. In the transmission line, somewhat there are some terms which are related to your power system also. But this type of question you may get in the power system basic questions. So beta we have got. Now we know that the beta L was equal to pi. So the L is equal to pi by beta. So this pi upon beta is 1.2. Okay, the pi upon beta when you calculate it is 1.2. So there are two ways, and you can choose the shortcut one because it was going bit lengthy. So here we calculated L, C, and then we will substitute. There are square root also that we need to solve. So it is not the good idea to solve by this because it is 24 into 10 raised to power 7. You will get 1 upon root LC, and then you can solve it. Okay, so there we have the two ways. Suppose in this question, suppose they would have asked about the inductance and the capacitance, then we would have followed that procedure only. ओके अगर सपोज करो कि यहाँ पे इंडक्टर और कैपेसिटेंस निकालना होता तब तो हमको यही मेथड ही फॉलो करना पड़ता, ठीक है, लेकिन हमको यहाँ पे जो कैलकुलेट करना था वो काफी इजी था, हम उसको जबरदस्ती लेंदी कर रहे थे. नाउ आंसर दिस. Okay, so we know that the characteristic impedance in this case, the characteristic impedance is given by root over ZSC into ZOC. So this is 5 into 20 equal to 10. Next, answer is the wavelength of 100 megahertz electromagnetic wave through a perfect non-magnetic dielectric with the relative permittivity epsilon r is. Okay, what is the answer? So the lambda is equal to, बिना गेट के लिए भी आएगा, गेट के लिए भी आएगा, इस वीक इस मंथ में एक ना एक होगा ही, Vp upon F. So Vp is nothing but C. Okay, C upon root over epsilon R into 1 upon F. So C हो जाएगा 3 into 10 to the power 8 and root 9 into 100 megahertz. So यहाँ से हमारे पास आ रहा है 1 मीटर. So बोल सकते हैं हम 100 सेंटीमीटर. ऑप्शन सी. ठीक है. नेक्स्ट. Yes, Nandesh. Mu R will be 1 permeability. If the pulse repetition frequency, this is the question from the radar, and you know that in the ISRO radar, questions from the radar and the range equations can also come. So that is why there is one basic question from the radar, that to give you an idea that the questions can be there from the topic radar. Microwave also important, basic of microwave. One answer I have got, other students can also answer this question. So as you can see that if you want to calculate the duty cycle, so how do you define the duty cycle? Okay. How do you define the duty cycle? Duty cycle is nothing but T on divided by T on plus T off. Okay, and T on means the duration at which you are transmitting the pulse. So that is nothing but the pulse width. Okay, T on is nothing but the pulse width, and T on plus T off is the total time. Okay, so total time you can say, and the inverse of the time is nothing but the frequency. So you have given with the pulse repetition frequency. Pulse repetition frequency means after which time. The inverse of pulse repetition frequency is the time at which you are transmitting the signal. So when you will transmit the signal back, when the total time will be finished. So suppose you are transmitting the pulse in this duration right here, and now then you are waiting for the reflected wave, because in the radar you will wait for the reflected wave. So this is T on and this is T off, and then you will again start sending the pulse. So in this duration you are doing the wait. Okay, so you are waiting for the signal to come back from the reflection. After reflection, that is known as echo signal. So T on plus T off will be the total duration of the signal, and the inverse of that is nothing but the pulse repetition frequency, that is the pulse is repeating after this time. So now it is pulse width, which is 1.5 microsecond and 1200. Okay, so when you multiply it, you will get the 0.18, right? 0.18. 1.5 into 1200. Yeah, so 0.18%. So right answer is option number C. Next. Okay, so now in this question, what is the answer? You guys have got C option you are getting. Okay, so here it is the phase constant we want to calculate. The phase constant is omega by C. It is given as the lossless. Okay, mu r into epsilon. This is given as lossless. So omega is your 2 pi into frequency, which is 50 into 10 to the power 6, and C is 3 into 10 to the power 8. Mu r is 1 and epsilon r is 2.25. So it is nothing but the 50 into 200, 100 into 10 to the power 6 is 10 to the power 8. So it is pi by 3 into 1.5. So it is pi by 2, correct. Pi by 2 radian per meter is the right answer. Option C. Yes, that's the correct answer. Okay, coming to the next one. Okay, so what is the answer you are getting? The loss tangent. Okay, so what is the value of loss tangent? The loss tangent is sigma upon omega epsilon. Okay, now we will put this sigma. What is sigma? The conductivity is 10 to the power minus 14. Omega is 2 pi f 2.5 into 10 to the power 6 and epsilon naught into epsilon r. So epsilon r is given. So 10 to the power minus 9 divided by 36 pi, and this is 2.25. So what is the value? So this is 2 pi, this is 18 you will get, and then when you will solve it, this is 100, and from here you will get 10. Okay, so this is 10 to the power 3 and 10 to the power 3 here, so it will be 3. So let me write it. 10 to the power minus 14. Here we get 25 into 225 into 10 to the power 3 into 10 to the power minus 9. Okay, so it will be minus 3, and then it will go in the numerator, it will be plus 3, and 11 it is 10 to the power minus 14 we are getting now. So I think after solving this we should get the 0.32. Let me calculate. Yeah, 0.32 na? 0.32 should be the answer. Check once. 10 to the power minus 14 is such a high value. Okay, 118 is also there. This 18 is also there. 18 is also there. Check the calculation. Okay, so we should get the answer as 0.32. 0.32 should be the answer. Any term if I am forgetting, then just note it down. Okay, 0.32 should be the right answer. Yes, 0.32 should come. Maybe this 10 to the power minus 14, I think if you are getting this particular factor, then it will be right. Otherwise, none of the above. Okay, let me do this by the calculator once so that we can get the exact answer. So 10 to the power minus 14 minus 14, and then 2 pi f was 2.5 into 2.5 into 10 to the power 6, then 8.85 into 10 raised to power minus 12, then 2.25. Okay, so there is some mistake in the power, that is in the 10 power. I think it is, if I take 1 4, then what is the value? Actually, it is only 10 raised to power minus 4. Only it is 10 raised to power minus 4. Then only we will get the exact answer. Otherwise, your answer is correct, none of the above. But the actual question was having 10 raised to power minus 4. So there is a typing error. So there is a typing error. Then according to that, you will get the answer. 10 raised to power minus 4. Okay. 0.32 will come, and that will come when it is 10 raised to power minus 4. Yes, Ankit, your answer was right. Just 10 raised to power minus 4, there was a typing mistake. So the answer is 0.32. Now you will get the answer. There is a typing mistake there. Okay, so what is the answer of this question? Okay, you are getting skin depth we want to calculate. So what is the skin depth? It is a solid conductor. So in the conductor skin depth is 1 upon root over pi f mu sigma. Okay, or you can also write it as 1 upon root over, if you divide it and multiply it by 2, then it is omega mu sigma by 2, or you can write in this way, 2 upon omega mu sigma. Okay, so now 2 upon omega you will get here. So pi into 10 to the power 4 is omega, and 4 pi into 10 raised to power minus 7 is your mu naught. Is there mu r? Mu r is not, yes, mu r is given, which is 200. So it is 200. And what about sigma? This is the conductivity sigma. So it is 5 into 10 to the power 6. Now it can be solved. So 2 upon, this is 4 pi square into 10 raised to power 6, and 200 into 5 is 1000. So 10 raised to power 7. This 10 raised to power 7 and this 10 raised to power minus 7 will get cancelled. We will get with only 5 into this. Okay, so It is 0.7 something. 1 by root 2, so 0.707 divided by pi millimeter. 0.225, yes, 0.225 will be the answer. Calculator is not allowed, but this is the question that you can expect in the ISRO examination. There is a calculation, normal calculation, okay, that you have to do this smartly. You have to do some approximation to get the appropriate answer. Like here, this is, I have taken 3 and this I am taking as 0.6, so I will get 0.2. So 0.2 is only one option we have. Okay, I am approximating it like this. This is 0.6 and this is 0.3. So when it is approximating, you are getting 0.2. Okay, because you can see that the options are 0.1, 0.2 and 2.2. So it is sure that we will get less than 1. So either we are starting with 0.2 and we getting 0.1. That is what we have to just check. And we are getting 0.2 first. So then we are saying that answer is B. Now answer this question. You can expect such type of question. This little bit calculation will be there. It is not that you will get them one-liner answer every time. Determine the energy density. What is the answer? Energy density you want to calculate, it is half mu h square, right? That is the energy density. So 1 by 2, it is 4 pi into 10 to the power minus 7. H square is 10 to the power 6. So it is 2 pi into 10 to the power minus 1. That is 628. 6.28 in, that is 0.628. That is 628 millijoules. So there are two options actually. There are a lot of typing mistake this time. 628 millijoule is the right answer. 628. They have done the mistakes in the units. 314, one is micro and another is milli. Yes. 628 millijoule. Now answer this. No, question is not blur. Question is clear. You have maybe network problem. Okay, so how do we solve this? There are infinite sheets and electric field because of infinite sheet is sigma upon 2 epsilon naught. Okay, just we need to check the direction. This is y equal to 7, this is y equal to 7, and we want to calculate y equal to 6. That means we are going in the downward direction. So sigma, this is the sigma. Okay, so this is 20 into 10 raised to power minus 12 divided by 2 into epsilon naught, and here you can see that y equal to 7 and y equal to 6. That means it is in the negative direction. So minus ay plus, here it is minus 8 into 10 raised to power minus 12 divided by 2 epsilon naught, and y equal to 3 to y equal to 6, so it is positive. Then it is 6 into 10 raised to power minus 12 divided by 2 epsilon naught, and y equal to minus 1 to y equal to 6, so it is again positive. Then it is y equal to minus 4 to 6, again it is positive. So minus 18 into 10 raised to power minus 12 divided by 2 epsilon naught and ay with the positive. So here we will get 20 minus 8. Okay, 20 minus 8 plus 6. So you can add this 26 and this is 18 and 8. Wait, 6 and 18. No? So 26 and 18 and 8 is also 26. So we get 0. 20 minus 8, 6 and minus 18. So we have minus 20. Okay, minus 20 minus 8 plus 6 minus 18. Just we need to add this only, na? Divided by 2 epsilon. So it is 28 plus 18. How much it is? 46, 40. So it will be 40 upon 2 epsilon naught with minus sign, and permittivity is taken as 1. So it is into 10 raised to power minus 12. So we can write minus 40, this is all ay. So minus 42 into 10 raised to power minus 9 divided by 36 pi into 10 to the power minus 12. So it will be 18 pi in the numerator, and in the denominator we have a 40 and divided by 1000. So yes, it is 18 pi divided by 25 ay cap with minus negative direction. But we want to calculate the magnitude, so answer is 18 pi minus ay. Anyone having any doubt in this? Electric field will be this. All the parameters are common. So the direction is negative, but it is asking only for the magnitude. So it is minus 18. What is the volume charge density when the flux field, electric flux density is given? Calculate it. Don't tell me how to calculate. Just answer it within the time, because you will not get more than this much time to solve any problem. So we want to calculate the volume charge density. So the volume charge density rho v is equal to divergence of d. And how to calculate the divergence? Just differentiate with respect to x with the x component. So you will get y square, and when you differentiate this you will get x square, and when you differentiate this you will get 1. So when we put the value of y equal to 2, it is 4. When we put the value of x, it is 1, and it is also 1. So 4 plus 2 is 6. Yes, 6 is the right answer. Okay, now the question is from the communication. We have 8 questions from the communication, then 4 questions from the advanced communication. Okay, so what is the data rate RB, maximum data rate that can be transmitted using the QPSK? You are getting A. So RB is the data rate for the normal PSK, BPSK if I say, and if I am saying that it is QPSK, then it is the symbol rate, which is bit rate divided by log base 2m, and the bit rate divided by the bandwidth is also given, na? Okay, so let me do in this other way. So the bandwidth is also given. So the what is the bandwidth formula for the in general for your BPSK? This is for the BPSK in general. Okay, in general for M array PSK, right? For this is the for now, but here the roll-off factor is also given. So replace this RB by 2 1 plus alpha. So when you replace the RB by 2 1 plus alpha, you will get this. Now we want this bit rate. So RB is equal to bandwidth multiplied with log base 2m divided by 1 plus alpha. What is the bandwidth? It is 36 into log base 2 4, because quadrature shift keying means 4 symbols and 1.2. So it is 36 into 2 into 10 upon 12. So it is 60 Mbps. 60 Mbps would be the right answer. 50 Mbps. 60 Mbps. हाँ, गेट ईसी का एग्जाम 11 फरवरी ये जो आया था वही रहेगा, है ना? विच चैप्टर इट इज रिलेटेड टू शो, इट इज द कम्युनिकेशन, इट इज अ सब्जेक्ट फ्रॉम द कम्युनिकेशन. Okay, so here we have the center frequency or the bandwidth. First step we will follow, the bandwidth is 20 kilohertz. Then we will calculate the K, which is highest frequency divided by bandwidth. So highest frequency is 410 divided by 20. So it will be 20.5. So the K value of K is 20. So the sampling frequency is 2 fH upon K. So 2 into 410 divided by K. So it is the 0 and 0 will get cancelled. Yes. So 41 kilohertz would be the right answer. 41 kilohertz would be the first step, second step and third step. 3 steps. Now answer this. Yes, because it is not a sinusoidal signal, we will say that it is proportional to the number of bit. So 12 into 6, that is, we will take the 6 into n, and 6 into n is nothing but the 72. If it is sinusoidal given in the question, peak voltage is only given 0.25. It is not saying the peak to peak voltage. So we cannot say that it is 1.76 plus 6n. It is only for the sinusoidal. Okay, it is only for the sinusoidal. So if we would have applied, the answer could be the 74. But because it is not mentioned in the question that it is a sinusoidal, then we will take it as a 6n and then we will get 72. What is the answer of this question? No, last question answer was 41 kilohertz per. So we have to calculate the noise figure. Noise figure is nothing but the ratio of input signal to noise ratio divided by output signal to noise ratio. We want to calculate the output signal to noise ratio. So output signal to noise ratio is input signal to noise ratio, which is 10 to the power 3.7, because it is given in dB. So we will calculate that, and 10 to the power 37 divided by 2. So it is 2505.9 something. So we have to take 10 log 2505. It is coming as 34 dB. So answer is 34 dB. Okay, you cannot calculate directly in the dB, right? You cannot calculate directly in dB. You have to calculate in the normal value. And I can understand that you will say, sir, it is how we will calculate the log value, right? But in the ISRO, you have in the previous year question, if you would have seen, they asked the question in this way. So you have to answer it. Just try to figure out some how you will get this answer. Okay, that 2505. How can you approximate it into log? When you take the log, then how can you approximate? That you have to learn somehow. This is nothing but a 10 log of 2505. Okay, the 10 log of 2505 is 30. Both of you are getting A. So what is the mean value? Let us say the mean is 3 into 0.2, 1 into 0.3, the value and its probability. So the mean is 0. Mean is 0. What about the mean square value? The mean square value is value square and its probability. Value square and its probability. Value square and its probability. And its square is its probability. So it is 9 into 2. And it is 0.3. It is also 0.3. And it is 9 into 0.2. So yes, 4.2. 4.2 is the right answer. It is coming as 4.2, and we know that the variance is equal to mean square value minus mean whole square, and mean we have got 0, so the mean square value will be final answer. So mean square value is 4.2. Next. D? No, see, when this code will be valid, what is the condition for the validation? The C into H transpose should be 0. A valid code word will be there when the C into H transpose is 0. And to get this, how you will calculate? This is the code and this is the H transpose. So what you can do is you can write the code and you can take the H transpose. This is the H matrix. You can write the H transpose like 1 0 0 1 0 1. This is the code, and then you can write the H transpose by taking the transpose 0 1 1 1 0 0 and then 1 0 1 0 1 0 and then 1 1 0 0 0 1. Okay, so after calculating it, if you get the 0, then it is valid, and if it is not equal to 0, then it is not valid. Okay, that is the procedure. So here when you solve, it will not be 0. But what will be the shortcut? You have to just check whether in which place of the code there is the 1. So this is the 1 in the first. Okay, for option A, I am telling you that for option A, the 1 is present in the first place. So you have to take the first column of H matrix. So 0 1 1. Then you have to take the mod 2 addition. Remember that mod 2 addition. Second, third, fourth position, you have the 1. So take 1 0 0. then fifth, sixth, then sixth position you have 1. So take the sixth column of the edge. Then you take the mod 2 addition. So mod 2 addition, you will get 1 here, you will get 1 here, you will get 0 here. So it is not coming all 0. So A cannot be our answer. A cannot be our answer. For similarly for option B, you will check for option B all the starting for except the except this one, except this column, we have all values present. So when you take XOR, you will get 1, you will get 0 here, you will get 1. So again it is not equal to 0, so B cannot be the answer. Now you will check for C. So it is second and the second last. So this is second and the second last. These two row we have to take. So 1, 0, it is 1. Then 0, 1, it is 1. Then 1, 0, it is 1. Again. So it is again not coming 0. Hence the option C cannot be the answer. So definitely option D should be there. And except this third and the last. This is when you take 1, 1, it will be 0. It is 1, 1, it is 0, it is 1, 1, it is 0. So right answer is option D. Right answer is option D. Akansha, now questions from the satellite. In a satellite ground station, the received signal is directly amplified in a low noise parametric amplifier followed by a FET amplifier. The gain and the effective noise temperature of the amplifier are 29 degree Kelvin and 10 dB, 200 degree Kelvin, the effective noise temperature. The effective noise temperature is given by TE1 plus TE2 divided by gain of first. So what is the time temperature? 9. What is the temperature of second? It is 200 already given in Kelvin. What is the gain of the first? Gain of the first is 20 dB. So it is given in the 20 dB. So this is 10 log of gain of first. So this is G1 is equal to 100. So G1 is equal to 100. So this 0, 0 cancel. 9 plus 2 is 11. So you will get 11 degree Kelvin. 11 degree Kelvin. That is the answer. 61. Now try answering this one. The cutoff wavelength for an optical fiber with the 5 micrometer core diameter and a core cladding indices of refraction is 1.484 is nearly equal to. Okay, now what is the solution? We want to calculate the cutoff wavelength. The cutoff wavelength is 2 pi d into numerical 2 pi a, in fact. D is the diameter, so we can write is in the diameter only. So pi d into numerical aperture divided by V number, and for cutoff wavelength the V value should be 2.405. So the pi and the d is 5 into 10 to the power minus 6 root over 1.484 whole square minus 1.402 whole square divided by 2.405. So answer is, see, this question has been asked in the ISRO examination for regarding the cutoff wavelength. The same, more or less same question, not exactly the data, but the this type of calculation you have to do in the ISRO examination. So just be ready for this type of calculation. Don't think that this is the lengthy question, so we should leave and we will solve any other questions. There is a chance that you will get again the 20 to 30% question like this. Then you cannot leave all the 20-30% question because of the lengthy calculation. So the answer is 3 micrometer. The answer is 3 micrometer. Now there are 4 options for this, but I think they have missed that in the typing. Again, it is given in dB, then you have to solve it in normal value. So just tell me what is the formula for this. What is the formula for this? By default, single mode, Ankit, it is not by default. For cutoff wavelength, it has to be single mode. Okay, cutoff wavelength means single mode. We cannot say that by default single mode because it is asking for cutoff. That is why we took single mode. Yeah, so it is like a parallel combination. Okay, so parallel combination के लिए क्या हो जाएगा? 10 का पावर 2.45 multiplied with 10 का पावर 1.54 divided by 10 का पावर 2.45 plus 10 to the power 1.54. ये तुम्हारा ओवरऑल सिग्नल टू नॉइज रेशियो, कैरियर टू नॉइज रेशियो, ओवरऑल C by N. ओवरऑल C by N होता है तुम्हारा C by N फॉर अपलिंक, C by N फॉर डाउनलिंक डिवाइडेड बाय C by N फॉर अपलिंक प्लस C by N फॉर डाउन. ओके, तो ये फॉर्मूला हम लोगों ने अप्लाई किया है. हाँ, ये भी नॉर्मल तरीके से ही कैलकुलेट करना है और ये ऑलरेडी इसरो में आ चुका है पहले भी इस टाइप के. अब बिकॉज वी डोंट हैव राइट टाइम राइट नाउ, सो वी विल सॉल्व इट डायरेक्टली. एंड उसके बाद इसको लास्ट में आपको डीबी में आंसर बताना है ना. इसके बाद आपको लास्ट में इसका डीबी में आंसर बताना है. तो आपको थोड़ा सा रेडी रहना, मैं बोला आपको पहले से रेडी रहना पड़ेगा कि अगर इस टाइप का कैलकुलेशन मिलता है तो कैसे हम इसको शॉर्ट में सॉल्व कर सकते हैं, उसका पहले से सॉल्यूशन ढूंढ के जाओ. ठीक है, फिर इसको 10 लॉग लेना है. अब 10 लॉग लेंगे 30.8 का, तो कितना आना चाहिए कैसे पता चलेगा, है ना. तो वो थोड़ा टेबल को देखो कैसे हम अप्रोक्सीमेट कर सकते हैं, कोई ट्रिक सीखो. 14.88 dB ये आंसर होगा 14.88. चलो इसका बता दो, ये लास्ट क्वेश्चन है. इसके बाद ईशान सर नेटवर्क और मेजरमेंट का कंटिन्यू करेंगे. तो आप लोग कोई भी लीव नहीं करेगा सेशन को. ठीक है, लास्ट आपका हाफ एन आवर और लगेगा और उसके बाद आपका कंप्लीट हो जाएगा पूरा इसरो का मॉक टेस्ट. तो आई होप कि आप लोग को यूजफुल लगा है सेशन. और ये बस लास्ट क्वेश्चन है, ये तो इसमें कोई कैलकुलेशन नहीं है, आप इसको इजीली बता सकते हो. ठीक है, तो एक आंसर ऑलरेडी मेरे पास आ गया है, दैट इज ऑप्शन नंबर सी, है ना. ग्रेडेड फाइबर में क्या होता है, ग्रेडेड फाइबर में कोर एक्सिस पे मैक्सिमम होता है और जैसे जैसे आप कोर से क्लैडिंग की तरफ जाते जाओगे द रिफ्रैक्टिव इंडेक्स ग्रेजुअली डिक्रीजेस. ओके, so guys stay tuned. I am calling Ishan sir and he will be joining you. Okay. Okay, this Telegram group, you can get the PDF of the whole session. So you can join this Telegram group. And thank you for watching this session, guys. And now the Ishan sir will continue. Okay, so I am stopping the session and the Ishan sir will be there for the next question from the 65 to 80. Thank you.
Hello everyone, welcome to BYJU'S exam prep. So I hope everybody is doing well. और कैसे गए आपके सेशंस? तो एज यू नो कि हमारा इसरो का मॉक टेस्ट चल रहा है एंड साकेत सर ने अभी क्लास खत्म करी है. नाउ फ्रॉम दिस मोमेंट आई एम गोइंग टू स्टार्ट द क्वेश्चंस बेस्ड ऑन नेटवर्क थ्योरी एंड मेजरमेंट्स. सो अगर आप नेटवर्क थ्योरी सब्जेक्ट के लिए बोलोगे, नेटवर्क थ्योरी इज वेरी वेरी इंपॉर्टेंट सब्जेक्ट फॉर एनी ऑफ द एग्जामिनेशन, चाहे वो इसरो का हो, गेट का हो, कोई भी एग्जाम हो. तो हम लोग नेटवर्क थ्योरी से स्टार्ट करेंगे. अप्रॉक्सीमेटली 10 to 12 क्वेश्चन हम नेटवर्क थ्योरी के सॉल्व करेंगे एंड देन वी विल सॉल्व क्वेश्चन ओवर द मेजरमेंट्स. नाउ मेजरमेंट्स के लिए वैसे ये ईसी का सब्जेक्ट होता नहीं है, बट अगर आप प्रीवियस ईयर इसरो के एग्जाम्स देखोगे तो कुछ 4 to 5 क्वेश्चन आपके मेजरमेंट्स से आए हुए हैं जो कि एक्चुअली बेसिक क्वेश्चन है. ऐसा नहीं है कि बहुत ही हाई फाई क्वेश्चन पूछ लिए, तो हम बेसिक क्वेश्चन ही देखेंगे उसके अंदर. उसके अंदर बहुत ज़्यादा गेट लेवल के क्वेश्चन नहीं देखेंगे. सो जल्दी से बताओ कौन कौन सेशन में लाइव है एंड ऑल्सो बच्चों सेशन को शेयर करो बिकॉज ये मॉक टेस्ट आपके लिए इंपॉर्टेंट है. जितना ज़्यादा आप मॉक टेस्ट में पार्टिसिपेट करोगे उतना ही हम डिफरेंट एग्जाम्स के लिए मॉक टेस्ट भी लेकर आएंगे. ओके, सो लेट्स स्टार्ट आवर सेशन. बिफोर दैट लेट मी इंट्रोड्यूस माई सेल्फ. माई नेम इज ईशान मुदगल. I have a 7+ year of teaching experience. MTech gold medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. And right now we are doing network theory. So before starting a session, let me give you quick information that we have launched the All India mock test. ये आपको काफी हेल्प करेगा. इस पर्टिकुलर टेस्ट में आपको डिफरेंट टाइप के टेस्ट मिलेंगे जिसमें डिफरेंट सब्जेक्ट्स है और मॉक टेस्ट भी है. सो इट विल हेल्प यू टू अंडरस्टैंडिंग कि आप कहाँ पर स्टैंड करते हो और कितना आपकी प्रिपरेशन में अभी लैग है या कितना आप कर चुके हो. तो ये ओपन होने वाला है आपका 16 दिसंबर से 22 दिसंबर तक. सो डोंट फॉरगेट टू रजिस्टर फॉर इट एंड गिव द टेस्ट एज मच एज यू कैन बिकॉज अभी जो टाइम है आपका रिवीजन का है. रिवीजन में जितने क्वेश्चन सॉल्व कर सकते हो उतने क्वेश्चन सॉल्व करो. ठीक है, सो लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन. सो दिस इज द क्वेश्चन ऑन योर स्क्रीन. सो क्वेश्चन नंबर 65 एज वी हैव ऑलरेडी सीन द 64 क्वेश्चंस टिल नाउ. सो बच्चों एक बात हो, जैसे ही कुछ बच्चों की प्रॉब्लम आ रही थी कैलकुलेशन कैसे सॉल्व करें, तो बेटा कैलकुलेशंस में आपके पास जो क्वेश्चंस आते हैं इसरो में वहाँ पे कैलकुलेटर अलाउ नहीं होता, आपके पास वर्चुअल भी नहीं है. बट आपको वहाँ पे अंडरस्टैंडिंग करनी पड़ेगी कि आपको अप्रॉक्स वैल्यू निकालनी है. आप अप्रॉक्स वैल्यू निकाल के वहाँ पे आंसर निकाल सकते हो, चाहे वो आपका एक्सपोनेंशियल वैल्यू हो या लॉग वैल्यू हो. ठीक है, सो ये क्वेश्चन आपकी स्क्रीन पे, ध्यान से इस क्वेश्चन को रीड करो और बताओ आंसर क्या होगा. 18 microfarad capacitor holding a charge of q coulomb is connected to the circuit at t equal to 0 second. The time at which the capacitor will be discharged to approximately q by 2.72 coulombs. अब इस क्वेश्चन को अगर आप ध्यान से देखोगे बच्चों, इस क्वेश्चन के अंदर ये आपका ट्रांसिएंट का क्वेश्चन है फर्स्ट ऑफ ऑल, और ये आपका प्रीवियस ईयर क्वेश्चन भी है. तो जल्दी से क्वेश्चन देखो, बताओ आंसर क्या होगा. आई विल गिव यू फ्यू सेकेंड्स टू सॉल्व इट. और मैं देख रहा हूँ बच्चों के सेशन काफी कम हो गए बच्चे. मतलब अगर आप एक पर्टिकुलर सेशन मॉक टेस्ट में ज्यादा लंबा नहीं बैठोगे बेटा, तो मॉक टेस्ट लाने का फायदा क्या होता है, राइट. तो लेट्स स्टार्ट सॉल्विंग दिस क्वेश्चन. तो सबसे पहले उन्होंने क्या बोला है कि आपका जो कैपेसिटर है वो डिस्चार्ज हो रहा है. कैपेसिटर की डिस्चार्जिंग इक्वेशन आपको पता है. कैपेसिटर की डिस्चार्जिंग इक्वेशन क्या होती है बेटा, Q इज इक्वल टू Q डैश e रेज टू पावर माइनस t बाई टाउ. दिस इज द डिस्चार्जिंग इक्वेशन फॉर अ कैपेसिटर, जिसके अंदर Q डैश होता है. ये क्या होता है आपके पास, इनिशियल चार्ज. तो क्वेश्चन के अकॉर्डिंग इनिशियल चार्ज दे रखा है आपको Q, और वेयर एज आपके पास जो फाइनल चार्ज है या जिस टाइम तक आपसे पूछा गया है वो है Q बाय 2.72. सो अगर मेरे पास इनिशियल चार्ज पता है और एक पर्टिकुलर चार्ज पता है जहां तक मुझे टाइम निकालना है, तो इसको सॉल्व करके आप निकाल सकते हो, राइट. सो टाइम कांस्टेंट मेन है यहाँ पे, टाइम कांस्टेंट निकालना. सो टाइम कांस्टेंट फाइंड करो, बताओ क्या आंसर होगा. अगर सिंपल सी बात करें, टाइम कांस्टेंट किसके इक्वल होता है, R इक्विवेलेंट मल्टीप्लाई बाय C. तो मुझे इसका इक्विवेलेंट रेजिस्टेंस फाइंड करना है. ठीक है, कैसे फाइंड करोगे, ट्राई करो. एंड बच्चों अगर आपको लग रहा है कि अभी के लिए कैलकुलेशन ज्यादा है, तो अभी के लिए आप कैलकुलेटर यूज कर सकते हो. अदरवाइज ये जो क्वेश्चन है ना, आपका प्रीवियस ईयर इसरो का ही क्वेश्चन है. तो ट्राई करो जितना आप लेस कैलकुलेटर यूज करो. ठीक है, बट अभी प्रैक्टिस के लिए आप अभी के लिए कर सकते हो. ठीक है, सो यहाँ पे अगर मैं बात करूं, सबसे पहले मैं इसको डेल्टा को स्टार में चेंज कर सकता हूं. We can convert the delta into star. वी कैन कन्वर्ट डेल्टा इनटू स्टार, है ना। इस तरीके से स्टार में हम इसको चेंज कर सकते हैं। तो अगर इसको स्टार में चेंज करोगे तो कितना हो गया, 6 + 4 10 + 2 12। तो यहाँ पे अगर आप स्टार फॉर्म में लगाओगे सो इट विल बी लाइक दिस। स्टार फॉर्म में अगर आप इसको देखोगे तो इट विल बी लाइक दिस। किसी को स्टार डेल्टा नहीं आता हो तो बेटा पढ़ लेना, स्टार डेल्टा आपके लिए इंपॉर्टेंट है। स्टार डेल्टा आप लोगों के लिए इंपॉर्टेंट है, अगर नहीं आता है तो प्लीज पढ़ लेना इस चीज को। तो यहाँ पर क्या होगा, 6 × 2 = 12, यहाँ पर कितना हो गया 1 किलो ओम, ठीक है। यहाँ पर कितना है 6 × 4 = 24, यहाँ कितना हो गया 2 किलो ओम। फाइनली यहाँ कितना आपके पास 4 × 2 = 8, 8/12, तो मतलब हो गया 4 से काटोगे 2/3, 2/3 किलो ओम, राइट। और यहाँ पर हो गया 3 किलो ओम, और यहाँ पर कितना है 12 किलो ओम, यहाँ पर कितना है 12 किलो ओम। और जो स्विच है, स्विच क्या हो रहा है, स्विच आपका क्लोज हो रहा है, स्विच आपका क्लोज हो रहा है तो स्विच क्लोज कर दिया, और यहाँ पर कैपेसिटेंस आ गया 18 माइक्रोफैराड, कैपेसिटेंस आ गया 18 माइक्रोफैराड, ठीक है। अब इसको सॉल्व करो। अब मुझे सबसे पहले आर इक्विवेलेंट फाइंड करना है। आर इक्विवेलेंट आप कैसे फाइंड कर सकते हो, कैपेसिटर टर्मिनल से चेक करो, कैपेसिटर टर्मिनल से चेक करो। आपको ये दोनों सीरीज में दिख रहे हैं, ये दोनों सीरीज में दिख रहे हैं, आपस में पैरेलल, तो मैं लिख सकता हूं आर इक्विवेलेंट क्या हो गया, ये दोनों सीरीज में है तो 4 प्लस ये दोनों सीरीज में है 14, सॉरी माय फॉल्ट, आपके पास 4 और 14 दोनों आपके पास क्या है, पैरेलल में है। ध्यान से देखो, ये दोनों सीरीज में हो गए 3 + 1 4, ये दोनों सीरीज में हो गए 12 + 2 14, आपस में ये दोनों पैरेलल में है, प्लस 2/3 किलो ओम के साथ सीरीज में है, प्लस 2/3 किलो ओम के साथ सीरीज में है, राइट। 3.78 अंकित 3.78 क्या है ये, मतलब रेसिस्टेंस निकाल रहे हो क्या फाइंड कर रहे हो मुझे बताओ। 4 × 14 डिवाइड बाय 4 + 4 18 प्लस 2/3, इसको अगर मैं सॉरी 2 से कैंसिल करूंगा 28/9 प्लस 2/3, तो हो जाएगा 34/9, 34/9 किलो ओम, 34/9 किलो ओम आ रहा है आर इक्विवेलेंट, ठीक है। सो 9 × 27, हाँ उसी के आसपास आएगा, उसी के आसपास आएगा, करेक्ट। अब आपको टाइम कांस्टेंट निकालना है। टाइम कांस्टेंट क्या है, टाउ। सो आर इक्विवेलेंट मल्टीप्लाई बाय सी, कितना हो गया 34/9 मल्टीप्लाई बाय 18, मल्टीप्लाई बाय 18 कितना हो गया 9 × 2 = 68, 2 × 4 = 68 मिली सेकेंड्स। टाइम कांस्टेंट क्या है 68 मिली सेकेंड, क्यों, बिकॉज ये आपका किलो ओम में है, ये आपका माइक्रोफैराड में है, तो कितना हो गया 68, कितना है 68 मिली सेकेंड। नाउ क्वेश्चन क्या है, व्हाट इज द टाइम टू डिस्चार्ज टू अप्रोक्सीमेटली Q/2.72। अब मुझे बताओ 1/2.72 कितना होता है, एक बार सोच के बताओ 1/2.72 कितना होता है। यूज द कैलकुलेटर, यूज द कैलकुलेटर एंड टेल मी 1/2.72 कितना होता है। 36.76, 36.76, देखो दिमाग लगाओ। इसरो में कैलकुलेशन कैसे होती है, इसरो में कैलकुलेशन कैसे होती है, दिमाग लगाओ। उन्होंने लिख दिया है 1/2.72, क्या मैं ये बोल सकता हूं, क्या मैं ये बोल सकता हूं इट इज 0.36 टाइम्स ऑफ इनिशियल। ध्यान से देखो, Q/2.72 is actually 36% ऑफ Q, यस और नो, हम ये बोल सकते हैं, हम ये बोल सकते हैं। और डिस्चार्जिंग में बेटा 36% ऑफ Q किस पर होता है, टाइम कांस्टेंट पर ही तो होता है। डिस्चार्जिंग में 36% ऑफ इनिशियल वैल्यू कहां मिलेगा, टाइम कांस्टेंट पे। तो यहां पे आंसर कितना हो गया 68 मिली सेकेंड, 68 मिली सेकेंड। तो बच्चों इसरो में कैलकुलेशन ऐसे होती है। अब नॉर्मल बच्चे क्या करेंगे, अगर आप लोगों को नहीं पता है तो नॉर्मल बच्चे क्या करेंगे, यहां पर वैल्यू पुट कर देंगे। नॉर्मल बच्चे क्या करेंगे, यहां पर वैल्यू पुट कर देंगे और फिर बोलेंगे सर इसका लॉग कैसे ले, फिर बोलेंगे सर इसका लॉग कैसे ले, लॉग लेने की जरूरत ही नहीं है। 36% निकालना है, 36% क्या होता है, टाइम कांस्टेंट। आंसर 68 एकदम से। टाइम किस में लगा है, हाँ आर इक्विवेलेंट निकालने में टाइम लगा है, बट इतना आप एक्सपेक्ट कर सकते हो अगर आप इसरो का एग्जाम दे रहे हो, ठीक है। नेक्स्ट क्वेश्चन सॉल्व करो, सॉल्व करो। Determine the value of voltage V1 in the figure shown below। V1 कहां है, अच्छा V1 ये रहा, ओके फाइन, ठीक है। तो बेटा कैलकुलेशन से घबराना नहीं है, कैलकुलेशन की ट्रिक्स आपको समझनी है, ठीक है। कैलकुलेशन की ट्रिक समझनी है कि किस तरीके से, बिकॉज जो इसरो का एग्जाम बना रहा है ना, उनको भी बताया कि कैलकुलेटर हमने अलाउ नहीं कर रखा, तो क्यों वो आपको कैलकुलेशन में घुमाएंगे? कैलकुलेटर आप किसी भी कंपनी में जा रहे हो, पीएसयूज में जा रहे हो, इसरो में जा रहे हो, बैठकर आपको कैलकुलेटर हाथ में मिल जाएगा, सॉल्व करते रहो। दे हैव टू सी कि आपका माइंड वहां पे क्लिक करता है या नहीं। सुप्रिया, क्वेश्चन ब्लर दिख रहा है। बेटा ब्लर कहां दिख रहा है? एक बार मैं भी चेक करूं अपने फोन में, एक बार चेक करता हूं क्वेश्चन। और बच्चों के भी ये डाउट आ रहा है क्या? और बच्चों के भी ये डाउट आ रहा है कि क्वेश्चन ब्लर दिख रहा है? सुप्रिया कह रही है। एक बार मैं भी अपने फोन में चेक करूंगा यार। क्वेश्चन ब्लर तो नहीं है। बाकी लोग बताओ, बाकी लोग बताओ। क्लियर ना? सुप्रिया एक बार आप अपना रेजोल्यूशन इंक्रीज करो फोन का, जिसमें देख रहे हो फोन या लैब भी। रेजोल्यूशन इंक्रीज करो, बिकॉज बाकी लोगों को तो साफ दिख रहा है ना, तो रेजोल्यूशन में कहीं दिक्कत होगी। या तो 180 पे जाओ या 720 पे जाओ, जिस पर भी आप देख रहे हो। बाकी सॉल्व करें, देखो जल्दी से सॉल्व करें क्वेश्चन, ज्यादा टाइम नहीं वेस्ट करेंगे हम अपना, बिकॉज हमें अभी और रिवीजन करनी है। तो देखो क्वेश्चन कैसे सॉल्व होगा, ये दिमाग लगाओ। डायग्राम दिखेगा कि सर यार यहाँ तो बहुत सारे लूप है, अब हम क्या करें? मेरा लूप है तो क्या हो गया? क्वेश्चन देखो ध्यान से, क्या हम यहाँ पे नोड को नेम दे सकते हैं? कैसे देंगे नोड का नेम? ध्यान से देखो, नोड्स को नेम कैसे देंगे? अगर मैंने यहाँ नोड ए बोल दी, अगर मैंने ये नोड ए बोल दी, तो क्योंकि यहाँ शॉर्ट सर्किट है, ये भी तो नोड ए होगी, ये भी तो शॉर्ट सर्किट है, ये भी नोड ए होगी, ये होगी नोड बी, ये नोड बी, ये नोड बी। तो क्वेश्चन तो इतना मुश्किल सा बड़ा सा बनाया हुआ है, लेकिन नोड कितनी है? सिर्फ दो। नोड कितनी है? सिर्फ दो। तो अगर दो ही नोड है तो सिंपल इस डायग्राम को फिर से ड्रॉ कर लो ना। दिक्कत कहां पे आ रही है? ये हो गया एक रेसिस्टेंस यहां पे लगा हुआ है, एक डिपेंडेंट सोर्स यहां पे लगा हुआ है ना, एक और रेसिस्टेंस यहां लगा हुआ है, ठीक है, एक और डिपेंडेंट सोर्स यहां पे लगा हुआ है, ठीक है, और एक रेसिस्टर और लगा हुआ है। बन गए मेरे पास यहाँ पे ब्रांचेस। ये कितना है? 25 ओम और V1, 25 ओम प्लस माइनस V1, ठीक है, 0.2 V1, 0.2 V1, ठीक है। उसके बाद 10 ओम 5 एम्पियर, 10 ओम 5 एम्पियर, और फाइनली 100 ओम। हो गया। क्वेश्चन में कुछ है नहीं, निकालना क्या इसके अंदर? वोल्टेज V1, वोल्टेज V1। तो ओके, V1 निकालना ना। इस पर्टिकुलर नोड को ग्राउंड ले लो। अगर ये पर्टिकुलर नोड आपकी ग्राउंड हो गई तो यहां पर वोल्टेज कितना आ गया? V1, ठीक है। अब सिंपल क्या है? केसीएल लगा लो। सिंपल क्या है? केसीएल लगा लो। सो अगर हम यहाँ पे केसीएल लगाएंगे तो किस तरीके से लिख सकते हैं? V1 बाय 25, V1 बाय 25 करंट लीविंग, यहां से भी 0.2 V1 आ गया, ठीक है, प्लस V1 बाय 10, यहां से भी करंट आपका लीव कर रहा है, और प्लस V1 बाय 100 इज इक्वल टू करंट एंटरिंग। करंट कितना एंटर कर रहा है? कितना? ये 5 एम्पियर। ये कितना है? 5 एम्पियर। सो इज इक्वल टू 5। इक्वेशन ऐसे बन के आ रही है, इक्वेशन ऐसे बन के आ रही है, यस और नो? तो यहां से V1 को सॉल्व कर लो, कितना आएगा? ये 1 बाय 25 कितना? 1 बाय 25 हो गया, 0.2 कितना हो गया? 1 बाय 5, ये कितना हो गया आपके पास? 100 था ना, 10 प्लस 1 11 बाय 100 हो गया, इज इक्वल टू 5, है ना। यहां पे एलसीएम कितना आ गया? 100 आ गया। 25 4 प्लस 20 प्लस 11 इज इक्वल टू 5, है ना। तो कितना हो गए? 25 36, नहीं 36 कहां हुआ? 24 25 35 हो गया। तो V1 इज इक्वल टू 5 मल्टीप्लाई बाय 100 डिवाइड बाय 35। कहीं कैलकुलेशन मिस्टेक करिए मैंने? इसे देखो मैं आंसर सॉल्व करते कितना आ रहा है? V1 इज इक्वल टू 100 बाय 7। तो 7 1 जा 7, क्या सही आ रहा है आंसर? देखो 7 1 जा 7, 14 7 जा 98 होता है ना, 0.2 7 2 जा 14, तो 14.2 वोल्ट। तो देख रहे हो, कैलकुलेशन ऐसी होनी चाहिए, कैलकुलेशन ऐसे होनी चाहिए, ऐसे इस तरीके से, इस तरीके से, है ना। अंकित बेटा आपका आंसर A100, कहीं ना कहीं मिस्टेक करी बच्चे, चेक करो। कैलकुलेशन फास्ट रखो, बट हाँ सही रखो। ये नहीं कि सर फास्ट कैलकुलेशन का मतलब कुछ भी आंसर ले आओ, नहीं, फास्ट रखो। कहीं लगता है कि आपको कैलकुलेशन में कहीं थोड़ा लंबा जा रहा है, स्लो हो जाओ। जैसे मुझे यहां पर लगा कि शायद मेरी कैलकुलेशन रॉन्ग हो रही है, एक बार मैंने जल्दी से चेक कर लिया, और ऑप्शन भी पता होने चाहिए आसपास ऑप्शंस क्या है। नेक्स्ट नेक्स्ट इजी क्वेश्चन है, इजी क्वेश्चन है, दिखने में थोड़ा लगेगा कि पता नहीं क्या क्या दिया हुआ है, क्वेश्चन इजी है। इन द सर्किट शोन बिलो, switch S1 is closed at t equal to 0 seconds and switch S2 is opened at t equal to 0 seconds. The current flowing through the inductor of 0.3 Henry at t equal to 8 milliseconds. टी इक्वल टू 8 मिली सेकेंड्स। ठीक है, सॉल्व करो जल्दी से, क्या आंसर होगा? सुप्रिया सेट 500/35। हाँ वही आंसर आ रहा था ना पीछे। शेयर करो सेशन को, जितना शेयर कर सकते हो बच्चा शेयर करो। यहाँ पर स्विच S1 इज क्लोज। देखो स्विच S1 t इक्वल टू 0 पे क्लोज हुआ है और वो ओपन हुआ है, तो इसका मतलब अगर मैं 0 से पहले की बात करूं तो S1 ओपन था, तो जब S1 ओपन था सप्लाई लगी नहीं हुई थी, तो इनिशियल कंडीशन तो 0 है ना, तो सिंपल एक पॉइंट हम बोल सकते हैं यहां पर, इनिशियल कंडीशन इज 0 बिकॉज t इक्वल टू 0 से पहले आपके पास सप्लाई इंडक्टर से कनेक्ट नहीं थी, तो सिंपल इनिशियल कंडीशन 0 हो गया। ठीक है, अब यहां पूछा है इन्होंने व्हाट विल बी द करंट फ्लोइंग थ्रू द इंडक्टर। सो क्या फॉर्मूला होता है, V/R 1 माइनस ई रेज टू पावर माइनस टी बाई टाउ। यही फॉर्मूला सीखा होगा आप लोगों ने कि इंडक्टर के थ्रू करंट कितना जाएगा, V/R ई रेज टू पावर माइनस टी बाई टाउ। अब सिंपल टाउ निकालो, L/R। ठीक है, अब देखो स्विच S2 को क्या बोला है, ओपन हो गया है। अगर ये ओपन हो गया है तो ये दोनों सीरीज में आ गए, ये दोनों सीरीज में आ गए, तो कितना हो जाएगा, ये 150 ओम हो गया और यहां पर हो गया 0.3 हेनरी। ठीक है, तो ये हो गया 1/500 सेकेंड्स। अगर मैं गलत नहीं तो इतना ही आएगा, 1/500 सेकेंड्स, है ना, 1/500 सेकेंड्स। ठीक है, उसके बाद उन्होंने बोला है अब आई निकाल लो, V/R, V कितना है 100, रेसिस्टेंस कितना है 1/50, रेसिस्टेंस कितना है 1/50, 1 माइनस ई रेज टू पावर माइनस 500t, माइनस 500t, मेरे हिसाब से इतना ही आ रहा है, माइनस 500t, है ना। अब उसके बाद टाइम की वैल्यू पुट करनी है कितनी, 8 मिली सेकेंड्स। ओके, सो 8 मिली सेकेंड्स, तो ये 0 से 0 कैंसिल हुआ, 5 से काटा 2/3, 8 मिली सेकेंड्स, तो 1 माइनस ई रेज टू पावर माइनस 500 मल्टीप्लाई बाय 8 इंटू 10 रेज टू पावर माइनस 3, सो कितना हो गया 2/3, 1 माइनस ई रेज टू पावर, तो 500, तो ये बचा आपके पास 0.5 था ना, ये 0.5 हो गया, 4 बचा ना, ई रेज टू पावर माइनस 4, अगर मैं गलत नहीं तो ई रेज टू पावर माइनस 4 बचाई, हाँ हाँ, ई रेज टू पावर माइनस 4। अब बताओ क्या आंसर होगा, अब बताओ क्या आंसर होगा, दिमाग लगाए इसके अंदर, बिना कैलकुलेटर के सॉल्व कैसे करेंगे, दिमाग लगाए, बिकॉज ई रेज टू पावर माइनस 4 मुझे भी नहीं पता कितना होगा। तो बेटा ध्यान से देखो, ध्यान से देखो, 2/3 कितना दे रहा है आपको, 0.67 कुछ देगा, 0.67 कुछ देगा। ई की पावर माइनस 4 काफी बड़ी वैल्यू होगी, ई रेज टू पावर माइनस 4 काफी बड़ी वैल्यू होगी, तो ऑब्वियस सी बात है जो आई होगा अप्रोक्सीमेटली 0.67 के आसपास ही आएगा, 0.67 के आसपास ही आएगा। तो ऑप्शन ए इज द राइट आंसर, ऑप्शन ए इज द राइट आंसर। देखो चेक करो एक बार, ई रेज टू पावर माइनस 4 की वैल्यू क्या है, मैं एक बार कैलकुलेटर में यूज करता हूं, ई रेज टू पावर माइनस 4, ठीक है, 0.018, काफी छोटी वैल्यू आ रही है, सॉरी बड़ी बोल रहे हैं, काफी छोटी वैल्यू आ रही है। ई रेज टू पावर 4 बड़ी वैल्यू होती है, माय फॉल्ट, ई रेज टू पावर 4 जो होती है ना वो बहुत बड़ी वैल्यू होती है, तो ई रेज टू पावर माइनस 4 जो होगी नेग्लिजिबल होगी। ठीक है, माय फॉल्ट, ई रेज टू पावर माइनस 4 बड़ी नेग्लिजिबल वैल्यू है, तो सिंपल 0.67। तो अगेन नेक्स्ट क्वेश्चन विदाउट कैलकुलेटर, बस दिमाग लगाना है कि किस तरीके से आपको कैलकुलेटर यूज नहीं करना। नेक्स्ट क्वेश्चन सिंपल है, ये तो बच्चे वाला क्वेश्चन है, सब लोग सॉल्व करो, बच्चे वाला क्वेश्चन है, सब लोग सॉल्व करो। द ट्रांसमिशन पैरामीटर ऑफ द नेटवर्क गिवन बिलो is represented in a matrix form like this. Calculate the transmission parameter of T matrix. Actually ये J2 है, ये J2 है ऑप्शन में, J2 है, 1 नहीं है, J2 है। ठीक है, आई होप गाइस यू आर लाइकिंग द क्वेश्चंस, आई होप यू आर लाइकिंग द क्वेश्चंस। तो नेटवर्क के कुछ क्वेश्चन सॉल्व करेंगे हम अप्रोक्सीमेटली 10 क्वेश्चन के आसपास, उसके बाद 6 क्वेश्चन हमारे पास मेजरमेंट्स के है। आई नो मेजरमेंट्स आप लोग बोलोगे सर इलेक्ट्रॉनिक्स का पार्ट नहीं है, बट बच्चों कुछ बेसिक्स आपको पता होने चाहिए। ठीक है, ये चीज है, अगर आप क्वेश्चन छोड़ते भी हो मेजरमेंट्स के तो याद रखना कंपटीशन बहुत ज्यादा है, तो ऐसा नहीं है कि आप सारे क्वेश्चन छोड़ दो, ऐसा नहीं है कि आप सारे क्वेश्चन छोड़ दो। आकांक्षा ने बोला ऑप्शन बी, सुप्रिया ने बोला ऑप्शन सी, बेटा ऑप्शन बी आंसर है इसका। कैसे होगा देखो, बी क्या होता है बताओ मुझे, चलो एबीसीडी पैरामीटर लिख ले, एबीसीडी पैरामीटर कैसे लिखते हैं, V1 इज इक्वल टू A टाइम्स ऑफ V2 माइनस B टाइम्स ऑफ I2, इस तरीके से। तो B कितना हो गया, V1 माइनस I2 व्हेन V2 इज इक्वल टू 0। याद रखना है माइनस साइन, ये इंपॉर्टेंट है, याद रखना है माइनस साइन, ये काफी इंपॉर्टेंट है। सो V1 by I2 when V2 is 0, V2 0 का मतलब क्या हो गया, दैट इज शॉर्ट सर्किट, वो आपका शॉर्ट सर्किट हो गया। V2 0 का मतलब क्या हो गया, इस तरीके से शॉर्ट सर्किट। ये क्या है, V1 यहां से जा रहा है I1, इट इज माइनस J2, यहां से जा रहा है I2, है ना। और जो 4 ओम है वो शॉर्ट सर्किट हो गया, दिखाने की कोई जरूरत नहीं है। तो यहां से देखो V1 और I2 का रेशियो निकालना है, V1 और I2 का रेशियो निकालना है, सिंपल है। यहां से V1 इज इक्वल टू माइनस J2 माइनस I2, I2 का डायरेक्शन अपोजिट है बेटा, I2 का डायरेक्शन अपोजिट है, माइनस J2, तो यही तो B है आपके पास, है ना। सिंपल क्वेश्चन, ये भी प्रीवियस ईयर है, ये भी प्रीवियस ईयर है, ऑप्शन बी इज द राइट आंसर। ठीक है, तो ऐसा नहीं है कि सारे क्वेश्चंस यहाँ पे कैलकुलेशन काफी ज्यादा आनी है, नहीं, कुछ क्वेश्चंस में आपके पास कैलकुलेशन सिंपल भी आती है। बैलेंस पेपर बनाते हैं, ठीक है, जो बड़ी कंपनी से आपकी इसरो हो गया, या फिर आपके गेट का एग्जाम है, या फिर ईएससी का एग्जाम है, पेपर हमेशा बैलेंस बनता है। ये मत सोचना कि 80 क्वेश्चन है तो 80 के कैलकुलेशन काफी ज्यादा आ जाएगी, ऐसा नहीं होता। नाउ सॉल्व करो। द टोटल नंबर ऑफ पॉसिबल ट्रीज कॉरेस्पॉन्डिंग टू द नेटवर्क शोन बिलो। अब देखो, ये इस टाइप का जो क्वेश्चन है, अगर आप गेट के लिए प्रिपेयर कर रहे हो, जो कि आप कर ही रहे होंगे, तो आप जनरली ये चैप्टर आप छोड़ देते हो, बिकॉज गेट में यहां से क्वेश्चन आते भी नहीं है। ईएससी में क्वेश्चंस आते हैं, तो यस आप ईएससी का पेपर प्रिपेयर कर रहे हो, ईएससी से क्वेश्चंस आते होंगे, ठीक है। तो इसलिए इस टाइप के क्वेश्चंस ना आपके इसरो एग्जाम के लिए इंपॉर्टेंट हो जाते हैं, जो बच्चे जनरली ना स्किप कर देते हैं टॉपिक्स। तो इस ट्री बनाने के लिए सबसे पहले आपको नंबर ऑफ पॉसिबल ट्रीज बोले ना, तो सबसे पहले हमें इसका ग्राफ बनाना पड़ेगा। तो याद रखो, ग्राफ के लिए हम कभी भी आई को इंक्लूड नहीं करते, जो आपका करंट सोर्स होता है वो जिस ब्रांच में होता है उसको इंक्लूड नहीं करते। तो अगर मैं यहां से बनाऊं ग्राफ, तो कुछ इस तरीके से बनेगा। ये ले लो नोड ए, नोड बी, ठीक है, ये होगी न्यूट्रल नोड, या नोड सी ले लो, लेना है तो, ठीक है। तो ये होगी नोड ए, ये होगी नोड सी, ये होगी नोड बी, ठीक है। तो एक ये हो गया फर्स्ट ब्रांच, सेकंड, थर्ड, फोर्थ, फिफ्थ, 5 ब्रांच है ना। बताओ नंबर ऑफ ब्रांचेस कितनी है, 5 ही है। नंबर ऑफ ब्रांचेस कितनी है, 5 है, इस तरीके से। और ये एक ब्रांच होगी, और यहां पर एक ब्रांच होगी, ठीक है। अब यहां पे करंट एज्यूम कर लो, ये ले लो I1 हो गया, यहां पे हो गया I1, ये हो गया I3, ये हो गया I4, है ना, ये हो गया I2, ये हो गया I5। इस तरीके से एज्यूम कर लिया, ठीक है। सॉल्व करो, ऑप्शन डी आंसर आ गया, ऑप्शन डी आंसर आ गया। कौन सा फॉर्मूला यूज करा, मुझे बताओ कौन सा फॉर्मूला यूज करा है मुरली। और ये पर्टिकुलर स्टिकर तो अच्छा है यार, स्टिकर तो अच्छा है। तो यहां से हम बना ले ए, मेरे पास नंबर ऑफ नोड्स कितनी है, ए बी सी, और नंबर ऑफ ब्रांचेस कितनी है, 1 2 3 4 5। मैट्रिक्स बनाना आती है आपको, यस और नो, मैट्रिक्स बनाना आती है इस तरीके से। तो यहां पर देखो, अगर करंट एंटर कर रहा है तो -1, अगर लीव कर रहा है तो +1। सो नोड ए पे I1 I3 I1 एंटर कर रहा है तो -1, I3 I4 लीव कर रहे हैं, सो +1, और जहां पे कोई ब्रांच नहीं है 0 0, ठीक है। अब बी पर देखो, I3 I4 एंटर कर रहा है और I5 भी एंटर कर रहे हैं, तो I3 I4 I5 एंटर कर रहा है, जबकि I2 लीव कर रहा है, तो I2 लीव कर रहा है, +1 0। सी पर देखो, I1 लीव कर रहा है, I2 एंटर कर रहा है, और I5 आपका लीव कर रहा है। इस तरीके से होगा, कोई डाउट इसमें। अब यहां से आपको एक पर्टिकुलर नोड को स्किप करना पड़ेगा, इसको हम बोल देते हैं AF, कट सेट मैट्रिक्स, इसको AF बोल देते हैं। -1 0 +1 +1 0। किसी भी नोड को स्किप कर सकते हो या डिलीट कर सकते हो। मैंने लास्ट वाली को डिलीट कर दिया है, लास्ट वाली को डिलीट कर दिया, इस तरीके से होगा। अब नंबर ऑफ ट्रीज निकालने हैं, नंबर ऑफ पॉसिबल ट्रीज। क्या होता है फॉर्मूला, नंबर ऑफ ट्रीज इज डिटरमिनेंट ऑफ AF एंड AF ट्रांसपोज, डिटरमिनेंट ऑफ AF एंड AF ट्रांसपोज। रुको AC बंद कर दो, डिटरमिनेंट ऑफ AF एंड AF ट्रांसपोज, ठीक है। तो सबसे पहले AF इंटू AF ट्रांसपोज निकालो, तो कितना है ये, -1 0 +1। अच्छा ये बताओ, स्पीड से कोई प्रॉब्लम तो नहीं है, स्पीड से कोई प्रॉब्लम तो नहीं है। देखो स्पीड में इसलिए दिखा रहा हूं आप लोगों को कि आपको किस तरीके से क्वेश्चन सॉल्व करने हैं एग्जाम में, आपको पता होना चाहिए, बिकॉज स्पीड मैटर्स, योर एफिशिएंसी एंड स्पीड बोथ आर मैटर्स। तो यहाँ पे -1 0 +1 +1 0 0 +1 -1 -1 -1 इस तरीके से होगा। अरे रिप्लाई तो करो बच्चों, रिप्लाई नहीं करोगे तो कैसा चलेगा। तो यहां पर आ गया 3। देखो जहां पे स्पीड स्लो करनी हो वहां पे स्पीड स्लो कर सकते हो। -2 ये 0 गया, ये 0 गया, +1 -1 -2 यहां पर क्या बचा 1 1 2 या 4 बचेगा, सॉरी 4 आएगा ना यहाँ पे 4 आएगा, है ना 4 ही आएगा ना 1 1 1 1। हाँ अब इसको सॉल्व कर लो, इसका डेटर्मिनेंट निकालना है। 3 4 जा 12 -2 2 जा 4 8। कौन बोल रहा था 7? कौन बोल रहा था 7 है? बिना सॉल्व करे 7। कौन कौन थे 7 वाले? ये सुप्रिया था, सुप्रिया बोल रही थी, मुरली बोल रहा था, मुरली ने सी का भी बोल दिया कि लो सर, ये लो सर डी फुल कॉन्फिडेंस। बेटा आई नो क्वेश्चन आता है, कोई दिक्कत नहीं है, क्वेश्चन आता है आप लोगों को, बिकॉज आप लोग गेट की पढ़ाई कर रहे हो, क्वेश्चन आता है आप लोगों को, लेकिन हमेशा ओवर कॉन्फिडेंस में नहीं जाना। जल्दी से सॉल्व करके देख लो कि आपका आंसर सही है या नहीं, ठीक है। अगर प्रीवियस ईयर किया भी है, फॉर एग्जाम्पल आई एम प्रिटी मच श्योर कुछ बच्चों ने प्रीवियस ईयर किए होंगे इस टाइप का क्वेश्चन, या सेम क्वेश्चन भी किया होगा। ऐसा नहीं है कि मेरे भगवान नहीं हो कि मैंने नया क्वेश्चन बना दिया है, आपने करा होगा, बट फिर भी जब भी मॉक टेस्ट कर रहे हो, प्रैक्टिस टेस्ट कर रहे हो, जल्दी से एक बार सॉल्व करके देख लो, ठीक है। तो 7 इज अ रॉन्ग आंसर, ठीक है ना, मैंने तो सही करा ना, हाँ ठीक है। नेक्स्ट क्वेश्चन, कंसिडर द सर्किट शोन बिलो, द पावर फैक्टर ऑफ द अबव सर्किट, यहां पर बिलो है, इज सीन बाय द सोर्सेस। पावर फैक्टर निकालना है, पावर फैक्टर। ये क्वेश्चन प्रैक्टिस नहीं है अंकित, क्या बोल रहे हो, मतलब पूछ रहे हो बता रहे हो, क्वेश्चन प्रैक्टिस नहीं है। इसी के तो बात कर रहे हो बेटा, अभी तो कोई एक भी क्वेश्चन मैंने तो नहीं कराया जो आपका कोर्स से बाहर का हो, बाकी आप लोग बताओ मुझे। बाकी कुछ बच्चे अगर कमेंट डिलीट करे तो बेटा कमेंट डिलीट मत करो, कोई दिक्कत नहीं है। अगर रॉन्ग आंसर दे भी रहे हो, क्या हो गया उसके अंदर। आकांक्षा, इससे ही भगाना है सर एग्जाम तो, हाँ ऐसे करना है। सुप्रिया सर लीडिंग, तो देखो एक बार पहचान लोगे तो यहां देखो आपके पास कैपेसिटर लगा, तो सुप्रिया ने कैपेसिटर देखते ही पहचान लिया कि लीड होगा, तो ऑब्वियसली बात है ऑप्शन ए ऑप्शन सी रॉन्ग हो गया, ऑप्शन ए ऑप्शन सी रॉन्ग हो गया। अब एक और दिमाग की बात करूं, एक और दिमाग की बात करूं, दोनों में काफी डिफरेंस है, दोनों में काफी डिफरेंस है ना। एक बार इसको सॉल्व करो फिर आपको बताता हूं किस तरीके से आप इजिली 10 से 20 सेकंड में ये वाला क्वेश्चन सॉल्व कर सकते थे। बट पहले चलो इसको सॉल्व कर लो अच्छे से। आपको पावर फैक्टर निकालना है ना, पावर फैक्टर निकालने के लिए आपको टोटल इसका इंपीडेंस निकालना पड़ेगा, टोटल इंपीडेंस निकालना पड़ेगा। सो टोटल इंपीडेंस यहां से देखोगे कैसे आएगा, टोटल इंपीडेंस 6 प्लस -j पैरेलल टू 4, 6 प्लस -j4 डिवाइड बाय 4 j नहीं 4 j होगा, 4 j चेक कर लो एक बार, 4 j। हाँ क्या कर सकते हो यहां पर, अगर चाहो तो रेशनलाइजेशन परफॉर्म कर लो, तो एक हो जाएगा 4 j, यहां पर प्लस कर लो 4 + j। देखो मैंने यहां पर रेशनलाइजेशन दिखा दिया है, एग्जाम में क्या है आप ये वाला स्टेप स्किप करके ना नेक्स्ट इस स्टेप पे आ सकते हो। ये मत करना एग्जाम में हर एक स्टेप कर रहे हो आराम आराम से, उसके मार्क्स नहीं है। 4 4 16 -j 16, ये कितना हो गया -j² + 4, 4 -j 16 डिवाइड बाय a² + b² 1। ये जस्ट मैंने आपको दिखा दिया, एग्जाम में हर एक स्टेप को सॉल्व नहीं करना आपको। 4 -j 16 डिवाइड बाय 17। अब इसको सॉल्व करना है, इसका आपको निकालना है, कैसे निकालोगे बताओ। ठीक है ऑब्वियसली अब आप बोलोगे सर कैलकुलेटर चाहिए होगा भाई, आपको इसका tan इनवर्स निकालना है। इसको थोड़ा और सिंप्लीफाई कर लो, इसको थोड़ा और सिंप्लीफाई कर लो इस तरीके से, -j 16 बाय 17। तो ऑब्वियसली बात है इसका tan इनवर्स निकालना है ना। मैं भी नहीं निकाल पाऊंगा विदाउट कैलकुलेटर, बट अभी मेरे पास कैलकुलेटर है तो मैं सॉल्व कर सकता हूं। क्या होगा तो मुझे बताओ इसरो में कैसे करोगे इसको, मुझे बताओ इसरो में कैसे करोगे इसको। एक सेकेंड, बताओ मुझे इसरो में कैसे करोगे। सर शॉर्टकट है, देखो करेक्ट सही बात है, तो आंसर कितना आएगा 0.98। देखो कैसे हो गया, सिंपल सी बात बताता हूँ, ज्यादा कुछ सोचने वाली बात नहीं है कि सर ये कैसा शॉर्टकट है। फर्स्ट ऑफ ऑल देख कर पता चला लीडिंग है, देख कर पता चल रहा है। जो दो की लीडिंग ऑप्शन बचे ना, उसमें बहुत ज्यादा गैप है, बहुत ज्यादा गैप है। जबकि आप यहां पर देखोगे जो आपका कैपेसिटेंस है 1 ओम और ये 4 ओम, इसमें ज्यादा गैप नहीं है, ठीक है। तो ये आपका बहुत ही नियर होगा यूनिटी के, ठीक है। और अगर आप ये भी नहीं पता ना कितना नियर होगा, आप कह दो यूनिटी के पास होगा। अब दो ऑप्शन है 0.9 0.23, सबसे पास कौन सा है? ऑप्शन बी तो है, तो आंख बंद करके ऑप्शन बी लगाओ। हाँ, लेकिन अगर यहाँ पे एक और ऑप्शन होता है 0.89 लीड, तब उस टाइम बेटा आपको पूरा सॉल्व करना पड़ता, बट यहाँ तो है ही नहीं ना, यहाँ तो है ही नहीं। अगर वहां पे 0.89 होता तब आपको पूरा सॉल्व करना पड़ता, ठीक है। पहला ऑप्शन तो ये हो गया। दूसरा, अगर आपको यहां से नहीं समझ में आ रहा तो आप इतना सॉल्व कर लो। इतना सॉल्व करने के बाद आप देखोगे कि ये जो रियल पार्ट है ये आपका अप्रोक्सीमेटली 6 है, ये जो पार्ट है ये आपका अप्रोक्सीमेटली 1 है। तो दोनों में काफी ज्यादा गैप है, इमेजिनरी और रियल पार्ट में ज्यादा गैप है। इसका मतलब जो आपका पावर फैक्टर होगा वो यूनिटी के पास होगा। क्यों? बिकॉज जो कॉस 0 होता है वो 1 के आसपास होता है, समझे? हाँ, सुप्रिया ने सही कहा, एब्सोल्युटली करेक्ट। तो इस तरीके से देखो बेटा, आपको दोनों साइड दिमाग चलाना है, कैलकुलेटर नहीं है इसलिए दोनों साइड आपको दिमाग चलाना है। नेक्स्ट सिंपल क्वेश्चन, जस्ट एक टेक्निक पता होनी चाहिए। हाँ, जैसे सुप्रिया ने कहा, दूसरा पॉइंट भी अच्छा है कि अगर रियल पार्ट इमेजिनरी पार्ट के इक्वल है तो 45 डिग्री आपका एंगल हो जाता है, ठीक है। तो ये चीज है, जब आप ज्यादा क्वेश्चंस प्रैक्टिस करोगे ना तभी आपको अपने आप ट्रिक्स पता चल जाएगी। ऐसा नहीं है कि हर कोई आपको सारी ट्रिक्स बता देगा। जब आप क्वेश्चंस प्रैक्टिस करोगे उसी लेवल के, ठीक है, लेवल याद रखो। ये नहीं कि आप गेट के क्वेश्चन में शॉर्टकट ट्रिक्स लगा रहे हो, वहां नहीं लगेगा, वहां कैलकुलेटर है, आराम से कैलकुलेटर का यूज करो। बट इसरो का एग्जाम हो गया, ईएससी का प्री एग्जाम हो गया आपका, या डीएमआरसी का, एलएमआरसी के, इनके प्रीवियस ईयर पेपर उठाओ देखो, और वहां पे आप ट्रिक्स लगाओ कैलकुलेशन की, बिकॉज वहां पर कैलकुलेटर अलाउड नहीं है, समझे? ये नहीं कि इसरो का एग्जाम है और गेट के प्रीवियस ईयर क्वेश्चन सॉल्व कर रहे हो, क्या फायदा है बताओ? क्वेश्चन सॉल्व करो इसको। All the three inductors are perfectly coupled as shown below. The value of total inductance across the terminal AB is, क्या होगा? सिंपल, अब तक आंसर आ जाना चाहिए था, अब तक आंसर आ जाना चाहिए था, सिंपल है। कॉन्सेप्ट पता है इसका? कॉन्सेप्ट पता है? नहीं पता जल्दी से बता देता हूं। कॉन्सेप्ट नहीं पता तो जल्दी से बता देता हूं। कॉन्सेप्ट मैग्नेटाइजिंग कॉन्सेप्ट है इसके अंदर। अगर म्यूचुअल इंडक्टेंस आपका एम होता है और दोनों डॉट्स में करंट अगर एंटर कर रही है, देखो I1 यहां से एंटर कर रही है तो वही I1 आपकी डॉट में एंटर कर रही है, तो अगर करंट आपके दोनों डॉट्स में एंटर कर रहे हैं देन टोटल इंडक्टेंस इज L1 प्लस L2 प्लस 2 टाइम्स ऑफ M। अगर करंट दोनों से लीव कर रही है, अगर करंट दोनों डॉट से लीव कर रही है इस तरीके से, देन टोटल इंडक्टेंस इज अगेन L1 प्लस L2 प्लस 2 टाइम्स ऑफ M। लेकिन अगर करंट एक डॉट पे एंटर और दूसरी से लीव कर रही है, फॉर एग्जांपल दिस थिंग, अगर मैंने यहां पे करंट भेजा तो यहां पर ये एक डॉट से एंटर कर रहा है लेकिन यहां पे उसी डॉट से लीव कर रहा है, सेम करंट आपका डॉट से लीव कर रहा है, तो उस केस में क्या होगा? यहां पे टोटल इंडक्टेंस इज L1 प्लस L2 माइनस 2M। इसको बोलते हैं सब्ट्रैक्टिव पोलैरिटी, इसको बोलते हैं सब्ट्रैक्टिव पोलैरिटी। याद रखना, पैरेलल के लिए भी यूज होता है, पैरेलल का क्वेश्चन आ सकता है, इंपॉर्टेंट है, दूसरे एग्जाम्स में इसी साल आया है। आपके AEJ के जो एग्जाम्स हुए वहां पर एक क्वेश्चन मैंने देखा था, पैरेलल का भी क्वेश्चन पूछ लिया गया था, दैट वाज आल्सो इंपॉर्टेंट। सॉल्व करें इसको फिर। तो इसको मैं L1 ले रहा हूं, इसको L2 ले लिया, इसको L3 ले लिया, इसको ले लेता हूं मैं M13, इसको ले लिया M12, इसको ले लिया M23, ठीक है। डायरेक्ट फॉर्मूला लिख रहा हूं, बताना कोई दिक्कत हो तो। सबसे पहले तीनों इंडक्टेंस का सम। अब देखो M12 में करंट एंटर कर रहा है डॉट पे और लीव करेगा, तो माइनस 2 टाइम्स ऑफ M12। M13 देखो दोनों पे करंट एंटर करेगा डॉट पे, M13 देखो ध्यान से, तो प्लस 2 टाइम्स ऑफ M13। M23 देखो यहां से लीव कर रहा है, यहां पे एंटर कर रहा है, तो माइनस 2 टाइम्स ऑफ M23, है ना। फॉर्मूले में कोई डाउट है कि फॉर्मूला कैसे आया? अब बस इसमें वैल्यू पुट करो, सॉल्व कर दो। आई गेस सुप्रिया ने सही करा है, वहां पे आपकी नोमेनक्लेचर अलग होगा, बट हम सॉल्व करते हैं। तो L1 कितना है? 6, 8, 10 माइनस 2 टाइम्स मल्टीप्लाई बाय 5, प्लस 2 टाइम्स M13 है ना, मल्टीप्लाई बाय 2 माइनस 2 टाइम्स मल्टीप्लाई बाय 4, ठीक है। तो कितना हो गया ये 2 5 या 10 10 कैंसिल हो गया आपका, है ना। देन इट इज 2 2 4 6 प्लस 4 10, ऑप्शन डी, ऑप्शन डी करेक्ट है ना। एब्सोल्युटली सुप्रिया, वेल डन अंकित, वेल डन बच्चा। लेकिन बाकी लोगों को क्या हो गया, देखो अभी काफी बच्चे लाइव देख रहे हैं, बस अंकित तो सुप्रिया ही है जो कमेंट सेक्शन में पार्टिसिपेट कर रहे हैं। बाकी लोग सिंपल क्वेश्चन तो है, दिक्कत क्या है इसके अंदर बताओ मुझे। अब ये बोलना सर ये क्वेश्चन भी हम एक्सपेक्ट नहीं कर सकते, तो बेटा एक्सपेक्ट क्या करोगे। नेक्स्ट, कंसीडर द रेसिस्टिव नेटवर्क शोन बिलो द वैल्यू ऑफ नॉर्टन करंट अक्रॉस द टर्मिनल ए बी। द वैल्यू ऑफ नॉर्टन करंट अक्रॉस द टर्मिनल ए बी। ओके, ए बी के अक्रॉस निकालना है सर, शायद नेटवर्क इश्यू इसलिए वैल्यू ब्लर दिख रही है। बेटा आई गेस आपकी साइड, बिकॉज मैंने भी अपना लैपटॉप खोला तो हुआ है, मैं चेक कर रहा हूँ। हाँ यार आपकी साइड से ही है यार, एक बार देखो, बाकी किसी को भी नेटवर्क इश्यू है तो बता दो मुझे, तो यहां से ना एक्चुअली साफ दिख रहा है। सॉल्व करो। कंसीडर द रेसिस्टिव नेटवर्क शोन बिलो द वैल्यू ऑफ नॉर्टन करंट्स अक्रॉस द टर्मिनल ए बी। नॉर्टन करंट क्या होता है, जिस भी टर्मिनल के अक्रॉस नॉर्टन करंट फाइंड करना है वहां पे क्या कर दो, शॉर्ट सर्किट, वहां पे क्या कर दो, शॉर्ट सर्किट। सिंपल सा कॉन्सेप्ट। तो यहां पे अगर मैंने ए बी को शॉर्ट सर्किट कर दिया, ए बी को शॉर्ट कर दिया, 12 ओम तो वैसे रिमूव हो गया, 12 ओम वैसे रिमूव हो गया। अब यहां पर मैं नेटवर्क बनाता हूं। अब याद रखना आप लोग मत बनाना, जब आप इसरो में एग्जाम में सॉल्व कर रहे होंगे डायरेक्ट आप ये वाला नेटवर्क बनाओगे, ये नहीं पहले वाला नेटवर्क बना रहे हो, देख के दिख रहा है ना कि वो शॉर्ट हो जाएगा, तो उसको फालतू में यहां पे बनाकर फिर से शॉर्ट करने की जरूरत क्या है। ये हो गया 2 एम्पियर, ये हो गया सॉरी 2 ओम होगा, 2 ओम होगा सॉरी, ये हो गया 2 ओम, ये हो गया 6 एम्पियर, 6 एम्पियर, 6 ओम, 3 ओम, और ये हो गया नॉर्टन्स करंट, और यहां पे कितना है 120 वोल्ट। सॉल्व करो इसको, सॉल्व करो इसको, कितना होगा आंसर, कितना आएगा, आईएन कितना आ रहा है, कैसे सॉल्व करोगे। सिंपल लगा दो केसीएल वेसीएल जो लगाना है आपको, केसीएल लगा सकते हो ना। यहाँ पे कैसे लगाओगे, ये एक वोल्टेज आपके पास V, ये आपका एक वोल्टेज है V, सपोज कर लो यहां से I1 आ रहा है, सपोज कर लो यहां से I2 जा रहा है, ठीक है, बाकी लोग है तो सिंपल केसीएल लगा लो। केसीएल क्या होगा, I1 I2 एंटर कर रहे हैं, देखो I1 I2 और 6 एम्पियर ये आपके एंटर कर रहे हैं, लीव क्या करेगा, लीव आपको करेगा 2 ओम का, V/2 आपका लीव कर रहा है, ऐसे होगा ना, I1 I2 और 6 एंटर कर रहे हैं, V/2 आपका लीव कर रहा है, तो I1 कितना हो गया 120 माइनस V डिवाइड बाई 6, I2 कितना हो गया 0 माइनस V डिवाइड बाई 3 प्लस 6 इक्वल टू V/2। पूरी इक्वेशन को 6 से मल्टीप्लाई कर दो, खत्म। तो कितना हो गया 3 2 5 1 6, 6V इज इक्वल टू 120 प्लस 36, तो V कितना आ गया 26, 20 6, हाँ V कितना आ गया 26, V 26 आ गया। आईएन निकाल सकते हैं हम, आईएन कैसे निकालोगे, सिंपल सी बात है, I1 I2 निकाल लो, या जो आईएन है वो आपका 6 कैसे भी निकाल लो। फॉर एग्जांपल यहां पर मैं I4 बोल देता हूँ, I4 कितना होगा, I4 इज V/2 कितना हो गया 26/2 कितना हो गया 13, है ना। आईएन किसके इक्वल है, आईएन प्लस 6 इज इक्वल टू I4, आईएन प्लस 6 इक्वल टू 13, आ गया आंसर। किसी एक बच्चे ने 7 आंसर दिया, एब्सोल्युटली करेक्ट, ठीक है, स्पीड मैटर्स, ऑप्शन सी। अंकित एब्सोल्युटली करेक्ट आंसर। देखो मुझे बताइए क्वेश्चन वैसा क्वेश्चन है सब लोग सॉल्व कर लोगे, द मेन पॉइंट टाइम कंस्ट्रेंट, द मेन पॉइंट टाइम कंस्ट्रेंट, अदरवाइज नॉर्टन्स अगर आपको निकालना नहीं आता तो बेटा किसी भी एग्जाम की आप क्या प्रिपरेशन करोगे, है ना। नॉर्टन्स तो आप निकाल सकते हो, नॉर्टन्स करंट में क्या है, शॉर्ट कर दो, ऐसा तो डिपेंडेंट सोर्स भी नहीं दे रखा है, बच्चों वाला क्वेश्चन है ये, 12th क्लास वाला। नाउ बिफोर गोइंग फर्दर लेट मी टेल यू दैट हमारी ऐप पे अगर आप लोगों ने ऐप इंस्टॉल नहीं करी तो इंस्टॉल कर लेना। यहाँ पे डेली आपकी एक फ्री क्लासेस होती है, मेरी भी नेक्स्ट वीक से फ्री क्लासेस स्टार्ट होने वाली है, तो यहाँ पे क्वेश्चन प्रैक्टिस हम करेंगे अच्छे से, बिकॉज एग्जाम पास में है, और आपके पास लीडर बोर्ड होगा जिससे कि आप अपना स्कोर अपने फेलो एस्पिरेंट्स के साथ कंपेयर कर सकते हो, तो थोड़ा कॉम्पिटिटिव एनवायरमेंट बना के रखेंगे। तो अगर आप लोगों ने ऐप इंस्टॉल नहीं करी है तो इंस्टॉल कर लेना। नेक्स्ट, टेस्ट सीरीज, हाँ बेटा टेस्ट सीरीज का भी ऑप्शन है, टेस्ट सीरीज का भी ऑप्शन है। प्लस बेटा बच्चों आप लोगों के लिए गेट के लिए भी हम एक अच्छी चीज प्लान कर रहे हैं, तो वो कुछ ही दिनों में आपको भी पता चल जाएगी, है ना। तो गेट की भी अच्छे से प्रिपरेशन आप करना हमारे साथ, जिसमें हम लोग काफी अच्छे अच्छे क्वेश्चन प्रैक्टिस करेंगे। प्रीवियस ईयर क्वेश्चंस हम आप लोग कर चुके हो, नहीं करा हो तो कर लेना। हम लोग न्यू क्वेश्चंस प्रैक्टिस करेंगे, नए क्वेश्चंस लेकर आएंगे जिससे कि दिमाग चले। प्रीवियस ईयर में क्या होता है, आपने देखा क्वेश्चन, आपको पता है चलो इसके अंदर ये यूज होगा, बट जब नया क्वेश्चन आएगा तब आप प्रीवियस ईयर की नॉलेज कैसे यूज करोगे वो हम देखेंगे। तो जल्दी हमारी एक पर्टिकुलर सीरीज भी स्टार्ट हो रही है गेट के लिए, तो याद रखना उस सीरीज में ईसी और इलेक्ट्रिकल दोनों के लिए स्टार्ट होगी। तो अभी तो ईसी के स्टूडेंट्स हैं, बाकी इलेक्ट्रिकल के भी आ जाएंगे। सो द वोल्टेज अक्रॉस द रेसिस्टर आर इज, आर के अक्रॉस वोल्टेज क्या होगा, सिंपल है, केसीएल लगाओ या करंट डिवीजन रूल क्यों नहीं लगा रहे हो, करंट डिवीजन रूल क्यों नहीं लगा रहे हो। यहां पर आप निकाल सकते हो I1 कितना होगा, I1 निकाल लेते, I1 इज इक्वल टू 1 मल्टीप्लाई बाय 1 प्लस J1 डिवाइड बाय कितना आ गया, I1 यहां से आ गया 1 प्लस J1 डिवाइड बाय 2। वोल्टेज कितना आ जाएगा, I1 मल्टीप्लाई बाय आर, आर तो 1 ही है, कितना हो गया 1 प्लस J1 डिवाइड बाय 2, ये आ गया वोल्टेज। जब वोल्टेज ही मेरे पास ये आ गया है 1/2 प्लस J1/2, तो अभी बोला था सुप्रिया ने कि जब दोनों सेम होते हैं तो एंगल क्या होता है 45, है ना। तो ये हो जाएगा 1/2 मल्टीप्लाई बाय √2 एंगल 45 डिग्री, कितना हो गया ये 1/√2 एंगल 45, है ना। ऑप्शन डी, ऑप्शन डी, है ना। केसीएल भी लगा सकते हो, दिक्कत नहीं है, बट केसीएल में आपको टाइम लग जाएगा, केसीएल में टाइम लगेगा। केसीएल कैसे लगाओगे, आप पहले यहाँ पर वोल्टेज निकालोगे, फिर कैसे आप करंट वोल्टेज डिवीजन रूल लगाओगे, कोई उस बात का तुक नहीं है ना। ऑप्शन डी इज द राइट आंसर, है ना। देखो इसको तो आप बिना कैलकुलेटर के कन्वर्ट कर सकते हो ना, कोई दिक्कत वाली बात नहीं होनी चाहिए, इतना तो कैलकुलेशन करो। इसको अगर कैलकुलेटर में लगाने लग गए तो आपका टाइम वेस्ट है, टाइम वेस्ट है। इवन गेट एग्जाम में भी टाइम वेस्ट है आपका, है ना। नेक्स्ट अच्छा क्वेश्चन है, a step voltage of 1 volt applied to the circuit at t equal to 0, the current through the resistor R just after t equal to 0 and at steady state R. Okay, क्या पूछा है, R के थ्रू करंट पूछा है 0 पे और स्टेडी स्टेट पे, ठीक है। हाँ करंट डिवीजन सिंपल, एब्सोल्युटली करेक्ट। जहां पैरेलल ब्रांच दिखे और करंट सोर्स दिखे, आंख बंद करके करंट डिवीजन रूल लगाओ, चाहे वो आपका व्हीटस्टोन ब्रिज है, चाहे जो पिछले वाला क्वेश्चन था वो था, ठीक है। सॉल्व करो, सॉल्व करो, बाकी लोग भी रिप्लाई करो, बाकी लोग भी ऑनलाइन है, तो जो बच्चे ऑनलाइन है बेटा रिप्लाई करो, जिससे कि मुझे भी पता चले कि आप लोग सेशन ध्यान से देख रहे हो। एट 0 इंडक्टर शॉर्ट सर्किट सिंपली V/R, बेटा इंडक्टर तो है नहीं सुप्रिया, इंडक्टर तो है नहीं, आई गेस आप बोलना चाह रहे हो कैपेसिटर, है ना। आप कैपेसिटर बोलना चाह रहे हो, जो कि एब्सोल्युटली करेक्ट है अगर आप कैपेसिटर बोल रहे हो तो, ठीक है। देखो t इक्वल टू 0 पे पूछा है, पहले देखो 0 माइनस पर क्या आपका कैपेसिटर चार्ज हो रहा है। 0 माइनस की बात करोगे तो आपका वोल्टेज कितना है, 0 वोल्ट है, 0 माइनस पे वोल्टेज 0 वोल्ट है ना। तो कैपेसिटर आपका चार्ज ही नहीं हो रहा, कैपेसिटर चार्ज ही नहीं हो रहा, तो सबसे पहली बात मैं ये लिख लेता हूं, इनिशियली कैपेसिटर इज नॉट चार्ज, कैपेसिटर इज नॉट चार्ज, कि कैपेसिटर तो चार्ज ही नहीं है। अगर कैपेसिटर चार्ज नहीं है तो t इक्वल टू 0 प्लस पर क्या होता है, कैपेसिटर इज शॉर्ट सर्किट। याद रखो, इस कॉन्सेप्ट को रॉन्ग मत करो, इस कॉन्सेप्ट को याद रखना। अगर कैपेसिटर इनिशियली चार्ज नहीं है तो दैट विल बी अ शॉर्ट सर्किट, इनिशियली बता रहा हूं, इनिशियली। और यहां पर वोल्टेज हो गया 10 वोल्ट, यहां पर 10 वोल्ट हो गया, ये 10 ओम। मुझे फाइंड करना है करंट I जो इससे पास हो रहा है, ऐसे ही पास होगा करंट I, कितना हो जाएगा, मिली एम्पियर में निकालना है क्या, अच्छा 1 वोल्ट है, सॉरी 1 वोल्ट है, 1 वोल्ट है, 1 वोल्ट है। तो जो करंट I है वो कितना होगा, 1 डिवाइड बाय 10 एम्पियर हो गया, तो इट विल बी इक्वल टू 100 मिली एम्पियर, 100 मिली एम्पियर, ये होगा ना 100 मिली एम्पियर। बेटा सुप्रिया ओपन नहीं होता, शॉर्ट होता बच्चे, तो 100 मिली एम्पियर, तो ऑप्शन बी एंड ऑप्शन डी कैन नॉट बी द आंसर। अब पूछा है स्टडी स्टेट पे, स्टडी स्टेट पर क्या होता है, एट स्टडी स्टेट कैपेसिटर इज ओपन सर्किट, कैपेसिटर क्या होता है, ओपन सर्किट। तो उस केस में नेटवर्क कुछ इस तरीके से आ जाएगा, दो है, अच्छा, नेटवर्क कुछ इस तरीके से आ जाएगा। ये हो गया 1 वोल्ट, ये हो गया 5 ओम, ये हो गया 5 ओम, ये हो गया 10 ओम। आ गया आंसर। यहां पर जो आपका आई होने वाला है, जो यहां पर आपका आई होगा किसके इक्वल होगा, 1 डिवाइड बाय 10 प्लस 10 1 बाय 20 एम्पियर। मिली एम्पियर में चेंज करना है तो 1000 से मल्टीप्लाई करना पड़ेगा, तो 50 मिली एम्पियर आ जाएगा, 50 मिली एम्पियर। ऑप्शन ए, ऑप्शन है करेक्ट, एब्सोल्युटली करेक्ट। विक्रम ने भी आंसर दिया, ऑप्शन ए, ऑप्शन ए। जहां सेशन आपका कुछ लंबा चल जाए बच्चे ड्रॉप होना स्टार्ट हो जाते हैं। तो अभी तक हमने 10 क्वेश्चन सॉल्व कर लिए बेस्ड ऑन द नेटवर्क्स। आपको बचे हुए 5 क्वेश्चन हमें सॉल्व करने हैं। 80 क्वेश्चन आपके इसरो में आते हैं, तो बचे हुए 5 या 6 क्वेश्चन हम लोग देखने वाले हैं आपके मेजरमेंट्स के ऊपर, ठीक है। क्वेश्चन आपके सिंपल होने वाले हैं, ऐसा नहीं है मेजरमेंट से बहुत ही मुश्किल क्वेश्चन आ जाएगा, दैट इज नॉट ट्रू, सिंपल होंगे। ट्राई करो इस क्वेश्चन को, ट्राई करो इस क्वेश्चन को। ठीक है, ट्राई करो। A DC voltage with ripple is given by VT. Measurement of this voltage made by moving coil and moving iron voltmeter show the readings of V1 and V2 respectively. The value of V2 minus V1 is. The value of V2 minus V1 is. ठीक है, यहां पर थोड़ा कैलकुलेशन लेनी पड़ेगी। जो मैं क्वेश्चन उठा लिया इसका ऑप्शन नहीं है, बट थोड़ा सा कैलकुलेशन हम कर लेंगे, ठीक है। बट याद रखना, घबराना मत। इसरो में कैलकुलेशन की आप ट्रिक्स यूज करते हो, या तो कैलकुलेशन इजी होता है, ठीक है, तो वहां घबराने की जरूरत नहीं है। तो यहां पर क्या होगा, रिपल्स, ऑप्शन शायद मिस हो गया। देखो यहाँ पे याद क्या रखना है, याद क्या रखना है, ये जो 2 मीटर्स है ना, ये इंपॉर्टेंट है। मूविंग कॉइल और मूविंग आयरन, मूविंग कॉइल एंड मूविंग आयरन इंपॉर्टेंट क्यों है? जो आपका मूविंग कॉइल है ना, ये सिर्फ और सिर्फ डीसी मेजर करता है, ये सिर्फ और सिर्फ डीसी मेजर करेगा। और जो आपका मूविंग आयरन है ना, ये मेजर करता है आरएमएस वैल्यू, ये मेजर करता है आरएमएस वैल्यू। अब नेटवर्क आप लोगों ने करा है, तो आपको इस इक्वेशन की डीसी और आरएमएस वैल्यू निकालनी है। क्या आप निकाल नहीं सकते हो? ये तो नेटवर्क में हम लोग हमेशा सीखते ही है। वीटी क्या है, 100 प्लस 10 साइन ओमेगा टी माइनस 5 साइन 3 ओमेगा टी, 5 साइन 3 ओमेगा टी, ठीक है। तो यहां से मूविंग कॉइल की बात करूं, मूविंग कॉइल की बात करूं तो मुझे चाहिए डीसी वैल्यू। डीसी वैल्यू क्या होगी, जल्दी से बताओ कमेंट सेक्शन में। डीसी वैल्यू क्या होगी यहां पर, कमेंट सेक्शन में बताओ। व्हाट विल बी द डीसी वैल्यू हियर, व्हाट विल बी द डीसी वैल्यू हियर? इट विल बी 100, इट विल बी 100। डीसी वैल्यू कितनी होगी मेरे पास, 100। क्यों? बिकॉज यही तो डीसी कंपोनेंट है, आगे तो हार्मोनिक्स है, आगे तो हार्मोनिक्स है ना। अब यहीं पे मूविंग आयरन की बात करें तो वो क्या करती है, पूरी आरएमएस वैल्यू को कैलकुलेट करेगी, पूरी आरएमएस वैल्यू को कैलकुलेट करेगी। एक सेकेंड, जो डीसी मूविंग आयरन है ना, ठीक है, तो V1 एंड V2, द वैल्यू ऑफ V2 माइनस V1, ठीक है। तो यहाँ पूरी आरएमएस वैल्यू को कैलकुलेट करेगी, दैट विल बी इक्वल टू, आरएमएस क्या होगा, 100 प्लस 10 होल स्क्वायर बाय 2 प्लस 5 होल स्क्वायर बाय 2। यस और नो, यही होने वाला है। जल्दी से बताओ मुझे, ये वाला कॉन्सेप्ट समझ में आया? ये कैसे करा मैंने? ये वाला कॉन्सेप्ट समझ में आया कैसे करा हमने? एक बार मैं इसको सॉल्व कर लूं। 100 प्लस सॉरी, यहाँ पे 100 का स्क्वायर होगा ना, 100 का स्क्वायर होगा, सॉरी 100 का स्क्वायर होने वाला है, 100 का स्क्वायर। बाकी बताओ कॉन्सेप्ट समझ में आया कैसे करा? इट कम्स आउट टू बी 100.31, 100.31। तो यहां पर इन दोनों का माइनस करना है, तो 100.31 माइनस 100 कितना आ गया, 0.31। दिस विल बी द आंसर, क्योंकि ये आपका V2 है, ये आपका V1 है, ये आपका V2 है, ये आपका V1 है ना, सिंपल सी बात है। तो यहाँ पर कितना आ गया आपके पास? अच्छा, ऑप्शन नहीं दिया है ना, देखो ऑप्शन दिए होते ना तो आप ये आंसर इजीली सॉल्व कर सकते थे। ऑप्शन दिए होते आंसर इजीली सॉल्व करते, बिकॉज आप देखते कि एक साइड 100 है, यहां पर 10 है, यहां पे 5 है, तो 100 के सामने 10 और 5 की वैल्यू बहुत कम है, बहुत कम वैल्यू है ना। तो इसका जब आप आरएमएस निकालोगे तो वो 100 के पास ही आना है, बहुत पास आना है, इवन 101 भी नहीं जाना, बिकॉज इनकी वैल्यूज ना काफी कम है। तो 100 के पास ही आएगा। तो इसका मतलब एक तो 100 पता है, तो जो इन दोनों का सब्ट्रैक्शन होगा वो डेसिमल में ही आने वाला है, 0 पॉइंट कुछ समथिंग आने वाला है। तो अगर ऑप्शन देंगे ना, ऑप्शन में इसी तरीके से खेलेंगे, कुछ बड़े ऑप्शन दे देंगे, कुछ छोटे ऑप्शन दे देंगे, और एक ऑप्शन इस तरीके का। तो ये मत सोचना कि सर अब इसका स्क्वायर रूट कैसे निकालोगे, कोई नहीं निकाल सकता, कोई नहीं निकाल सकता स्क्वायर रूट। नेक्स्ट, द रीडिंग ऑफ वोल्ट मीटर इन वोल्ट फॉर द सर्किट शोन इन अ फिगर। वोल्ट मीटर कहां लगा हुआ है? वोल्ट मीटर यहां लगा हुआ है। सॉल्व करो। देखो क्वेश्चन मेजरमेंट का है, क्वेश्चन मेजरमेंट का है, लेकिन नेटवर्क का कॉन्सेप्ट यूज होगा। तो इस टाइप के क्वेश्चन आपके मेजरमेंट में आएंगे। क्वेश्चन मेजरमेंट का है क्योंकि वोल्ट मीटर बोल दिया गया है, बट नेटवर्क कॉन्सेप्ट यूज होगा इसके अंदर, नेटवर्क कॉन्सेप्ट यूज होगा। ठीक है, तो सॉल्व करो एक बार, इसका आंसर बता देना। ऑप्शंस नहीं है इसके अंदर, कोई दिक्कत नहीं है, बट आंसर बता देना। सबसे पहले बताओ, क्या यहां पर व्हीटस्टोन ब्रिज बन रहा है? कंडीशन ऑफ व्हीटस्टोन ब्रिज यहां सेटिस्फाई हो रही है, यस और नो? कंडीशन ऑफ सर्किट ब्रिज बैलेंस और नॉट? हाँ, ये चेक करो, बताओ, चेक करो। सबसे पहले चेक करते हैं। J1 मल्टीप्लाई बाय J1, J1 मल्टीप्लाई बाय J1 माइनस 1, 1 बाय J मल्टीप्लाई बाय 1 बाय J माइनस 1, तो वेरीफाइड, ये वेरीफाइड हो रही है। तो मतलब ये क्या है? व्हीटस्टोन ब्रिज है। अगर ये व्हीटस्टोन ब्रिज है तो इसका मतलब वोल्ट मीटर के थ्रू कोई भी करंट पास नहीं करेगा, वोल्ट मीटर के थ्रू कोई भी करंट पास नहीं करेगा। तो इस सर्किट को मैं सिंप्लीफाई कर सकता हूं। कैसे? ये आपके पास हो गया 0.5 ओम, जो ये है, उसके बाद यहां से जा रहा है J1, और मतलब करना चाहो तो कर सकते हैं, कोई दिक्कत नहीं है। इसको इस तरीके से कर लेते हैं ना, 1 प्लस 1 बाय J 1 0। ये आपकी मर्जी, आपको करना है करो, नहीं करना मत करो। अगर आपको वहीं से दिख रहा है तो कोई दिक्कत नहीं है। 1 बाय J, J यहां पर क्या है मेरे पास, J और 1 बाय J, इस तरीके से J और 1 बाय J। आपको मेजर क्या करना है? ये वोल्टेज आपको मेजर करना है, ये वोल्टेज प्लस माइनस V, ये वोल्टेज मेजर करना है ना। तो सबसे पहले मैं करंट फाइंड कर लूं, करंट कितना होगा? सबसे पहले मैं करंट फाइंड कर लूं। तो ध्यान से देखो, मैं 1 बाय J को क्या लिख सकता हूं? माइनस J। ध्यान से देख के बताओ, 1 बाय J को क्या मैं माइनस J लिख सकता हूं? कोई दिक्कत है इसके अंदर? बेटा वोल्टेज जीरो नहीं आएगा, करंट जीरो होता है। देखो बेटा ध्यान रखो, अगर आप कह रहे हो कि इसका आंसर जीरो है, रॉन्ग। करंट जो इसके पास थ्रू होगा ना, वो जीरो होगा। करंट जीरो होता है, वोल्टेज जीरो नहीं होता व्हीटस्टोन ब्रिज में, याद रखना। तो यहाँ अब देखो ध्यान से यहां पर कि इसको सॉल्व कैसे करना है। ये माइनस J प्लस J, इट विल जीरो, इट इज ऑल्सो जीरो, इट इज ऑल्सो जीरो। तो जो ब्रांच का रेसिस्टेंस होगा या इंपीडेंस होगा वो जीरो हो जाएगा। तो यहां से करंट कितना होगा? करंट इज इक्वल टू, अच्छा ये 100 साइन है, ये 100 साइन ओमेगा टी है। तो करंट इज इक्वल टू 100 डिवाइड बाय 0.5 साइन ओमेगा टी, 200 साइन ओमेगा टी। ये हमारे पास करंट फ्लो कर रहा है, दिस इज आई, ये मेरे पास करंट फ्लो कर रहा है। अब देखो दोनों शॉर्ट सर्किट है, दोनों का रेसिस्टेंस आप कह सकते हो, इंपीडेंस कह सकते हो, सेम है, दोनों का इंपीडेंस सेम है। तो अगर आई जा रहा है तो यहां भी I/2 और यहां भी I/2 जाएगा, बिकॉज दोनों का इंपीडेंस क्या है? जीरो है, दोनों का इंपीडेंस जीरो है। तो I/2 और I/2 जाएगा। तो क्या मैं यहां से वोल्टेज नहीं निकाल सकता? सिंपल निकाल सकता हूं। यहां पर KVL लगा दो, KVL लगा दो, माइनस J I/2 प्लस I/2 मल्टीप्लाई बाय माइनस J प्लस V इक्वल टू जीरो। V कितना आ गया? I/2 I मल्टीप्लाई बाय J, I मल्टीप्लाई बाय J, I कितना मेरे पास? 200 साइन ओमेगा टी। तो मतलब 200 एंगल 0 मल्टीप्लाई बाय 1 एंगल 90, V कितना आ गया? 200 एंगल 90 डिग्री वोल्ट्स। बताओ यही आएगा? यही आंसर आएगा? जल्दी से बताओ, किसी को कोई भी डाउट हो पूछ लेना। स्पीड में, स्पीड इंक्रीज इसलिए है जिससे पता चले इसरो में कैसे कितने टाइम में सॉल्व करना है आपको। बट क्वेश्चन क्या पूछा है? आरएमएस। क्वेश्चन क्या पूछा है? आरएमएस। वो क्या आ रही है? मैक्सिमम वैल्यू। वो क्या आ रही है? मैक्सिमम वैल्यू। बेटा साइन में रख लो सुप्रिया, बिकॉज यहाँ पे सप्लाई साइन में है, तो आप साइन में इसको पुट कर सकते हैं, कोई दिक्कत नहीं है। तो यहां से आरएमएस वैल्यू कितनी आ जाएगी? आरएमएस क्या होती है? मैक्सिमम बाय √2। 141.4, रूट ए रूट 2 141.4 सिंपल आंसर। ठीक है, देखो विदाउट कैलकुलेटर का यूज करके आप सॉल्व कर सकते हो, बिकॉज यहाँ पे कॉन्सेप्ट है, वो चेक करे कि आपको व्हीटस्टोन का कॉन्सेप्ट पता है या नहीं। व्हीटस्टोन का कॉन्सेप्ट पता है, कैलकुलेटर उठाना ही नहीं है, सिंपल शॉर्ट हो रहे हैं, सिंपल सॉल्व कर दिया। ठीक है, नेक्स्ट 2 watt meters which are connected to measure the total power on a 3-phase system supplying a balanced load which is reading this and this. The total power and the power factor respectively are. KVL रॉन्ग हो तो यही गलती होती है, KVL और KCL जो बेसिक चीज है वो रॉन्ग हो जाती है। पूरा क्वेश्चन पता है बट बेसिक चेंज होती है। KVL बताओ एक बार फिर से, KVL बताओ। देखो KVL कैसे लगाओगे, देखो एक बार मैं इसको दिखा देता हूँ KVL कैसे लगाओगे यहाँ पर। देखो यहां से कितना करंट जा रहा है, I/2। इस करंट की वजह से पोलैरिटी क्या होगी, प्लस माइनस। यहां से कितना करंट जा रहा है, I/2, इसकी वजह से पोलैरिटी क्या होगी, प्लस माइनस होगी। शिव काइंडली स्पीक इन इंग्लिश सर बेटा। शिव यू शुड टेल मी दिस इन स्टार्टिंग ना। आई थॉट everybody are familiar with Hindi ना। Okay, from now I will speak in English. So this is I/2. Now how you will apply the KVL? You can move in this particular loop. If you move in this particular loop, you can see the minus sign here. So minus J multiplied by I/2. Moving further, plus I/2 multiplied by minus J plus V. So in this way, we can apply the KVL, right? Simple. Now next question. 2 watt meters which are connected to measure the total power here, are balancing. So this is a 2 watt meter method. If you have done measurements in your colleges and all, so you have learned about the 2 watt meter method. In a 2 watt meter method, you need to remember two things only, that the total power is W1 plus W2. Total power is W1 plus W2, summation of both watt meters value, and also the power factor angle is equal to tan inverse W1 minus W2 divided by W1 plus W2. These two formulas you should remember in case of a 2 watt meter method. Okay, now if you are from P or EC students and you haven't heard about this method, then don't worry about it. There are multiple things you haven't heard about the measurements, so you can skip it. But if you have heard, then this is one of the important topics from a measurements from where question can come. Okay, so what will be the value here? So first of all, we have given 10.5 and minus 2.5. 10.5 and minus 2.5. So it will be 10.5 minus 2.5. It comes out to be 8. It comes out to be 8 kilowatt. So 8 kilowatt, so option A and B cannot be the answer. Next, power factor. So for that, I need to find out the power factor angle. Tan inverse W1 minus W2. So it will be 10.5 plus 2.5 divided by 10.5 minus 2.5. So it will be tan inverse 13 by 8. Tan inverse 13 by 8. Now what will be tan inverse 13 by 8? Let me solve quickly. It comes out to be 58. Power factor of 58 is equal to cos pi na. What is the answer here? Power factor of 58 is approximately 0.52. Cos of 58 is approximately 0.52. 0.52. So option C is the right answer. Option C. D nahi hai beta. Option C is the right answer. Option C is the right answer. Okay. Now next question. Now this question seems like a measurement question. The question is also the measurement question, but if you know the concept of networks, you can solve this question easily. If you know the concept of network theory, so try to solve this question. So that's why I'm telling you, if you know the concept of network theory, most of the questions from measurements can be solved. Okay. So Ankit is deleting the answer. But don't worry if you're giving a wrong answer. The main point is you are participating. That's the important point. Okay. Don't worry. Everyone can be wrong. So here, a single phase load is connected between the R and Y terminal of a 415 volt symmetrical 3-phase 4-wire system. Sir, will the problem can be asked? Yes, beta. They can ask you. They can ask you from a polyphase. Matlab 3-phase. You are asking about the 3-phase, Vikram. So yes, they can ask you from a 3-phase. Okay, but not many questions they are going to ask. So I will advise you. In a 3-phase system, you should understand what is the star formation, delta formation, and what is the basic relation between line and phase voltages and current. That much you should remember, and how to find out power. That much only. That will take approximately 1 hour to understand all of these things. So it will help you not only for ISRO exam, for the other AEJE exams also. So we need to find out the wattmeter. What will the wattmeter will read? Now, one thing you should understand about wattmeter, that wattmeter reads the real power. The wattmeter reads the real power. So if they are saying what will wattmeter reads, I need to find out the real power only. VI multiplied by cos phi. VRMS, IRMS cos phi. I need this thing. Wattmeter reads the voltage and current and the cos phi. Okay. Now, since we have given RYB, this is a 3-phase question. This is a 3-phase question. So this is for the single phase. This is for the single phase. What is the 3-phase power? 3-phase power is √3 times of line voltage, line current, cos phi, or other formula is 3 times of phase voltage, current, phase current, cos phi. These two formulas we can use. Both are the same. Both are same. Okay, one is line, one is phase. Okay. Now let's find out all of these value. If you see one point, the power factor is already given. It's 0.8 lagging. No need to find out the power factor. It is already given. So we need to find out line RMS voltage. We need to find out line RMS. Now here you can see this is the phase R. This is the phase Y. Now between the phase RY, the voltage connected is 415. So this will be the line voltage. This will be the line voltage. So line voltage here is equal to 415. So wait a sec. My fault. Power. This 0.8 is the power factor of load. My fault, guys. 0.8 is the power factor of load. My fault. This is the power factor of load. So it will be 415 angle 30 degree volts. So this will be the line voltage. Any doubt how we write the line voltage like this? Tell me. If you have any doubt how we have written down the line voltage, then ask me. 415 angle 30. Why? Because always remember the voltage which is given in a 3-phase system, it's always a line voltage. First point. Second, in a line voltage always leads the phase voltage by 30 degree. So that's why it is 415 angle 30. Okay? Now the impedance Z is equal to what? Impedance Z is equal to 100 angle 0.8 power factor lag. So 0.8 power factor, you should remember the value. For the 0.8, you should remember the value 36.86. 36.86 degree ohms. Now what we need to find out? We need to find out the current. Okay. How you can find out the current? You have a voltage. Achha, one point you need to understand here. Let me check one point. Let me check one point here. That, okay. Now one thing you can see. This is the line current I want. And here we have a phase voltage. Remember this. This is the line current we want and we have a phase voltage here. So let's find out the line current. Line current is equal to the voltage here. Voltage between RY divided by impedance. You know? Voltage RY divided by impedance. Voltage is 415. 415 angle 30 divided by 100 minus 36.86. So it comes out to be 4.15 angle 66.86 ampere. 66.86 ampere. You know? Any doubt here? Any doubt here? Simple V by Z. Yes, Supriya, absolutely correct. Simple V by Z we have find out. Now, what is the phase voltage? What is the phase voltage? VB. What is the phase voltage? It is equal to 415 divided by √3 angle minus 120 degree. This will be the phase voltage. Any doubt? Finally, power. For the power, I need to find out power factor angle. I need to find out the power factor angle. So power factor angle will be 66.86 minus 120. So it comes out to be 186.86 degree. 186.86 degree. So if you want to find out the power, it is equal to 3 times of phase voltage. Phase voltage is 415 root 3. Then we have a current here 4.15 multiplied by cos of 186.86. So it will give you approximately minus, this is minus actually, minus 597 watt. Minus 597 watt. You can solve it. Approximately you will get minus 597 watt. This is minus here. Okay. So simple है. Voltage और current find करो. Once you find out the voltage and current, you can solve the question easily. Once you can find out voltage and current, you can solve the question easily. Now, second last question, 79. The AC bridge shown in a figure is used to measure the impedance Z if the bridge is balanced. The frequency F equal to 2 kilohertz, then the impedance Z will be. Again, the question is of measurement, but the concept we are going to use here is of network theory, or you can say the mixed concept, because the bridge is balanced. Whenever the bridge is balanced, the product of opposite impedances are same. The product of opposite impedances are same. Yes or no? Tell me, guys. So here I can say, because the bridge is balanced. Tell me, am I audible to you guys? Yes or no? Am I audible to you? Yes or no? Audible हो? ठीक है. Because watching एकदम ही बंद खत्म कैसे होगी? Okay, there is some mistake here. Okay. So ZAB is equal to 5. ZAB is equal to 500 ohm. Okay, fine. ZAB is 500 ohm. ZBC is equal to resistance 300 minus 1 upon omega C. तो मतलब 2 pi into 2 into 10 is to power 3 multiply by capacitance 0.398, 0.4 ले लो, 0.4 into 10 is to power minus 6. 398 है ना, 0.398. You can take it as a 0.4. You can take it as a 0.4. So what? Minus J. So what we will get here? Don't worry about calculation. ठीक है? This type of calculation will not come, but whenever the calculation will come, it will be a easier calculation. So let me use the calculator. It comes out to be 10 raised to power 3 minus J 200. Minus J 200 ohms. This will be ZBC. This will be ZBC. Now let's talk about ZAD. ZAD. It is equal to how much? 300 plus capacitor. नहीं. Okay, ये microfarad है. Sorry, this is a capacitor. This is a capacitor. This is a capacitor here. 15.91 microfarad, no? 15.91 microfarad. So it is actually a capacitor. So it will be minus J divided by 2 pi into 2 into 10 is to power 3 into 16 into 10 is to power minus 6. Again, because it is given 15.91, so I have taken 16 just for the approximation. There is no mistake in this type of approximation. 2 pi, sorry, my fault, 2 into 3.14 into में 2 into में 16. ठीक है? It comes out to be only 300 ohm. Okay, so this will be the result. So finally I can say ZAB multiplied by ZCD is equal to ZBC multiplied by ZAD. ZBC multiplied by ZAD है ना? ZAB कितना है? 500. ZCD कितना है? CD that we need to find out. ZBC कितना है? 300 minus J200. 300 minus J200 and ZAD कितना है? It is 300. It is 300 है ना? तो Z कितना आ गया? 0 0 3 9 by 5 minus J 3 तो 6 by 5 है ना? तो कितना आ रहा है? 5 9 1.6 नहीं, सॉरी 1.6 रहेगा नहीं 1.8 है ना? इतने आ रहा है 1.8. हाँ, माइनस J 1.2 इतने आ रहा है Z शायद. हाँ, Let me check. 1.8. Acha, there is some mistake here. Is there some mistake? Can you check the calculation, guys? I guess यहाँ पर कोई mistake. I guess there is some mistake in here because they have produced a capacitor. But let me check the calculation once. 0.14 into 2 into 0.4. 1 divided by answer multiplied by 1000. So this is correct. Let me check that one. This is that idiot. This is also correct, right? So I guess there is a mistake here. There is a mistake somewhere in a particular resistor or something here. Otherwise, the question will be correct. No doubt. I hope you have understand the concept. Let me check this also. 500 multiplied by Z and this and this. So 0, 0, 3 by 5. 9 by 5, 6 by 5. Okay, no problem. Concept you understand, na? Concept you understand. That's the point. Now, last question. Moving iron instrument are scaled at what? Moving iron instrument are scaled at what? Linear, exponential, non-uniform, logarithmic. मतलब क्या होगा? Moving iron instrument are scaled at what? Simple question है. One mark question. Exponential? No, exponential answer नहीं है. The answer is non-uniform. If you are familiar with the moving iron, the moving iron reading is directly proportional to I RMS square. Now what happened? For the smaller values, the square values are very, very near to each other. For example, if you have a 0.1, the square is 0.01. If you have 0.5, the square is going to be 0.025. है ना? Sorry, my fault. 0.25. You have a square of 0.25. But if you have a value of 10, then 10 whole square is 100. So here you can see when the values are very small, very, very small, the square is very, very small there. Okay. But the value become more than 1, then the square will become very large. So what happens? There will be a cramping. The word is cramping. There will be a cramping at lower side and there will be a space at higher side. That's why the scale is non-uniform. This question has been asked multiple times in ISRO level examination like ESC, like DMRC, NMRC. Okay. So guys, this complete your mock test for ISRO for today. I hope you have enjoyed the session. If you haven't watched the complete session, I will advise watch the session by increasing the speed. Okay. So we will end our session here. Before that, let me give you one information. Wait a sec. That we have already started the GATE 2024 crash course. If you haven't enrolled in this crash course, you can enroll it. And again, you can prepare well and score well in your upcoming exam. Ankit, you can expect approximately 6 to 8 questions. And out of 6 to 8 questions, I can tell you that average student can give the answer to 4 questions. Because if there is a pure core measurements, then obviously you cannot give the answer. But in the questions like in which you have to use the concept of networks, then you can give the answer easily. Okay, so try to achieve at least 50% question of the measurements in the examination. They will give you approximately 6 to 7 question only. Thanks, Vikram. Supriya, aptitude session will also come. And as you know, Rakesh sir is taking the aptitude classes regularly. From there also you can do the aptitude. But it depends on how much you have done. From zero, no beta, from zero it will not possible. Frankly, from zero it will be not possible. Okay. Okay guys, so bye, take care. So updated now. With this, we will bring more sessions like this for the ISRO and GATE examination. So all the best for your exams. So bye guys, take care.